With Python being so easy to learn and having really powerful capabilities, it seems to be the dominant choice for new learners and industry professionals alike. Machine learning and Python are like peanut butter and jelly, an unbeatable match. You don't even have to have much experience in the technical industry to learn either of these topics. With these skills in hand, many people go on to work in companies like Netflix, Goldman Sachs, and Deloitte. A series of tutorials like ours is enough to get you started on your journey to becoming proficient in machine learning and Python. Who knows, you might be the next industry expert. This course consists of different aspects of machine learning as well as Python. So we have got three amazing faculty members, experts in their own right, to help you get started with this discipline in a comprehensive manner. They are Dr. Abhinanda Sarkar, one of the top 10 data science academicians in India, Dr. Narayana Darpaneni, an IISc postdoctoral fellow, and Mr. Raghuraman, a big data expert. Now, before we start off with the session, I'd like to inform you that we will be coming up with a series of high quality tutorials on artificial intelligence, data science, and so much more. So don't forget to subscribe to our channel and hit the bell icon to get a notification every time we upload a new video. If you like this tutorial, don't forget to click on the thumbs up icon and comment down below what you'd like to see next. Here are the topics we will cover in this tutorial. First, we will get you to dip your toes in some programming with an introduction to Python and Anaconda. Then, we'll cover different libraries in Python, including Pandas and Numpy for data processing and manipulation. After that, we shall see how we can visualize data in Python using libraries like Matplotlib and Seaborn. We will then get into a statistical approach, understanding how statistics is different from machine learning and the different types of statistics. An understanding of data, how it is distributed, how it can be measured, and how it can be represented will get you right on track to handle machine learning algorithms that come your way. Moving forward, you will be introduced to reinforcement learning, its principles, and its framework. Then, we will learn about Q tables, Q learning algorithms, and a case study of a smart taxi to help you understand reinforcement learning better. Let's get introduced to the teachers of this tutorial. Dr. Abhinanda Sarkar received his PhD in statistics from Stanford University. He has taught applied mathematics at the Massachusetts Institute of Technology. He has also been on the research staff at IBM. Dr. Sarkar has also led quality, engineering development, and analytics function at GE and has co founded Omics Labs, a biotechnology startup. Dr. Narayana Darpaneni has more than 11 years of industry experience and over 4 years academic research experience. Over these years, he has worked as a professor, trader, project manager, team lead, and developer. He has completed his PhD in mathematics from Pierre and Marie Curie University and his MSc and BSc in mathematics from Pondicherry University and Sri Krishna Devaraya University, respectively. He was also a postdoctoral fellow at the Indian Institute of Science. His areas of expertise include machine learning, optimization, financial engineering, and high frequency and algorithmic trading. He has published over 10 research articles in international journals and conferences. Mr. Raghuraman is a big data and AWS expert with over a decade of training and consulting experience in AWS and Apache Hadoop ecosystems like Apache Spark. He has an impressive resume, having worked with global clients like IBM, Capgemini, HCL, and Wipro. To top it all off, he has worked with many Bay Area startups in the US. With that, let's get into this machine learning with Python course. It's time for some great learning.
So, like Rajeshri said, my name is Raghu. So I have been working for about 12 years as of now. I started as a developer, Java developer basically, and then moved into something called big data. So I have been a big data developer for quite some time, and then moved to machine learning because the industry changes, right? You can't stick to one thing. And I also teach and practice a bit of cloud computing with Amazon Web Services, right? So that's what I do. And currently I work as a consultant for some of the companies. I help them in solving their problems and giving them advices as to what to do, etc., etc. And I also train people. So with Great Lakes, as of now, most of my training sessions are into Python. That's what we are going to do, and statistics as well as ML. So these are the areas where I usually train in Great Lakes. We also have a separate program called Big Data on Cloud. So which is also, I'm also one of the mentors for that program. That's a totally different program, not your program, but I was one of the co-author for that program and also mentor for that program. So there we mostly deal with cloud and other kind of technologies, right? Well, so let's get into what we are going to do, right? So the idea is, this is called Introduction to Python for ML. So I think from the industry session, you could have got some idea about, you know, what will be the future, right? What you're going to learn over the period of time. So see, when somebody pick up the track of machine learning and, you know, start to learn what is machine learning and all, it's really important that you need a programming language. That is for sure, right? So whatever you want to do, you depend on a programming language. And there are many languages, like you could have heard about R. There is a language called R, and SAS, and we also have Python. So we will be using Python throughout the course, right? So, and you may ask, like, why are you like teaching using Python? Why don't you just use R or any other language? Well, Python as such has some advantages, because if you look at a language like R, for example, that is only used for this data analytics kind of jobs, whereas Python is a universal language. You know, you can have web development in Python, or you can do any sort of programming in Python, not only related to your machine learning. So when you go to the industry and when you start working with real projects, right? So maybe you are doing some sort of an ML project, but that project also has a part where, you know, you are probably building a web application or making an API call or something like that. So there Python will become handy. So you learn one language which can be used in many places actually, and that is why we are using Python basically. And the second reason obviously is that it's sort of like very easy to learn. So many people are like confused. I'm not from a programming background, and also probably my programming is not so good as the other guy. So Python is very easy to learn compared to other languages. And if you are comparing it to something like Java or something, it's pretty easy, right? Because I have been working as a Java developer. So basically my skill set is Java, Scala, Python. So I also work on Scala, which is one of my primary skill set, and then Python. So when I compare this together, then, you know, learning Scala or Java is very difficult for you. So that is why we have Python as a primary language. And also Python has a support for a rich set of libraries, which probably I think the person could have explained to you. So, and what we will be doing today and tomorrow is we are going to learn practically. So there is no point in, you know, talking about the history of Python and what is Python for 4 hours. Nobody is going to learn anything end of the day. So I also have slides, but I think even that is pointless. Like, you can just run some slides and explain, but some concepts are important, but majority of the thing we'll be doing practically. And did you get a chance to go through the LMS and see what is there for the prerequisite or something like that? Have you guys went through the LMS by any chance before coming to the class? Yeah, so there is a Python prerequisite. I don't know how many of you have gone through that. So there is, the first thing that you need to do is that you have to install something called Anaconda. And have you installed it actually? Yeah, okay, so that's good. So see, when Python is open source, by the way, so you can just go to the Python website and download Python. That's one way of working with Python. But that is not really useful, because if you're downloading the open source Python, just original Python, it will not come with any libraries for you. So usually what we do is that we prefer this distribution of Python called Anaconda. So Anaconda is nothing but a distribution of Python. So basically when you download and install, you will be getting Python. You will also be getting some of the libraries which are very commonly used with Python. And it is very easy to update, and if you want to add any other libraries, you can do it in Anaconda. So Anaconda is one of the most famous distribution of Python. We also have another thing called nthought canopy. There is something called canopy. That's another distribution. Well, canopy is not very popular like Anaconda, but I have also, they're similar. I mean, the only difference is that the name and the project, but end of the day, if you download canopy also, you get Python, same thing, right? No, this is like a distribution which comes with, I'll show you certain tools inside that. So one thing you will be getting is Python for sure. Then you will be getting the libraries related to Python. Then you will get an IDE for Python. like Eclipse you have for Java, right? So very similar to that, you have a IDE called Spider for Python. So if you are using Anaconda, you'll be getting Spider and some debugging tools extra like that. But end of the day, they are all open source. It's not like any proprietary thing that you are using, but it makes easy for you to download and install. So we'll be using Anaconda for our all the hands-on practices. So this is a prerequisite. You need to install Anaconda, and then I will show you what to do once you have installed it, how to test it, and I will show you for something. And then we will be using Python 3. I don't think this requires any explanation, but we have a version called Python 2, which is an old version. Python 2 by 2012 or 2013 was officially removed from the community. Not removed, the support was removed. So Python 2 no longer exists actually, but in some of the older projects we still see Python 2, people writing the code. What we are using is Python 3. There is no major difference as such, some small syntax differences and performance improvements in Python 3, but everywhere people follow Python 3 these days, right? And now how are we going to learn Python? So one thing you need to understand is that you are going to learn Python in the aspect of data science or machine learning. You are not going to learn Python to create a website, for example. That's different, right? So you will be learning Python specifically for data science or machine learning, which means when you start learning Python, there are certain libraries in Python which you might have to make use of. There is a library called Numpy, something called Numpy, and then there is something called Pandas, and then there is something called Seaborn. Now you don't have to really remember them, we'll cover them anyway. And then there is something called scikit-learn and all. So what are these things? These are all libraries which you can download and install along with Python. And the good news is that when you download and install Anaconda, all this will come by default, like free. So you don't have to separately go and download them, right? And in this, so this is actually your domain. For the rest of the year, you will be playing here. So this is where you're going to actually work, or at least 70 to 80% of the time. I'm talking only about ML. When you go to deep learning and all, it will be different, but usually in the ML side, this is where people play around, right? And in this, so what are these things, right? So Numpy is a library which is called a numerical Python, and this is used for things like numerical data processing. For example, I can have things like 2-dimensional arrays, 3-dimensional arrays, multi-dimensional arrays and all. So mostly for scientific calculations and all, you need to represent your data in the form of an array. So you know what is an array, right? An array is just a collection of numbers. I can just say 1, 2, 3, 4. This is called an array. Well, this is technically a list, but so something like this is an array actually, a collection of numbers. Now this is 1-dimensional, right? Now I can also have 2-dimensional and 3-dimensional and even more than 3-dimensional ways of representing the data. And if my project requires that my data needs to be represented in that fashion, and then I have to do some manipulation on my data, we use a library called Numpy. So we will touch base on Numpy and you will understand how this is happening. And if you're thinking about this image processing and all, which you will learn later, but imagine you want to do something like image processing. So end of the day, what happens when you read an image or something, it will be converted to bits and bytes basically, right? So you know that, right? So if I have a JPEG file, I will read it as an image, but when I want to process it, I cannot just process an image. What I will do is I'll convert it into numbers, basically ones and zeros. So, and then I will be using this Numpy arrays to load that data and then do matching and classification or whatever you want to do. So Numpy arrays and all are very important when it comes to your deep learning, image classification, in some of those contexts. Maybe not immediately you will not work on Numpy, but a basic knowledge on Numpy will be actually helpful for you in the future, right? So this is one thing.
One question. Numpy, more than 2 dimensions, can you work on?
You can. So I will probably explain that. So naturally the question will be that how does the 4th dimension look like? Are you Christopher Nolan, right? I mean, obviously. So yeah, so obviously people will ask, right? So 2-dimension, you know what it is. What about 3-dimension? That also people can imagine. What about 4-dimension, right? So then the discussion goes to a different track altogether. But yes, you can actually visualize 4 dimensions. I can show that actually. It's not a big deal. It's not rocket science. It's very simple. But in some of the scientific calculations, we need the data in the form of 4 dimensions. And then you do additions and subtractions on the data. So you need a different type of data structure to represent that. Your normal data structures cannot define 4 dimensions or 5 dimensions. That is when we say we'll use Numpy basically, right? And in your projects or upcoming sessions, these will be explained further whenever it comes to the point of Numpy, right? And this Pandas, this is what we will be starting today our analysis with. It's called Pandas, okay? So Pandas is a library for sort of like labeled data analysis. So you guys are familiar with Excel, right? Excel sheets. So the same thing in Python is Pandas actually. You have labeled data like rows and columns, okay? And then you want to process the data. So I have probably a data set with 1,000,000 rows or 10 million rows, and I want to find out something from that. So probably if I use Excel, it may not be a good idea. So in normal calculations, Excel is fine. But if my data set is like, 10 million, 20 million rows of data, then that actually makes a problem. So we had a customer. I was working with this Mercedes-Benz, Merck, right? So they were one of our customers from Germany. So Merck actually what they do, all their cars are having this sensor thing. So they make weird cars, right? So if you look at a Mercedes-Benz S-Class, it is one of the safest cars in the world. Why? Because it has around 200 different sensors on the car. So what they do, they collect this sensor data. When the car is moving, it will track the acceleration, brake and pedestrians and everything they will track using the car. So this sensor data they collect. So imagine the car is moving, like if I'm traveling for, I don't know, probably 3 hours, it will collect the data. So this is text data and this will be in terabytes. The text data that you get, normal text, will be in terabytes. So like more than billions of rows. But we can't help it, right? Because sensors will keep on, every second or even less than that, they'll keep on tracking the motion of the car or what it is doing, and they have to collect it. And at the end of the day, their problem is like, I want to analyze it and then probably make a machine learning model. So if I'm giving you such a file, for example, I'm giving you a text file or a CSV file where I'm saying that there are 100 billion rows. And obviously, you cannot load it in an Excel sheet. It doesn't even work that way. So that time we come to this Pandas. Pandas is one of the libraries which helps you to do that. There are other libraries also, but Pandas is most common. So where you work with the labeled data, you have rows and columns, and then you can have selection, filtering, indexing, grouping, joins, anything that you normally do on a data set. So we will be spending a lot of time on Pandas as such. So this is one place where we need to spend. Matplotlib, this is used for visualization. Like I want to draw a graph. So it's very important to tell a story to your customers, right? So when you have a customer, so he will give you some data and then you want to talk to your customer. So you will analyze the data, and usually what we do is that it's very rare that we use Matplotlib directly. We use a library called Seaborn. The Seaborn is built on top of Matplotlib basically. So this is the guy we actually use for visualization, where you can have nice graphs, bar charts, pie charts or scatter diagrams or box plots or any type of plotting you want to do. But then you will be thinking that, hey, this is very similar, even I can do what plotting and all. So how do you normally, if I ask you to write a plot or create, what tools will you use? I mean, apart from Python in your data, Excel or probably PowerPoint or something you will use, right? But the difference here is that these libraries, the Seaborn, Matplotlib, they allow you to do statistical plotting. For example, I have a set of data. I want to calculate the mean, median and standard deviation, and based on that I want to plot, or I want to include those properties, then they will allow me. So it's not like a normal XY plot that anybody can do. I don't need Matplotlib for that, right? So these two libraries have to do a bit with your statistical side. Now the problem is that I will cover Seaborn tomorrow for sure, but actually in order to completely understand Seaborn, you need to have some statistics base. Your statistics class will start only tomorrow afternoon. My class is in the morning actually. So, but we will cover it so that you will understand what it is. And also visualizations initially you will not be touching a lot. as you proceed, the respective topics that will be covered, what sort of visualization you are using. So these two are basically visualization, and scikit-learn is where you apply actual machine learning. So scikit-learn is your primary library for all the ML algorithms that you will be using, right? So after the next month or so, when you actually start learning machine learning, most of your machine learning algorithms are inside this library called scikit-learn. So I will not be touching scikit-learn because that is a whole course actually. So I will be, my job will be to cover basically pandas mostly, and then matplotlib and seaborn in one, and a bit of numpy, and that is a job given to me to at least give you a basic idea. And again, if you look at say something like pandas, the topic is very exhaustive. So it is not like I'm going to teach you everything about pandas in 3 hours or 4 hours. That's impossible, right? So the way we do this is like I will be covering the basics of all of this today and tomorrow, and Sunday you have a practice session. So normally we have a practice session where somebody will be coming to assist you. So you will have some questions to be solved, and answers will be there, and you practice. And then the good news is like your next class will be after a month, and that class will be a statistical class, not a Python class. Then the technical class, well, statistics is also technical. The next class will be after 2 months actually, when you start ML. So you will get around 2 months to go through what I have taught you basically, right? So that will give you enough time to pick up Python. If somebody is thinking that okay, I need some time to learn Python or get some idea, you will get a good amount of time to pick it up, right? And yeah, sorry, yeah. So one thing is that, so I don't want you to immediately pick it up. So normally trainers will not say like this, but I don't want you like today you go home and like shut up, I'm going to learn Python for 3 hours now, and then only I'm going to talk to anybody, right? So it's not like that, right? So you can't learn it that way. So today and tomorrow, mostly I want you to pay attention and understand what we are doing. You are not really learning anything, right? And then the Sunday class will give you some more idea. Then I'm going to share you a set of assignments and practice and solutions which you must do. And I'm also going to share some learning material over the period to cover, right? So the idea is like you are all working professionals. So you spend some time every day, probably, half an hour or 15 minutes. That's more than enough for you to get prepared for Python. And of course, in the ML classes, Python will be used in a different way. So in ML classes, you will be having pandas for sure, but then pandas is used. Okay, I forgot. So in the last class, there was a small confusion. So I take regular classes, but see, this whole thing, what we are doing is called EDA. And I don't want you to forget this name. There is a reason behind this. It's called exploratory data analytics. Why? This is funny actually, because in the last Python class, I taught all this, but I didn't say this name. So in the next class, the trainer said, okay, all of you completed EDA. They said, no, the trainer did not teach a single line of EDA, and the other guy got confused. He immediately called me. What did you do for 8 hours? Did you actually skip your class? I'm going to check the recording. I said, no, I didn't skip. I taught all this. No, the participants are saying they didn't even learn a bit of EDA. So remember the name. If somebody asks you, say you learned at least. See, I am also doing a job, right? So great learning is like, okay, this guy came last time. I know he was in the class, but what he was doing, we should probably check the recording. So in Chennai batch, it happened actually. No, I mean, it matters sometimes, So this is called EDA. Why this is called EDA? Because usually in a typical machine learning project, what you do is that you first collect the data, whatever data you have, and then you do this part called EDA, exploratory data analytics. There is a slide probably I will show you, which will be very consoling for many of you, because a lot of people were concerned that I have to do a lot of programming now. So after learning all this ML, when I get a job, I have to sit and program. So there is a slide which is not just a slide. Around 70 to 80% of the time in a ML project, you are not really sitting and programming. You are just trying to understand your data, and that's true. I mean, I'm not making this up. So when you start an ML project, the problem is like, so we had a project on the New York Children's Hospital. We were working on a project from the New York Children's Hospital. So there, it's a children's hospital, right? So they were trying to detect early cancer in children. That is a project. So end goal is like you should, figure out if given a patient, what is the probability this patient will get cancer or not. So that is the end goal of this project actually. So we know this is the project and we know, okay, this is what we need to do. But the real challenge is that if I need to do this, what is the data that I'm going to look at, right? So then you start understanding. So first thing is that you understand the domain, because I had no clue about the healthcare domain or specific to cancer. So then you understand, some aspects of the domain, like what is cancer, what causes it, what are the factors which influences it, does age actually influences it. So this will take roughly around 1 to 2 months to understand the domain and the features of our data. Then you talk to the hospital and the doctors and try to collect the data. So initially you may not get enough data, you will just get the patient records, which will have their age, weight and statistics, and then you ask for more data. So the more data you get, the more features you can get from the data, and that will impact your ML model. So actually doing this ML is not a very big deal as you are thinking about, because you have an algorithm to do this, right? So probably in the morning you would have discussed. So for every machine learning problem, we have an algorithm which can solve the problem, right? So all you need to do is call the algorithm, give the data, algorithm will give you the result. It's probably 10 minutes job, really, right? So it's not like very complicated. But before you call the algorithm, you should have the right data in the right format to feed to the algorithm. Then only it's going to give you the expected result. So majority of the time, the data scientists are spending in understanding the data and seeing if I can collect other varieties of data, then what features I can extract. So initially we were getting only patient records, okay, and then we built a model that was not very powerful. It was giving results, but it was not really what the center was expecting. And then we had further discussions, and then they said we will also share some more data, okay, which is not directly related to cancer, but some of the things which may affect. For example, we started looking at gene patterns and all. For example, if there's a study which is going on which proves that it can be hereditary. Cancer is not hereditary actually, but what is the effect of that, right? So then that is a whole different question. So now you need that kind of a data where the person's hereditary details, his genome data, father, mother details and all this. What is the history of cancer in the family, right? So then how do you represent that data? So this is majority of the time we are playing with the data. That is this EDA part. So once your data is finalized and you have an idea, okay, so this is what I want, calling the ML algorithm is not a big deal actually. Everything is already written. If I'm calling a regression algorithm, it's already written. I'm not writing anything. Just passing the data, I'm getting the output. But then I validate, is this correct what I'm doing? So if that is not correct, then I need to again rebuild my data and then train my model and all. So that is why this EDA part is very important, because you have to collect the data and then look at the data and extract certain features from the data and then compare it. That is where this EDA becomes very useful. These are not the only EDA methods. There are further methods as well, which you will cover later. These are some of the basic EDA things that we do usually.
How much accuracy level you take, whether your model is refined or?
So that project actually got on hold, but we went up to 96-97% accuracy levels in that. So right now that model is not running, but we were able to achieve. I was not actively a contributor in that project, but I was helping them since that was a new project actually. But we were able to get a good accuracy level in that actually. So it depends on what kind of problem you are solving, right? Each problem is actually different for ML. And like I said, so what we will do, we will just look at basics of Python a little bit, and then we will go to Pandas, and we will do some hands-on with Pandas, right? And then Numpy, and then this visualization stuff, right? So I think possibly I should, get started with the hands-on part. So if you can look at your laptops, right? So today probably what we will do is like you can do along with me if you want. Maybe tomorrow I will do it myself because it also takes time, right? So maybe depending on what we need to cover, sometimes tomorrow what I will do, I will just demonstrate and you can practice later also. That will not be a challenge. So if you have an installed Anaconda, right, you can just search for Anaconda. So this is, see, there is something called Anaconda Navigator and you can just open it. just to make sure that things are working fine. Well, Jupyter is in fact not an IDE. Spider is the IDE. We'll be using Jupyter for sure. I mean, Spider, we don't use Spider at all for ML projects actually. I'll show you. So once you start your Anaconda, and one more thing you can do is that if you're not really very much comfortable with programming, I mean, you may be somehow comfortable, but if you feel like you're not really comfortable with programming, you can just take a help for somebody who's sitting next to you, right? Yeah, so if you open Anaconda, you will see these icons, and in these icons, we are really interested only in this thing called Jupyter Notebook, the second thing that you see. There are many things actually, we are not really using any of them. For most of the data science projects, Jupyter is the primary, building platform for prototyping and all, at least now when you begin, right? Then once you complete, let's say 3 months, 6 months and all, probably you can use different tools also. But to get started, what you need is this thing called Jupyter. So either you can click on the launch button here, one thing, there is a launch button, or even it will be available here. If you go to the programs, just type Jupyter, somewhere it will be there. Yeah, so there is Jupyter Notebook. So whichever way, either you click on this launch or you click on this, just open this thing called Jupyter. It will open in a browser. I will tell you what it is. It will open in a browser. Well, what is this, right? So Jupyter is actually an open source project. Originally, it was called IPython Notebook. Later, it was renamed as Jupyter Notebook. It is a browser-based interactive shell for Python. Meaning, normally if you are writing a program, what you do is that either you will take a text pad or something, or you will open the command prompt and type the program. So if you're doing something like Java or something, you will use Eclipse or something, right? In case of Python, since it is sort of like a scripting kind of a language, it's very easy to write the code. What Jupyter allows you to is to create something called notebook. A notebook is an environment where you can type your code, run the code, see the output, and the advantage is that you can share it with others also. So just to show you an example, we will pick up some notebooks, but you guys can do this. You can say new, there is a new button, and there is something called Python 3. If you click on this Python 3, ideally in a different tab, this will open. So what you need to do, just go here, say new, Python 3, and something like this will open, right? Are you able to do this? Yeah, okay. So this is called a notebook. Now, if you really want to do what this guy is doing, it's very simple. For example, I can say A equal to 5, B equal to 10, okay, and I can simply say print A plus B. I think probably you can understand the code. It's not so difficult. So let's say I'm writing a code like this, okay. So I'm saying there is a variable A that's 5, B is 10, and I just want to print A plus B, right? So this is my program, imagine. Now, if I want to execute my program, what I can do, either I can click on this run button, there is a button run, or I can just press shift enter. Just run the code and show me the output here. This is basically what it does, right? So it is an interactive notebook. You can type and click and see what you're typing or what it is going to do. And for most of your data science or ML projects, you will be using this tool. Because in ML, it's very important that in every step, you see what's happening, right? So you don't write a full code and then run it, but rather you load the data, then see what is the data, filter it, see what it is. So the most convenient way to work that is using Jupyter. So we'll be using Jupyter all the way, right? Yeah, so some of you are having small difficulties in starting IPython and all, it's perfectly fine. Even if you're not able to do it right now, it's perfectly fine, okay? So anyway, I'll be sharing whatever I'm doing over the LMS, right? Now in the LMS, you have a file. Can you look into this file? If you go to the LMS, let me just, can you see these files in LMS? There is a Python overview, Python visualization, store sales, Uber driver, etc. Where in LMS? There will be a zip file called Python files. Do you see a zip file called Python files? Can you download it and extract it? Inside that you will have a zip file, right? Can you download it and extract it? And once you download it, extract it, and you should see these files. So basically what you need to do, once you download them, open your Jupyter. So this is my Jupyter, right? And all you need to do is, let me see if it is already there. No, it is not there. All you need to do is that click on this upload button. There is an upload button, okay? And then select the file you downloaded. Let me show you which one. Where is it? Python files. And then select this file called Python overview. Can you see? And say open. And click on upload. That's it. So what you need to do, click on this icon called upload. Click on this upload and upload this Python overview file. Now I have seen in some of the classes, for some participants, when they try to do this, it will not get uploaded. And the issue was with the browser. So sometimes if you are using Internet Explorer, it will not allow you to upload. I don't know why, for that reason, but. And if you have uploaded it successfully, you should see it here like this on my screen, somewhere in this home file. So if you just click on this file, Python overview, it should open like this. You should see this actually, right? So this is the advantage of a notebook. See, you can type your code and you can even type the explanation. See, so I have typed something like code structure, what are you learning, all these things. And this is not actually code. This is just the markup, right, that I'm doing. So I can even type these kind of explanations and share with people. So it's very easy, right? And I want you to do one thing. Once you open this, go to this cell menu. There is a cell. Can you see? And there is something called all output clear, the last option. Because normally when you create a notebook, it will have some outputs already. So I just want you to clear it. So just go to this cell menu, all output, you can say clear. Now you can also insert your own cells. So basically how the notebook works, you can see different cells. Each cell can be executed independently, and you can also write your own cells if you want, right? And this is a code structure. So first we will look at some of the native data types in Python which are important for you, and we will look at pandas and basic data frame attributes and common data manipulation tasks using pandas. Then there is loops and functions, visualization, any other miscellaneous topics, right? And what I want you to do first is to run this cell. Under this basic data types, you have a cell here. So either you can press Shift Enter, or you can click on this run button. And how do you know whether it is actually running? You will see this number 1 here. Can you see? This means it has ran. Okay, so that is the only way to identify whether that cell has executed.
What is that cell exactly?
And what is this? So basically I'm just doing a small import here. So I'm saying that from IPython, import something called interactive shell, and interactive shell code interactively all. I will explain this. So basically what I'm doing is that I'm just telling that I want to work interactively on the IPython notebook. So you just need to run to standard code, boilerplate kind of code whenever you are interacting with IPython. I will explain what this code means to you in a moment, right? But just run this and make sure you can see this, it is actually running, right? Now actually there is some code here, but you can insert your own cell. So I don't want to just run. What you can do is that you can say insert and you can say cell below. And what will happen? You will get a cell like this, right? And you can adjust like what you want to type, that's up to you. So after you run the first cell, I just want you to insert a cell. And in Python, at least for the time being, you need to know only 3 basic data types. So if you put a hash, it will not work. Commenting is hash in Python, right? So if you type a hash and type any code, it will not actually execute. So that is why I'm typing a hash. So basically in Python, the 3 data types you should know are, one is called a list, then there is something called a dictionary, and then there is something called a tuple. So what I'm saying is that list, dictionary and tuple are the 3 data types you should know, at least for your ML and all these kind of things mostly. There are other data types also in Python. Of course, there are n number of data types, but these 3 things are very important because these 3 data types can hold your data, like more than one piece. So all these are collections kind of data. And the first thing that typically you should know is called a list. So what is a list? A list is nothing but a collection of elements, And how do you create a list is like this. For example, I can say something like this, my list equal to, let's say 20, 30, you guys can also try with me if you want, 70, that's it. So how do you identify something is a list is the square bracket. So that is the thing you need to understand. If you see a square bracket, it's a list, right? And so I just created a list called my list, and you say equal to, and then you just type this. So this creates a list. Now, in case of your IPython notebook, if you want to run something, so I have this, I can just say run, and it should just create the list for me. So now the list is created for me. And if you want to see this, you can simply type the name. I can simply say my list, and run this again, and it should print it. So this proves that the list is actually created. So whenever you want to print something in the notebook, you don't have to explicitly type print. The last line is anyway printed. So you may be wondering that normally when you want to print something, you say print and then this thing. In the IPython notebook, the last line or any variable you just write, it will print it by default. So you can easily see that, right? So first thing you need to understand is that this is a list. You see the square bracket thing, right? And also if you want to access any element from the list, you will always say my list. Okay, I'll just probably type it here, and you can simply say this notation, 0. So what will happen? You can access the elements using the index position. So 0 will be the first element, it will print 20, right? And if I say 0, 1, what will happen? No, it will not print. So you cannot access like that. Okay, so yeah, so I'll tell you. But so if you want to just print one particular element, you can say like 3. So this will print what? 50, because 0, 1, 2, 3. Now, if you want a range of elements, for example, I want to print the 20 and 30, right? You can simply say, I can say something like 0 to 2. So when you say 0 to 2, what it basically means is that I want to print 0th and the first element, not the second one, not the position 2. So if I say 0 to 2, it's going to print 20, 30. If I say 0 to 3, what it will print? 20, 30, 40, right? So this is one way of accessing, the elements within the list. You always use this colon notation and say that which elements or which range you want to actually print. And this notation is very common in Python. This is not only in list, even if you go to data pandas and all, we'll be using this colon. Something from something, it will start printing those elements. Okay, now what if I want only 20 and 40? I don't want everything, right? I want only 20 and 40. So 20's position is what? 0, then what? 3, I don't know. You get it? No. So take it as an assignment, I'll explain this. But yeah, so normally when you want to print a series of elements, you will say like this, 0 to 3, this will print, let's say 20, 30, 40. I'll tell you how to print individual elements, or you guys can figure it out and tell me also. Some in-class assignment for that, right? So my question is that how do you print 20 and only 50 if you want? You can try and let me know. Anybody got any answer? Then it is easy for me.
0, 3.
0, 3.
Yeah.
3. No, that gives me an error, right? List indices must be integers or slices, not a tuple. It's just throwing some error, right? It is not printing, right?
Minus 0, then comma minus 1.
So is that in 0 is square
Minus
bracket?
0.
Minus 0, comma
Minus?
Minus 0, then comma minus top.
Oh, okay. Separately. No, I just want.
0 is in the square bracket, comma, and then.
Okay, so 0 in a square bracket, comma. Then what is that? 3, right? Sorry.
Remove the external brackets.
Oh, you don't want the external brackets?
No, comma also remove and external brackets also.
That's not the syntax.
We don't follow that syntax.
No, that doesn't work, right? Okay, it's a small trick. I'll tell you, let you know. Okay, so as of now, we are just printing series. Okay, I mean continuous elements, 0 to 3. I'll tell you how to print individual ones. Don't worry. Okay, you can, but it's very rare that normally in a list kind of a category, it's very rare that you pick up individual elements, because normally if you are creating a list, that will have like 1 million elements inside it, and it's very rare that I say I want only the third and fifth. You mention a range of elements actually. You can also do this. You can simply say, for example, 1 colon, and what that does is that if I say 1 and just colon, it picks up 30, that is the first element, and gives you all the things after 30, 30, 40, 50, 60, 70. I can also say 2 colon if I want. That should give me 40, 50, 60. So you have this nice ways of accessing elements within the list, whichever way you want, right? So that is, we will look at lists more, don't worry. There is a simple example of a list, and here also we have created a list. Now my question, don't run this, okay? My question to you is that will this actually work? So here I am saying x equal to 1, then b. So what is the speciality of this list?
It has different data types.
It has different data types. Does it actually work? No. Yes. I don't know, I'm just asking. Yeah, it works. So, but list can contain different type of elements, okay, but ideally we keep similar type of elements. Now, apart from the list thing, insert cell below, another thing which is very interesting is a dictionary. So I can say something like dict equal to, and how do you create a dictionary is with a curly braces. So whenever you see a curly braces, that is a dictionary. Okay, and what is a dictionary? A dictionary is a collection of key value pairs. For example, I can say Raghu, and I am a trainer, right? And then you guys, right? You or you guys, I don't know. You are what? Participants, right? Sorry. And I can also mix them. For example, I can have another key. For example, there is a key called 3, and I can say this is something like my number. So basically, what is a dictionary? The idea is that you represent it using curly braces, first point, and it always has the key and value structure. For example, here Raghu is the key and trainer is the value. Again, you is the key and participants is the value. 3 is the key, my number is the value. Now, inside a dictionary, there is no strict rule as to what should be the key, what should be the value. That's for you to define. You can have strings, you can have integers inside a dictionary. But one thing is that when you want to access the elements of a dictionary, normally in a list you will say 0th, 1st, 2nd. Here you will use the keys to access the elements. For example, you want something, you can simply say, so what is the name of the dictionary? DICT, right? So the dictionary name is DICT, and I can simply say something like this. So if I want to get, say, what is the value of Raghu, I can simply say call the key Raghu and you will get trainer, or any key for that matter. So I can say give me the value for 3 and you will get my number. So basically this is used like a lookup table, sort of like a hash table, where you have fixed number of key value pairs and you can just call the key and you will get values. You can also print things like this. For example, I can say dict dot keys. Sorry. Yeah, so if I just ask for the keys, it's going to give me all the keys, what are there in the key. You can also, you should also be able to do a dict dot values. Sorry, I'm always missing. Yeah. So basically, if you get a dictionary and you just want to know what are the keys or values inside it, you can just call a dot keys and dot values. It's gonna give you the keys and values, and then you can access whichever values using the key. Now individually you can do like this, but if you are interested in accessing a range of keys, like I want 100 keys, then ideally you should go for a for loop or something. So typically if you want to iterate through a dictionary and get different values, we use a for loop. I'll show you. So usually you say that 4 elements and then one by one I want all the values or something like that. So that's how you look at a dictionary. Now we are not really dealing with object oriented programming here. So how many of you are coming from the OOPS background, object oriented thing? Because why I'm talking about this is that usually in your data science or ML side, we don't normally deal with object oriented concepts. But Python is a language which supports object oriented programming. It is an OOPS language. So normally you have an object and then you will have methods and attributes for the object, right? So that is what, when I'm saying this, these are functions on the object actually, right? So I'm saying that dicts with brackets, right? So basically you can have function calls and then get the value, whatever you want. So these are defined on the dictionary actually. So we will see them more. So directly you will not be dealing with classes or objects a lot in Python, but you may sometimes use some of the built-in methods like this, right? Now another interesting thing that you can do is, let me just insert a cell below. So I can say the same thing, right? So I can have a dictionary where I can have the keys like this. So let's say I'm picking up you guys, okay? So you are a student, okay? And you were working in IBM, right? You were working in IBM, and then there is another student, S_2, and this student was working in multiple companies. So let's say Infi, I don't know. We are in the Silicon Valley of India, right? Give me some company names. Infi, then what? I know only Infi and IBM. Why am I like this? Wipro. No, be more creative, right? Give me something more.
Google.
So what I did here is that I created a dictionary and there is a key and value. The value can be anything. So in this example, the value is a list, right? The value is a list, and I can simply ask for students, and then I can say give me for S1, right? And I should get IBM, right? But if I'm asking for student 2, I should get Infi, Wipro, Google and all, right? Now tell me one thing, what if I want to know so these are in order. For example, the second student has first joined Infosys, promoted to Wipro, by fluke entered Google, okay? I don't know how do you get promoted from Wipro to Google, but yeah, happened. So I want to know what is the second company he was in. So when I say S2, I am getting all this. I don't want this. I just want to know Wipro. What will you do?
S2 of 1.
Bracket 1.
S2 of 1.
Right. So you can actually, so this is the way to access a list, right? So I can just say that I want the key. Within the key, I just want, so this will return the value. Within the value, I want the second element, which gives you Wipro, right? Or like this. If you want only Google, you can do like this. So these kind of operations are possible. And the same thing I have written here, right? We will look at them later. Okay, so there is also one more thing called a tuple. So this is called a tuple. Can you see? How do you define a tuple? Is within the bracket, normal bracket, right? So what is the major difference between a list and tuple? Is that list is mutable but tuple is immutable. For example, so this is tuple. So let's say my list equal to 1, 2, 3, 4, 5, right? So in the IPython in the Jupyter notebook, if you want to understand what are the operations you can do on a particular item, you can do one thing. For example, I have a list now. I can say my list and put a dot and put a tab. So you can just type my list, put a dot and then put a tab. It will show you a list of arguments you can pass. So you can always see there is something called append. So I can actually do a append and let's say 7. So what happens here is, if I do a my list, meaning lists are mutable. You can add elements, you can even remove elements. There is a method called pop and there is a method called remove. Using that you can just remove the elements, you can add elements. But if I look at this tuple which I created, I say tup, what is that, underscore ex dot, I don't see a method called append. So tuples are totally immutable. Once you create it, you cannot modify that. So if your requirement is like that, then probably keep your data in a tuple format. That's up to you to decide. Okay. So that's a difference between a tuple and a list, right? So lists are mutable, tuples are not, by the way. Now, one more interesting thing, okay, I want to talk a little bit about the notebook actually, is that here you have this new notebook and all, which you should know ideally, and you can actually save this notebook. You can say download as notebook. So if you have added some lines, you did something, you want to save it, you say download as notebook file, and then you can upload again back to Jupyter, right? Oops, you can rename it. One more thing is that if I have this line, so normally what happens is that if I type anything here, a equal to 5, it will execute it. Now I don't want it to execute, I want like a heading. So what I can do, I can just type something, this is to test Python, and I can just select this cell and there is a cell type. Where is it? Cell, yeah, cell type. I can say markdown. So if I keep it as markdown, it will just print it. And you can always have this hash option. For example, I can put a hash and that will increase the font, so this is like, you can just make it bigger. And if you type 2 hashes, it will be the second heading, third heading, like that you can have very nice representation. So always remember this, because sometimes what I have seen, people will mistakenly make a cell as markdown. Then it will not execute the code, whatever you are typing. It's just going to print whatever you are typing, right? So you can just go to this cell type and say whether it is a code, markdown. There is also row convert. Don't bother about it, but make sure it is code if you want to run it actually, right? And if you go to this help menu, you can actually see what are installed. So there is Numpy, SciPy, Matplotlib, SymPy and Pandas. There is also a library called SymPy. We'll talk later. But since you are seeing the help of these things, that means these libraries are already there. I think ideally you should also see the similar things. You can get the help about them. But in case, let's say you want to install a library in future. So let's say there is a new library which came, you want to install from the notebook. The ideal way of doing it is this command, pip install, and then you can just mention what you want to install. So if you put an exclamatory mark at the beginning, it will run from the command line, right? So pip is a tool which we use for Python installation. So I'm just saying that I just want to install Pandas. If I run this, well, Pandas is already installed, so it's gonna throw an error saying that the library already exists. But you can see a star here, which means this cell is now executing, it's still running. So when you see a star here, that cell is getting executed. So it says requirement already satisfied, Pandas is already there. But in future, so one way is pip install Pandas, another way is conda install Pandas. So either you say pip install or you can say conda install also. So since it is part of Anaconda, the installer is called conda, and say conda install, it will install. So if there is a new library, you can just Google how to install, say, ABC in Anaconda. The exact command will come, copy paste it, install it. Very easy. So any questions so far? Anyway, it is already installed as well, so it's going to throw an error. This star will be really useful when you actually build ML models and all, because when you are building machine learning models, what it will do is that it will take your data and then do something called iterations on the data. So it will read your data, then iterate multiple times. So that sometimes might take some time. So you can actually see that, okay, your code is executing, you need to wait for some time, right? And right now, one of the problems that we are facing, so I'm just sharing, I mean, some of the, probably not exactly a problem, but from my experience. So see, we are always moving ahead with new technology, right? So in the older days, the problem was that the hardware was a problem. So I don't know what to do with the hardware. So that is when you started getting this cloud and all as an option. Now everything is available in cloud. Even your entire ML things can be automated in the cloud, apart from your local notebook. So initially when machine learning and all became very popular, we were very much using cloud for most of these building ML models and all, and that was very easy. And now the challenge is, we are now from ML, we have gone to something called deep learning or AI kind of side. So when you go to deep learning, one of the problems that you will face is for the hardware, right? For example, if you are building something on image classification, say, so one of the project which I'm mentoring, so you have this capstone projects, right? So what happens when you do a capstone project, you will be a group, let's say 4 or 5 guys, and then there'll be a mentor like me who will help you to. So currently I'm mentoring a capstone project. So what these guys are doing, they have a CCTV camera footage identification. That's what they are doing. So they have the images, and by looking at the image, the system should say, the system should actually describe the scene. It's not like it should say there is a dog or cat. It should actually see what is the content of that. So they're building something similar in that fashion. Now the challenge there is actually not building the model and all are fine, but if you are doing things like deep learning and all, you need a lot of GPU, graphical processing unit. That is the challenge, because GPUs are very costly. You know what is GPU, right? It's graphics card kind of thing, right? So if you're using a laptop or something, it will not work, because you will have what, 2 GB or I don't know, 3 GB max. So one possibility we explored was that you can sign up with the Google Cloud, and Google Cloud gives you some credits for free. So if you sign up with Google, they will give you around 21,000 rupees credit for free. You can use their services worth 21,000 rupees, right? Even with that, the credits ran out, because these guys need around, I think, 16 gigs of GPU or something. So to train the model, they took 1 or 2 days. By the time the account is over, so the 21,000 rupees are gone after 3 days. So then what will you do, right? I mean, so I think the next challenge that we are going to face is on the GPU side. Like, how do you get it, right? Of course, if you pay money, you will get it. That's not a big deal. But what is an economical way of building a deep learning model? That is the next challenge actually right now. And it is very popular. So because it is not easy. Locally, you cannot get it. The only way is from the cloud probably, but they are very costly. So if you are running it by paying money, then it will be really, really costly, right? So I think we are still trying to find out what to do. I mean, so initially they build the model as a test in the laptop. That was working fine. But when you are really doing a project, you need the real data, right? So not like a test data. So that time it will take more resources for you. So even I don't know what to do. I just suggested them you either pay or get some other cloud vendor or something. Google is the only vendor who is, I think, paying this much money. If you sign up with Amazon or something, they won't give you. AWS, no. AWS has a scheme called a free tier. That's basically cheating. You should file a case against them actually for such a. So Amazon basically will say, we will give you every service for 1 year free. In fact, nothing will be given, right? So they will give only minimal services. For us, they will charge. Like GPU based services and all, they charge. They don't give it free. Azure is also giving some level of discount, but so far what we explored is Google Cloud. They are giving good amount of free money. So I mean, I'm just saying, so some of the challenges, right? Even when you do these kind of analytics, ML analytics, normally you can work on this kind of data on a laptop. Like if you're having even, let's say, a CSV file with, let's say, 10 million, 20 million rows, in your laptop, you can easily manipulate using data frames. That's not a big deal. But if it goes beyond that, then you may not be able to directly run on a lap or something. You need a better configuration machine. So good option will be that you can use any cloud provider just to test if you're having.
Can't we have this thing go in a parallelized or a distributed way?
Yes, you can. So one way will be that you take the same thing to cloud. When you're talking about distributed way, the small challenge will be that you need to learn a bit about it. For example, I can use something called Spark. There is something called Apache Spark. Apache Spark is a big data processing platform. I basically train people on Spark. So Spark has the same ML capability. Spark supports all the ML models. So what Spark basically do, it takes, let's say, a bunch of machines like 10 or 20, distribute your load. But you need to learn certain things about Spark. Because for example, I am using here Numpy, right? Numpy doesn't work in Spark. You have a similar data type. Or if I'm just using Pandas, Pandas as such doesn't work. So they have a similar one called data frames. Okay, so there is some difference. So you might have a small learning curve, right? Concepts are end of the day same. Like if you're building an ML model, everything will be same, but this explore EDA part, there'll be some changes because Spark is having its own data types to deal with, not the regular ones we see. So that is one challenge we see sometimes. When you build a model and you want to do distributed way, you need to slightly change the EDA part. Rest everything will be perfectly fine. Yeah, so some of the people are actually exploring those distributed computing platforms as well. So I mean, just some of the thoughts I probably should be interesting if you go further, not immediately. Right, so now what I want you to do is, so now we will just start working with Pandas. So what I want you to do is, can you see this slide? There is a slide called read the data, not a slide, there is a box cell, right? I want you to run this slide, but don't run this Numpy thing. So you can just comment this. Right now we don't need this. So basically you need to run import pandas as PD, but we need the data, right? So what you need to do, go to the files which you downloaded. There is an Excel file called Uber Drives. Can you see? Can you open that? The Uber Drives. I will maybe open from my side. Yes, so I just opened it. Let me just, I'll quickly explain what this is. So basically this is an actual data set which we have collected. So this is regarding the Uber trip data. So how do you explain this data? So there is a start date and end date. So start date is when the trip was started and end date is when it was ended. Most of the cases it is same date trips. Then there is a category that's always business. Then there is a starting point of the trip for the Uber driver. So these are all cities in US, right? New York, Fort Pierce and all. And then there is a stopping place where the trip ended and the number of miles covered. And then there is also a purpose of the trip. So this is how the data looks like. And if you select any of the column, you have roughly around 1000 plus lines of data. So we are just interested in analyzing this data. We just want to ask some interesting questions to this data. And we want to do that using the Pandas module, right? One thing that I would suggest you do is that just rename this file. So because it's called Uber Drives 1, just remove this 1. Just call it as Uber Drives 2016. I don't know why there is a 1 actually. I mean, you can keep it, but typing that will be problem, right? And then what you want to do, go to your notebook, and in the notebook, you need to upload it. So go to the home folder of Jupyter, say upload, and upload the Uber drives. Open, upload. See, it will be here. Can you see? So just click on the upload button, select the Uber drives, click upload. It should ideally show you on the screen of the home page like this. And Python has a lot of ways to read a different type of files, right? Right now we are interested in CSV. You can also read Excel files and other formats of files. So for the time being, we will concentrate on CSV files. If you want to read a CSV file, all you need to do is that you can say, so what is this line? Import pandas as PD. What do you mean by this as PD? It's an aliasing, right? It's an alias. So the library that I'm importing is pandas. I'm saying that I want to import pandas as PD. So it's just an alias name. And so PD will refer to pandas. If you want to read the CSV using pandas, you simply say pd.read_CSV and just give the name of the file. And then if you actually want to see the file, okay, you can simply type df. Oh, I didn't run this, right? Sorry. You have to first run this, right? I'll run this, then run this. Might take a moment to read it. So df will be your file, I mean the variable in which you are reading it. I don't know why it is taking this much time. Usually it should read very fast. My PC is actually very slow today for some reason. Let me do one thing, okay? I'll just restart and clear out. So I'll just say import this. Why it is saying it is still star for me? Are you guys able to read it? No? Yes. So can you see this? So the moment you say df, it's gonna print it. Now the question is, what exactly is this thing called df? Df is called a data frame. Well, the name can be anything, okay, it can be Raghu. I'm saying the data type is called a data frame. What is a data frame? A data frame is the basic data structure we have inside pandas, which represents your data in the form of rows and columns. So this pretty much looks like your Excel spreadsheet, and that data structure is called a data frame. So in order to create a data frame, what I'm doing, I'm just reading this CSV file using this method and assigning to this variable called df. Now df is my data time, my data frame, right? And if you simply type the name of the data frame, it should print the output like this. So you can actually see what is inside this. Also in Python, if you want to verify the data type of anything, you can do this. You can simply say, I think it should work, type of df. Yeah. So you can just say type of df, it will say pandas core frame data frame. So basically this is a data frame. So pandas is actually built on top of Numpy. It is built on the Numpy library actually. It does not directly use Numpy, the methods are different, but the core data structures are built on top of Numpy. We need to use pandas actually. Numpy doesn't have any built-in libraries to read Excel files or anything. Also in Numpy, you don't have these labels. This, I print this df. You have this start date, end date, category. Those are the column headers, right? That structure is not available in Numpy. So it anyway will not be able to read what is in the data. So in order to read, I need pandas. So I'm saying that in the data frame, you can actually call it as a column name. That is possible. But in Numpy, there is no way to do that. It doesn't support any labeling as such. So now the question is that if you simply say read_CSV, how it is able to, read it like this. For example, this is my column headers in Excel, sorry, CSV that it is reading. So by default, the setting is like the first row will be considered as your column header. Now, what if I don't have a column header, right? I get a CSV file, there is no column header. So if you Google for this pd.readCSV method, there are some arguments you can pass. You can say skip a line, skip the header, add a header, and one common problem that we have when you do things like this is that even though we are not very stringent about this, we are always looking for data types, right? So one common problem that you're going to have is that if I read this is fine. I have something called a start date and end date. So what is this? This is dates, right? So normally you want to do things like I want to subtract one date from another date, or I want to compare two dates. Now if I want to do something like that, they should be represented in the date data type, right? But the problem is that normally when it reads, this will be string. I will show you how to look into that. But normally when you simply say pd.readCSV, it's going to assume this is a string. Everything is a string unless it sees some integer. This will be an integer or a float, but these are all strings. So in this pd.readCSV method, if you read about it in Pandas, I will show you, there are some arguments you can pass. For example, I can say the third and fourth column are dates. Please consider them as date data type. Or skip the first line, that is not the header, etc. But as of now, we are simply reading it because the header is also the same one here, right? Now, I think we will be able to see this if I do a df dot, look at here. You can always do a df dot d types. What does this mean? Each column's data type I want to know. Now, whenever you see an object that is nothing but a string, this is a string. So the class is actually called object, that is what is showing as object. So the only column it is identifying is float 64, that is a miles column. That is okay with me. But my start date and end date is object or string. I don't want it to be string, I want it to be date, right? So there are ways to convert it, I'll show you.
So that command line import Pandas is PD, is that defining PD as a function to import?
No. This is an alias for Pandas. So Pandas is my library. I'm just saying that I don't want to type pandas.readCSV, I'll type pd.csv. That's all. Aliasing. I can also say import pandas as Raghu. Then I can say Raghu.readCSV.
Could I directly use pandas?
You can.
Read CSV?
You can.
Oh, okay.
You can simply say import pandas and pandas_read. But these are some of the common, how do you say, things that we do in. And when you are importing Numpy, you will always say import Numpy as NP. That is a standard, So even if you read production codes, you will say np dot because they could have imported as np normally, right?
So Pandas is basically just importing the entire worksheet, right?
So now another point is, which is good, if I do this from pandas, import pandas as pd, one of the drawback is that this will import the whole pandas library. Maybe I don't want that. I don't want all the functions. I want only selected things. So you can say from pandas import only selected ones. I think, see, from pandas import read_csv. If I do this, but the problem is only this will work. I can't do anything else.
Putting this worksheet into this workspace that you're working in?
No, this is just, this is not a worksheet. This is our notebook. So this is just so all these import statements I'm running here, they will be running using command line behind the scene. One more thing is that what I did is that this Uber driver CSV I uploaded in the this thing notebook, right? And then I say read it. So right now this is in my directory and the original file doesn't get changed. The original file, because that is a good practice. I have a CSV file and if I directly read it from where it is existing and I do some manipulation, then what will happen? My original file gets altered. So all these changes what I'm doing, it is not going to affect my original file. So you could have downloaded somewhere. So this will upload it in its own workspace, right? And whatever and if I want, there is a method called pd.toCSV. So if I have this data frame, I created this, did some manipulation, I want to save it back, I can say pd.toCSV back to the CSV file. That's also possible. So this point is very important because when you look at the data types, this guy is object, this guy is object. That means my dates are actually string. I don't want string, I want the date data type. I will show you how to convert it, and it's a very common requirement because we have examples where you are getting sensor data in certain intervals, and the sensor data will have a timestamp column, because every time interval it is sending the data, and this will be in the Unix timestamp format, which nobody can understand. Like it will have milliseconds, microseconds, nanoseconds, and date and time. So what will happen when you read it as a PD .csv or anything? It will say this is a string, right? So then you have all string values. You can't do any manipulation. So ideally, you should change that into a date data type. I will show you how to do that, but that's a very common thing that we do, right? And one thing to confuse you very much is, okay, so this is really confusing. If I type just df, oh sorry, you see this, right? There is one thing which is confusing here. Can you tell me what is confusing? No confusing. No. The point is it has something called row index. This 0, 1, 2, 3. This is very confusing. Normally in an Excel you don't have this. You have it, but you don't really care. But in Pandas this is very important, and this is one thing which confuses people a lot. Because if I want to access the data, I can say column wise or row wise, and whenever I say row wise, I have to use these numbers. Now one way to do this is that, so when it read, by default it added these values, right? I didn't specify. One way is that I keep it like this. Another way is that I can define my own index. I can say I don't want 0, 1, 2, 3. I'll type whatever I want. You keep it here and then store it. That is also possible. I'll show you in the upcoming sessions, but this is something which confuses people. And even though we call this as a column, it is not a column. So we say this is a column. In our normal terms, we are saying that there are rows and columns. This is not a column. This is called a series. S-E-R-I-E-S, series. Series is a data type. So basically a data frame is nothing but a collection of series. This is 1 series, 2 series, 3 series, 4 series. That is why each series has a data type. So in simple terms, we will say that you read a CSV file. CSV file has 7 columns. That's what you say. But in reality, when you look at the data types, this is a data frame. A data frame is made up of multiple series. Each one is called a series actually. You can see the data type actually of the series. We did a D types, and each column it was saying what is string or object. So that's called a series actually. And in some of the classes, I have seen people discussing how to create a series from scratch, but I don't think that's not really important, because when you start working in production, it is very rare you create your own data. You get it from somewhere. That will come in Excel or CSV or something. I don't think that you will create your own data by typing and then creating, but that is also possible. If I want manually, I can create a data frame. I can just fill in these columns and create a data frame. So we read it, right? That's what we have done. Okay, so one more thing is that when you simply say df, it's printing the whole data frame. If I have like 1 million lines, it's not really a good idea. So you can always say df dot head, H-E-A-D. This is going to give you the first 5 lines. That's easy, right? Because you just want to have a sample of how the data looks like. And one interesting thing that you can do in your notebook is that, so this head is a function that we are calling. If you want to understand what is head doing, you keep the mouse cursor inside this head and press shift tab. What it says, it is saying df.head n equal to 5. That means the number of rows are 5. If I want more, I can say n equal to 10. So how did I get it? Just keep your mouse inside this, press shift tab. It will give you an explanation of the method that you're calling. Well, works in some cases very complex functions, it will not give you the entire detailed explanation. For that you need to look into the documentation, but sometimes it is handy. So always do a head and always do a shape. Another one is a shape. What is the shape? It will tell you how many rows and how many columns are there. 1156 rows and then 7 columns. This is really helpful because you will be doing a lot of filtering, manipulation, and then you want to know how my data looks like. How many rows I read, how many. So always do a shape, very important, always do a head in common data manipulation, right? So shape is another method you can use, right? Yeah, so we are able to get the data, right? Now, one of the things, like I said, there is a problem is with the time that we have, right? So what we can do is that we can actually, convert this start date and end date, these things. But before we do that, let's have a look at it. So already we did a head and shape. You can also do a tail, which I'm not really interested. But one thing you can see from the tail is the last row. In the last row, this is actually a sum of all the value. Like this is miles, so they have added all the values. And what is this NAN? This NAN is sort of like the official junk value in Pandas. It's like null. It is not null. NAN stands for not any number. So whenever a data frame doesn't have anything to fill, or if it reads something which it doesn't understand, it will.
NA is not treated as null.
It is not treated as null. There is nothing called null actually in a data frame. Instead of null, you can say NAN.
So that it can be counted and it can do the analysis on this.
Yes. So the useful use cases will be sometimes when you read the data, there will be some junk character which Pandas is not able to understand. And the junk character can be anything. It will not be one character. So all those junk characters commonly it will treat as NAN. Now I can say select all the NAN, replace everything with something, say 1 or 0, or even the mean, or delete it, something like that. So it's officially used to remove this kind of junk values. Why you are seeing it here? Because normally in a data frame, it has a fixed row column structure. Everything should be filled ideally, right? So in the last, I'm not able to add all these things. So it just simply filled it with the NAN values here. You can see only this field is added here, right? You have 1000 or 12,000 something, right? Some value.
Instead of head, is there any method which print only the series one?
It is. I'll show you. Yeah. So we'll just look into that. But before that, I just want to show you one small example. So have a look at here. So this is something which may be interesting, because what I'm doing here is that there is a method called pd.dataframe. What this allows you to do is to create a data frame from your own definition. So normally you will read a CSV, that's a different thing. So right now what I'm saying that I am creating a data frame myself. And if I look at the data frame, oh sorry, I should run this first. It looks like this, right? So how I have created a data frame, this is a dictionary, right? What is this? This is a dictionary. And in the dictionary, what you have key value pair. A is the key, B is the key, C is the key. So if you pass a dictionary, the keys will become the column names, the values will become whatever values you have, and the index, row index is anyway 0, 1, 2, right? So it created a data frame like this. And now the problem is, if I look at the data types, again I have the same problem, because A is, I don't mind, it's a string 1, 2, 3, 4, be it. B is integer, that's also fine with me. But C for me is string. But C is actually the date, right? But it has read it as a string. So what I want to do, I just want to convert that into a date data type. Now there are multiple things you can do. For example, the method is actually this. It's called pd dot to date time. So this is actually the method, and you can say something like 2016 June 2. So there is a built-in method called a to date time, and what you can do, you can just pass a string like this. So I'm just passing 2016 June 2, right? What it did, it automatically identified that year is this, month is 6, date is this, and the time is 000, right? This is very important. And you can, and what if you want to pass multiple things, you can put a list. Sure, 2002-16, right? Or anything, 2002 hyphen 02. No. 31st. So what is the error you are getting?
That means the middle one should be a compile
Formatting function should be there, right?
Yes. So by default, what it does, the format is what? Year, month, and date. But what if my data is not like this? There is a way to convert it, to mention the format. So by default, if you look at to date time, it will mention that. So in Python, there is a date time library which you can import. Once you import it, inside that you can say that dot format and my month is this. I will quickly do one thing. I know that I'm a bit offloading the discussion. Where is the? There is one more thing. Python file. Give me one moment, okay? I have downloaded. Did you guys get only this? Okay, this one. Sorry, guys. I'll just extract this. What I can do is I can go here and I say upload, and I can say there is a file called final. In this, I have this. I'll share it with you guys, okay? Don't worry. Python basics. This one I'll share it with you, don't worry, but I'm just. Yeah. So there is a built-in date time function. So if you are particular about the date format, what you need to do, you need to import this date time. You can import this date time, date and time, and then you can do something called strip time. So I can mention that, you know, this is my data and the format is like year, month, date, hour, minute, second. This way I can mention. So you can Google around it. It's not a, so by default, but if you look at this to date time, this will accept only in this format. But I can say like this, right? 11/2, that should give me. Now, what if you have multiple dates? What will you do? I have 2 dates. I want to convert 2 dates. You always keep it in a list. So the advantage of list is this. So whenever you want to keep multiple things, you can keep in a list. For example, I can say that this is in a list. Oops. And I can say, give me one more date, some date. 2020, 1, sorry, 1-1. So now, oops, doesn't convert. Yeah, the D type is date time, right? It converted, right? So if you are having multiple elements, you can actually pass it as a list and they should be able to convert. If you have a single element, you can just say that convert it into that format. But that is not our problem, right? Our problem is that we have what you say, a data frame that is called temp, and in this temp, so let's run this. Where is temp? Temp. Yeah. So in this temp, I want to convert this C, right? So how do you do that? I think I deleted it. You can say temp of. So what is a column that you want to convert? C. You can simply say pd dot. So when you are converting, this is what you need to do. This is how you access a column from a data frame. So you will say temp is my data frame. I want to access this C equal to, I want to do something with it. I want to convert to date time of this column. So this will be replaced by this C column. So if I do a temp.d types, you can see C is now date time is converted. So any column that you have, you can just do a date time and convert it. And usually that is a good, common practice that we do. Many places you have strings and you just want date time only for that. It will change the original file. So when you are doing these kind of modification, the original data frame temp will get changed. Now, if you do not want to do that, you should assign to another data frame and do it. And that is another very confusing concept in Pandas. In Pandas, there are some operations which will change the original data frame, some operations which will not change. For example, if you are adding a column, you can add a column to a data frame. If you are adding a column, that will change the original data frame. So what will happen if I say just add a column, my data frame will change to someone. But sometimes when I am removing a column, the original data frame will not get changed. So I will say, okay, data frame, remove the last column. Then if I again I type data frame, the column will exist. So I need to assign that to another variable and then do it. So when we reach those respective examples, I will share you probably. But in this example, yes, the original data frame gets changed. So the data type gets changed actually. Now another problem that might happen is if you do something like this. Can you guys try this? I want you to do what can we do? Try this. Do a pd dot to date time. Okay, convert it. Let's say you have a series of values, list of values. Let's say 2016 September 11 comma ABC. Very possible, right? Very much possible. I am going to read a column. Either I am reading a column or I am manually passing the value. I want to convert into date format. The first value is fine, no problem. The second value is what? So can you run it? Yeah, obviously you cannot convert ABC to date, right? So you can do two things. One thing is that you can filter them and then say that, okay, I don't want them. Another thing is that you can add a parameter here. Forgot the name actually. You can say error. It is COERCE. So you can just add a small argument saying errors equal to cause. What will happen is that it will understand that you want to convert the data. Wherever it can convert, it will convert. Wherever it cannot convert, it will say NAT. NAT means not any time. It's again like garbage value. So that will be useful, right? Otherwise, even if you have a single value, it will throw an error and say that I cannot convert. Sometimes it is useful because you read timestamps and it is not able to understand or throw errors. That times you can do. Even I forgot this. Very recently somebody asked. So see, sometimes it will not come on top of your head. So in the last class somebody asked like, how will you do it? So then I didn't remember on my top of my head, but I found it's very rare that you use it. Normally the formats will be filtered before you get it, but you can do it anyway. So you can add this line in case if you want to convert it. You can also say a PD to numeric. Okay, so look at what we are doing here. You have this A, right? What is A? A is a string. I can say what? So I can say PD to numeric of A. So what will happen? A will become integer, right? So sometimes you can convert from what? String to integer, and we have also converted from string to date time format. Possible. And there are some more things. Oh, I think I have written here. So you can mention the format, month, date and all if you want. So there is a URL I have given here, https python 3 library date time. So you can just open this to understand more about the date time functionalities that you want to use. And also see, when you're actually doing ML classes, right, there this will be again repeated. So don't think that right now you will learn, that is the only end of learning. So if you are having a data where you have date, definitely you will deal with it, right? So this is just like an introduction. There is a very useful method called a describe, df.describe. Okay, What this does, probably you can understand, it will describe a data frame. For example, there is start date, end date, category, start, stop. How many are there? Count of them. How many unique values are there? What is the top value? The frequency, mean, standard deviation, minimum. This is a median kind of 25th value, 50th value, 75% value, and the max. So this will be useful if you want to get a quick look at your data set. What is the common column values? Wherever it is not applicable, it will say NAN values, right? So some of them there is no mean, median, and all. It says NAN. Other places it is actually going to display the result. So the describe method is very useful if you want to get an idea about your data. And you can say include all, or you can say include only the columns that you want. There is also an info, right? Info we will look at later. And another thing that people usually want to do. So right now we have this Uber data, right? In the Uber data, we have a column called a start star. Start star is the starting point of all the Uber trips, right? So I want to know how many values are there. So you can say a value count. So these are the locations. So there are 201 trips starting from Cary, 148 unknown, and 85 Morrisville. I don't know, there is an Islamabad in New York, somewhere near to that, but yeah, there is one. There is also Karachi, I think. I don't know why, but yeah. So this is very useful because you can know, right, how many unique values are there, the count of values. So you can always do a value counts, and then you can do a head also if you want on that. So it says the top 5 locations, top 5 trip starting points, something like that. A very interesting thing. Okay, so let's look at the common data manipulation tasks that you can do. So when you get a data in the form of a data frame, right, some of the things that everybody want to do, one is selecting, indexing the data. I want to select only 1 column, 3 columns, 2 columns, very common. Second is filtering the data, always possible. I want all the values greater than this, less than this, something like that. Then sorting the data, for sure, I want to sort it. Mutating, conditionally adding the column. I have all the sales revenue. I want to add a new column, the total or the mean of the sales, something like that. Group by summarize. So for example, the Uber trip data, I want to group by the start location and find out all the trips which are having more than 10 miles or something like that, this kind of analysis. So if you can get a basic idea about these 5 tasks, majority of your EDA is done, right? If you can do this much, that's all you want to do, right? What else? And of course, then another thing that might come inside this is functions. So for some of these tasks, you might want to write a function to perform it. We will discuss that, but commonly if you can understand these many aspects of it, that's more than enough. Now, when it comes to this selecting, so first thing we are going to do is selecting. There is a small thing you need to understand. There are 2 methods. One is called iLog. Second is just called log. So whenever you want to select the columns or rows from a data frame, either you can say iLog or you can say log. This iLog is actually deprecated. We have been using it, even it is supported. I don't know what version you are running. In some of the Pandas versions, if you run the iLog, it will throw a warning saying that this is old, it is deprecated and all, right? I think in the future versions, they will remove it. Log is what everybody uses. And the difference is very simple. iLog means this is accessing a row or a column using a number. Log means by the name. Like I'll show you a practical example, but basically iLog and log are just, so I can do this. So let's first look at the data frame. So if I want to get some data, I can say iLog, okay, and then I can say, let's say 0 to 5, just an example, okay, and then I can say 0 to 4. So can you tell me what happened here? So when I say I log, the first part is the row, the second part is the column. So 0 to 5 means row number starting from 0, 1, 2, 3, 4. It will not include 5. And 0 to 4 means what? Columns 0, 1, 2, 3. So basically you want these 5 rows and these 4 columns. So the first thing that you mention is the index, that is a row. The second thing that you mention is the column. That is how ilog works actually. From that you are slicing a part of the data. So that is indexing, right? Also you can do one more thing. If you want selective columns, you can do like this. I can say I want only the 0th column and the 3rd column. Understood? Like this. 0 to 5 row, 0 column and 3rd column. 0 column means first column, 3rd column is this column. Right? Can you guys try this? Let me know if you are able to do it. Not able to do it? Okay, let me ask you one question. What will happen if I do only this? Will it work? Just a question. 0 to 4 I am just typing.
Yes, column. Yes. All the columns.
What happens? Because the first argument you are passing is the row, right? And you are getting all the columns. But if you want the other way around, ulta, you have to say colon, comma, 0 to 4. What does that mean? This first column is what? All the rows. I want all the rows. Look at here, 1, 2, 3, 4. No? All the rows. So it just says etc. etc. Doesn't display everything, right? I want all the rows, but only these columns. So remember this. If you simply type anything, what will happen? These are 1, 2, right? Only this, and all the columns will be displayed. But if you want all the rows, but just the columns that you are interested, you can say this. Selecting so selecting certain columns that you want or rows that you want. That is what you are saying. Selecting or indexing means the index position that you are mentioning, 0 or 1 or whatever. Now you want all the rows, and all the columns. What does this mean? All the rows, all the columns except the last column. Do you have the last column? What is the last column?
Total.
Total. You don't have that, right? Total is not there, right? In this? Purpose, right? I think purpose, right? Now, one more thing. Understood? Because I have to do this. Raghu equal to this, okay? And df dot shape Raghu dot shape. So we have to explicitly print it out. The last line is printed. Last line is printed. I said from the data frame select all the rows except the last column. Fine. But that is not going to affect my original data frame. My original data frame still has 1, 1, 5, 6 rows and 7 columns. I am saving it as another data frame called Raghu, and when I look at the shape of Raghu, it has only 6 columns. So whenever you are selecting, the result has to be saved somewhere. Original data frame never gets, that is obvious, it's like a projection. So you need to save it as. So in SQL what you do, you will say what? Select this column, this column, this column as something, right? And if you want to persist it, of course the original table will not change, right? You will save it as another table or something. Same thing. So always, so this is the importance of shape. You can see what is happening in the row level, column level, right? Questions on ilog? But yeah, I don't think like ilog is very important because, like I said, it is sort of like deprecated. Why do you think it is not important?
Because on data we are not, if a very big file, we are not concerned.
Exactly. the column names, if you have a column names, who is going to remember the 6th and 7th position? That's like weird, right? So that is why lock actually came, and mostly we prefer lock, and lock is easy actually. So label based indexing, right? So I can simply say something like this: df dot lock, and I can say colon, comma, I can say start star. So what is happening? Or I can say as a list, right? I can say I want more. There is only one column. I want all the starting and stopping locations, right? What is the column? Stop star. Stop star, right? I don't remember. Stop star. What will happen if I remove this thing, this colon? Doesn't work, right? Because you are saying that rows and columns, right? So you say this and this. Now I think it will work. Just give me one moment. One moment. No, this doesn't work here. Yeah. So since this label based indexing is very common, like people are doing lock these days a lot, and one of the other thing is that normally when you are working with a CSV file or an Excel file, you are mostly interested in the columns, not in the rows. Rows are there, but you want to calculate the average of a column or summarize a column. So these guys have become more liberal, and now they are saying that you should not type hard code like LOC then colon. So if you simply say df of these columns, you will get it. Can you see what I typed? Ideally, what you should type df dot loc then 2 column and all rows, but no. Just want to see 2 columns. This is easy. So this is sort of like a shortcut. And in the actual programs, you will see like this. They won't say lock and all, because it is assumed that you want to look at a column, right? Unless you want to filter on the rows. Right now, I don't want to filter on the rows. I just want to see the columns. I have an interesting question. Okay, not question. I want to show you something. So let's go back to the original way of doing it. How do you do it? df dot lock, right? Then what you say? All the rows and columns, and you get the same thing, right? Now pay close attention. I am going to do something. Pay close attention. df dot lock. I will say colon, comma. Let's say only start. Where is star? Star is missing. Okay, star is there. Just pay close attention. This is the output of 2 columns. I'm going to run 1 column. You find anything interesting? Header, maybe header is gone. That's okay. Yeah, so this doesn't look like nice, right? I mean, so previously the this was, if I comment this, if I'm running 2, this looks very nice in representation. The other one doesn't look nice. The reason is, if you are giving only 1 column, right? If you are giving only 1 column, remember that is a series. This is a series. You remember I told you a data frame is made up of individual columns. So it is printing it as a series. How do you know? You can actually assign it. So I can say ABC equal to this, and if I check the type of ABC, What do you see? Series. It's a series, right? Okay, I understood. So what do you mean, right? But probably in your data manipulation tasks, you don't want a series. I want only one column, but give it as a data frame. I am not bothered about learning series and all. Then only one small thing you need to do, I think it should work, to just keep it here. How many brackets? 2. Understood? I'm just passing it as a list. So what will happen? It will not consider it as a, it will return as a data frame, because these are small things but may become very interesting, because you are working on a very large data and you are doing some selection on a single column, right? And you read it, you selected one column, but the output is a series. Then if you write something on a series, it may not work, because all the functions that works on a data frame may not work on a series. Then you are wondering why it is not working. I just wrote it. So then you might want to pass it inside a single list, so that this guy will be treated as a data frame. Now this ABC will become a data frame. It's a proper data frame now. Try this out if you want. Okay, so if you want time, tell me. I just keep on going to next. If you need some time to do this, then tell me. And I don't think it is there in the notebook. If I share it with you, some of this I make up. So it may not be there in the original file that I'm sharing to you. No, this one is a data frame. Previous one was a series. No, previously I was passing this just as start star. Now I added this thing. I passed it as a list. Then the result will be a data frame. So what I'm saying is, how do I show this? Yeah. So what I'm saying is, normally if you want to select only one column, so let me comment this, okay? Normally if you want to select only one column, you can just pass the column, right? So what am I doing here? I'm saying that df.log, I want all the rows, and the column name is start star. No problem, right? But if I run this, what will happen is that it will create a series. This is called a series. And the only way to identify whether it is a series or not is by doing a type. You can check the data type of this. Series is nothing but a single column. A single column data type is called a series, right? But I can convert that into a data frame. Even though it is a single column, I can have a single column. Imagine like an Excel file with only one column. Possible, right? Nobody is saying that you cannot have only one column in an Excel file. Probably I want it like that. Then I need to pass this inside a list. So look at what I'm adding here. This start star, what am I doing? I'm adding this thing. Here, see, I'm passing this as a list, right? And now if I run this, it will become a data frame. So you need to do this if you need the return data in the form of a data frame. Pass it as, so normally you will use that square bracket if you have multiple columns. Even for a single column, you must use it ideally. Then only the output will be a data frame. Otherwise, it will be a series. Yeah, so lock is, ilock is the number you are mentioning. Lock is the name. So here I am saying lock and start star. If this was ilock, I'll say 2 for third column. Yeah. So I have to mention only the number. And ilock is not very common these days, because you have a CSV file and people don't want to just refer the number, right? You have the label. So label based indexing is actually lock. That is what is common these days. Mostly we use lock. So why don't we do an in-class assignment, right? So I have some interesting assignments. So the thing is, like, the ones which are easy to demonstrate, I do. The ones which are difficult, I give as an assignment, right? Even I don't know the answer.
Using curly brackets, how is it different? If we use
Not
curly
square,
brackets,
right?
Not square. I'm supposing if we use curly or the round brackets.
Square, right? This one, right? Yeah, so this is like a list I'm passing.
I understood this. What if we were to use curly bracket or
No, curly is dictionary. So
give a different output?
So yeah, it will not accept it at all. So the lock is a method which will take an argument as where is your rows and where is your column.
I'm just trying to understand the difference between how brackets are used.
So I am passing a list of elements, not a dictionary is key value pair. So here I don't have a key or value, right? I just have column names. So if I'm passing only one column, I can just say one column. I don't have to use a bracket at all. If I'm passing multiple columns, how do I say multiple? Inside a list I will say.
Okay, that's fine, I got the list. Okay, what about the round brackets?
Round brackets, I don't think it is supported, because if you look at this df.lock method, it says the input has to be a list. I don't think it supports, but let's try since you have asked. You are saying tuple, right? So what if I pass it as a
dictionary?
Dictionary anyway it will not support because it is key value pair, right?
Okay.
So just give me 1 moment, I'll just try this. So what you do, you pass it as a curly, right?
This is round bracket.
Oh, okay, it supports. My bad, it supports. In fact, I have never tried it. Probably learning for.
What does that mean? And that is what is confusing.
So in the method, the input parameter can be either a list or a tuple. That's what it means actually. I mean, as per, but it cannot be a dictionary, I know, because if I'm passing a dictionary, it has to be a key and a value.
Yeah.
But unlike list, it is actually giving you a series only. But unlike passing a list, when we pass the same start within a list, for example, it was giving a data frame.
This is giving me a series, right?
Now this is a series, which is just
That
like,
difference is there.
as if we passed it as a normal string.
Normal string. Yeah. That difference is there. That's what I'm saying. So I passed a tuple, but the data type is a series now. It's not a data frame.
So that's too much information.
So ideally, you have to pass it as a list. The ideal condition is that you have to pass it as a list. If you have only one parameter, you pass it as it is, as a string. If you have more than one, you pass it as a list.
No, but even if we are passing it as a list, you can pass it as a tuple. So if there is a single that.
But it is treating it as a series. That's a problem. That's what I'm saying. You can do, but you will not get it as a data frame. I'm saying. You will get it as a series.
So putting a round bracket is making it a tuple.
Round bracket is tuple.
So that's considering that this column itself.
It is considering it as just like a string. It is not adding any value actually if you are passing it as a tuple. Because even if I remove the tuple, I am getting the same output. Correct. But what if I pass two elements? Let's try that, right? What if I am passing two elements here? Start star, comma, let's say stop star. What is the column name? Now it is giving me a data frame because there are two columns. Two columns are, but if I am passing a single column as a tuple, it will not allow me to construct a data frame.
Does this argument mean that now the ABC, the list that you have, or let's say the frame that you have, is cannot be changed now? It's a tuple now.
No, data frames. No. This is just the columns I have added here.
So since ABC is equal to now, and the argument that you passed, considering those columns are tuples.
No. This means this tuple cannot be further modified, but I can add a column to data frame again. That is possible. These are the original, what you say, columns I have in the data frame.
You cannot make changes to start and stop, but you can add another column in ABC.
Yes. Because that is a property of the data frame, not what I'm passing actually. A data frame by default allows me to add columns and remove columns also. If I want, I can say original data frame should not be changed or it should be changed. Both options are there. But I have seen, so this is also new to me, but I have never seen anybody using tuple so far. I mean, to tell you the real answer, probably I can check why, why somebody should not use a tuple. But I have never seen, because if you're passing more than one values, ideally it's a list of values, not a tuple of values. Usually we use. List is the mutable, collection, which allows multiple elements to pass.
We are passing the argument, right? We are not passing it in brackets like as an argument. We are not passing it.
Oh, this one, this so LOC. So LOC, it is not a function actually. So that brackets will come when you are calling a method, right? This is not a method actually. LOC is a selection attribute. So when I am calling LOC, I just need to mention what are the index. It takes only two separate positions. One is the row, one is the column.
LOC is internally is it a kind of list?
Yes, internally. So it's not a function. If LOC was a function or a method, I'll see that brackets and options. That is not there. So whenever you see those brackets, that means it is a method actually. This is not a method. So why don't you do this in-class assignment? Let's see how many of you can do it. Can you see this assignment? I'll just show you. This one. Extract first 5 rows and columns. Start date and months. Okay. I'll just explain this. I need a data frame where I have 5 rows and only these 2 columns. That's the assignment. So you can use iloc or loc, that's up to you. Okay, you can use iloc or loc, that's up to you. One moment, okay. So even some of the things are very, how do I say, new to me. See, I wrote the solution like this, right? This is correct, right? So now I got another solution where here you put a colon and then you do a dot head.
That's what I did.
Yeah. So see, it is up to you to decide, but normally that is not something we do. I know head will display the elements, top 5 elements, right? But head is normally like a limit statement in SQL. In SQL, you have what? A limit statement. So what is the purpose of a limit? You just want to see the data. Where will you use a limit? You have a 1 million rows. You just want to see top 20 rows. You use a limit. So I can actually do a dot head. You will get the output. But usually when somebody asks you do a selection, okay, what they ask is actually I want specific rows and columns, right? I can also write a dot head. I know, but ideally this is how you should write it. And somebody was also asking, is there a performance difference? I didn't see any performance difference, even if you write a head or do like this. But something like this should be ideally your answer, I'm saying. Well, you are to decide. I mean, if you are interested in doing a dot head, that's also fine.
So I have a question basically. For example, if I want to see the rows with not mentioning these index numbers, I want to see the start date from 1st January to 30th of January.
Sorry, which one? Start date?
I want that index should be on the start date instead of this index.
No, this one we cannot change. This is actually system generated index, right? This 0 to 4 up to 100 is system generated, right? If I want to do any condition, I have to do the condition within the start date. I can say within the start date, I want to filter the data from this date to that date. So that will happen only here. I'll show you how to do that. But this index will not change. Now what I can also do is that I can change this index. Because right now this is a system generated index 0 to 100. I don't want that. I can say instead of this, replace this index and have an index of either date or any column I can add as an index. I will show you. I'll show you. But you need to have a column which you can take it as an index. We'll take an example.
Because by indexing the data retrieval will be fast. What I do.
No. That is different. That is the SQL indexing. This has nothing to do with that. This is just index means is the position. So that is talking about the SQL indexing. That is totally different, right? Because in that indexing, what it does, it calculates the mean, median, and some statistical values of the columns and store it. That is how the retrieval is faster. Here it is just the mentioning of the position.
How do you do with the iLog if you want to use that?
Head.
iLog, just the head?
iLog.
Yeah.
You want to do this in iLog. So how do you do it in iLog?
Because I don't know the column index.
0 and 0:5.
0 colon. iLog, one difference will be 5, right? This one you cannot pass start date and miles. You need to give the column number. What will be that?
Okay, comma, you give 0, 5.
What will be that? Can you tell me?
0, 5.
Okay, comma.
But
No,
if you,
it doesn't work.
No, large bracket.
Raghu, from the labels, for example,
Range
we
name,
just know
colon
the label names which are like start date, miles.
New line.
Is there a routine where we can actually get a index 0 and
Same
5,
as
which we are actually putting a manually 0 and 5?
0 is the first.
So start
No,
date
no.
is 0, miles is
That
5.
0 and
How
5
do
we
you come to know
are actually looking into the Excel
looking
sheet
at the data?
or the data frame,
Ah.
then finding out, okay, this is like manually finding 0 and 5. Let's say we just are looking at start date. So is there a routine?
No. You want to know what will be the number of start date, right? No, I don't think you have to figure it out only based on the position. And that is why iLog indexing is not very popular. Because if I'm giving you a data frame and I'm asking you do an iLog on this column, only way is that, but you can say dot columns and get it. I can say dot columns, right? I mean, you don't have to look at the data frame. What is the name of the data frame? So I can do a columns and I can see these are the columns. Now I can say 0, 1, 2. I don't have to read the entire file to look into that. And then I need to say 0, 1. There is no other way to do it actually. Right?
So I think we can still do, it will be very long, but I think if we do a DF columns, then name itself, I think then only also you can make it.
Yeah.
This is very
Correct.
convoluted way.
You can do that.
Assign the
Okay. So we just did selecting, and I just want to bring your attention to filtering, right? What do you mean by filtering? You can filter the data, right? Now, there is one small thing you need to understand. Filtering works very easily. For example, one of the condition that I want to put is that I want to filter all the trips which are greater than 10 miles. So there is a miles column and I need to filter. But before you run this, don't directly run this. Let us see what will happen if I do this only. So I'm just copying only one part of the code which says in the data frame I have a miles column. I want everything which is greater than 10. Now don't run this. Can you take a guess what will happen if I run this? So the condition I'm giving is that I want to look at the miles column in the data frame where I want all the miles which are greater than 10. If I run this,
It will give us true false.
exactly, because this is how filtering works. That's what I want to know. First, you have to identify the condition. What is the condition you want to put? I want this column greater than this. That's a condition. Now, if you only run the condition, what will happen? The condition will be either satisfied or not satisfied. You will get true or false, basically. But I don't want this, right? I don't want this. I want all the trips where more than 10 miles is required. That is where you need to add the condition like this. So basically what you do is, instead of this, you will say, I want to create another data frame where I'm using the lock and I'm saying that I want all the miles greater than 10, comma, miles star. And if I do a df2, well, another thing is that why are you doing this, the last mile star? Then only it will display the column. If you simply add the filter condition, it is not going to display the columns. Then you mention, so do you want one more column? You add it, right? I also want what? Start, right?
If I want all the columns,
Start, date, star.
You can run the first statement also by just starting square brackets and another df.
Sorry, I didn't get the first statement.
Yeah, just start another df and square brackets around it.
Like df miles.
No, start with df, then the entire thing, this entire statement in square brackets. Df of.
You can. So this one, this entire statement you're saying, right?
No. I mean without the lock.
Okay, without the lock, only this. Only this.
No. So the first statement that you ran. So df minus greater than 10, the condition.
This one.
Yeah.
So
So add
df
a
at square
df
bracket.
in the start.
Add another df.
Yeah.
And then square
And then
bracket.
rest something in square brackets.
Give me one moment, okay.
And do the square bracket.
Give me one moment, okay.
Yeah, it will give only 2 false and another data.
It should give the entire data set.
No, it won't.
What happened?
So all the minus greater than
All
10
the minus greater than
All the
But now what is happening? Yeah, so that's correct, right? But you get all the columns, right? You are getting, so you are simply saying that in the df, I just want to apply. Yeah, that is absolutely possible. So you are just filtering that. But what will happen to your original data frame, do you think? Because the conditions that you are adding, right? It is sort of like you are filtering it based on that, right? So, so this is one way to say that, but here you are saying that I want all the columns. So here the only difference is that, so I told you, right? It is not mandatory, you should use lock. Lock you can remove. So I can simply say df of this thing, and then I can say I want only specific columns. That is also possible. Yeah, so here the only difference, I want only 2 columns. Here all the columns will come.
So one is remove the dot lock from the line.
Ah.
I see an error. I'm not sure why that is.
Where?
The thing.
Here.
Yes, just remove dot lock and then just try it.
I think if you remove lock, then
Which one?
the syntax is incorrect, right?
Yeah.
Here.
Something like that.
Okay, just give me 1 moment, okay. There is an error. So can you tell me why there is an error coming up? Okay, I know why the error is coming.
So you'll have to put two different brackets on the first statement as well.
Where?
No,
So this df
actually the
minus
error
greater
is
than
coming
10,
because
on the
the
bracket.
value it is taking as a df in a true or false, right?
Ah.
But here actually we are taking the 2 columns to point it out.
Yes.
So basically the input would be as a series, not as a data frame.
Okay, so what will happen?
Yeah, this will change the df to yes.
Understood. So you cannot pass that, right? That will be immutable. So you cannot say that I want to put this true or false condition and then pass 2 columns. That doesn't work, right? So that's not a syntax error. So whenever you are doing filtering, what you need to do is that either you apply that to all columns, or if you are picking selected columns, say iLog, or you remove it and then you say apply that only on the certain columns. Now previously what he was doing, I mean what he was asking is that why it was throwing an error. So after this I was adding 2 more columns. So that is not possible. If you are doing like this, you are applying a condition. This is like a true or false condition. So this will apply to the whole data frame. So now from this probably I can say I want to select only certain columns. I have a df2 now. From the df2 I can say I want to project only 2 columns. In this statement I cannot say that colon I want to add only 2 columns I want to apply this. This has to be applied to the whole. It is saying series object immutable. It is treating it as a series. So this condition it is treating as a series. We ran it, right? Let me show you. So what was the condition we added? Yeah, you can have an and or. I will come back to your question in a moment. Okay. You can put an and or. I will show you examples. Okay. So, but basically what we were doing, I forgot. So what we were doing, we were saying what? df.ilog. Sorry, df.lock, right? Then what was the condition? df of miles greater than 10. Then what was it? What was we add? What is that we were? So I put it in this start date star comma miles star. Right. So this is a simple filtering that you can do. Okay, sorry. Let me just do a df2 dot head just to remove this. Right. Now, so this is somebody who was asking. You can also directly apply that. So here I am doing a df dot miles greater than 10 dot head. So basically, if you want all the columns, then you don't want to say select specific columns. You will get them, right? Now, one more thing which is interesting is that what if you want to find out all writes to or from carry, right? It is not to carry. From, let's say, New York, right? So in that case, what will you do? You will say the column name equals to what you can do? New York, right? And then do this. All right. So here you have a string column. Start star is a string column, and you can do a equal. And one of the things that we commonly see here is this is in operator. This is very common. What is this is in operator? So you want to match multiple conditions. For example, I want to select the start location, find out all the writes that is, starting from carry and Morrisville. So if you want to, look for multiple locations, you can do this. Or let's say you want carry and New York.
Is all right? Not and. Carry all find out. All right.
No, it will match with both.
Yeah, but it's or operator.
Operator, yeah. So if it is having either carry or New York, it is going to give you the answer. So, and if I do let's save it as something. So let's call it as my rights or something. And if I do my rights of head equal to, sorry, dot head equal to 10. So here you have matching with carry and New York, and in the sense either if it is carry or New York, it is going to get it. So this is in operator is important, and I don't want to actually get into the discussion, but there is something called regular expressions also. You know that, right? So you can always write a regex. So string operations, whenever you do, you write a regex to exactly match or select starting with this letter, ending with this letter, these things.
Raghu, if you could go back to the place where you're creating df2.
Hey, this one also has that, these new.
Yeah. So when we are filtering, the row numbers don't seem to be updated.
Oh yeah. So yeah. So I wanted to clarify that. I think somebody asked during the break. So this is very important. For example, let me show you something. So what did you do? You did a filter, right? And you have my rights. Now, if I do a my rights dot ilock, I'm doing a my rights of ilock, right? And I'm saying that 0 to 5, okay, comma, star. What does this mean? I want the, this will work, right? But if I do a lock, okay, I will get nothing. Why? Yeah, this is very, very important because see, you are doing a filter, right? Oh, sorry. You are doing a filter, right? After the filter condition, you are picking all the writes from carry and New York, and first 6 writes are not there. It is starting from 7, probably, I don't know, 7, 8 and 10, 22. So when you say LOC, it is the name based indexing. So column names and row names, not row position. So when I say 0 to 5, nothing will come. I have to say 7, 8 and 10, then only I will get it. That is also a confusing thing because if you are using LOC, this is the name of the row, not the position.
Is there any way we can refresh it?
Yes, I will show you. There is one example. So normally in these cases, what we do, there is a technique called reset index. So I stored this as my rights, right? Now the problem is that in my writes, the index is what? 7, 8. I can say there is an option called reset index. Okay. So if I do a reset index, this will start with 0, 1, 2, 3. But I have some more things, I'll just show you how to do that. But that is one thing we commonly do.
That comment is wrong. Find out all rights from it should be.
Oh yeah, from so not to. Yeah, change it. I think I also changed somewhere by mistake. Yeah, so this is all rights from Cary and New York, right? GF dot. If you do DF dot, no, DF should work, right? Because DF is my original data frame. So if I do DF, what is DF? That will have original. That is never going to change. But I'm saying if I do my rights, that index is different because it is filtering only those columns. Here. Oh, here you are saying you want to use dot. You can do that also if you want. This is the easy way of doing actually. Ideally, you should say dot lock and then select a column. But Pandas actually allows you to directly access the column. That is also possible. There is no difference actually, because originally, so how it happened was that originally when data frames came into picture, we had only iLock. There was no lock actually. But then it was really problem because the column indexing is very difficult. Then they introduced this lock, and when they introduced this lock, they said that, okay, since to differentiate them, you say lock and iLock. But if you are very comfortable, you can just say column name, it will work. In this case, because first of all, you are mentioning the column name, right? If it is iLock, it has to be the numbers and then it should work, right? So I will just remove this. So what I will do in the interest of time, I will just, how do you clear this? I'm not able to clear the output. Okay, so why don't you do something? I'll give you an in-class assignment. So just like all the assignments, find all the trips with distance greater than 10 miles and originating from Cary and Morris. So what is the condition? It's a filter, okay? You want to find all the trips with distance more than 10 miles and originating from Cary and Morris. So what is the challenge that you are going to have? You are applying two filter condition. How do you apply two filter condition? And put a and, it will be two filter condition. And when you are putting an and, what you should do? You should put a bracket. So bracket and bracket. Just give it a try. I mean, I'll just give it as a try. If it is working, fine. But otherwise, there is a documentation which we have, like when to use what. But usually, but this is very common, right? Even in other programming languages, when you have an and or, you put them in a bracket, right? In SQL, you do, right? Now, here and is and, or is pipe character. I think in some other places also we see and pipe, right? In SQL, what you say and A and D, or is OR, right? Here it is ampersand and then pipe character, or character, or condition. You can't use or and no, you have to use this thing and or. Let me try. I mean, I don't know. I'll just try. That is what. So try this. This may take a time. So I'll give you the rough idea for the answer, right? So you will have LOC for sure, lock, and you will first have a square bracket, right? And in the square bracket, you will have a circular bracket. Here you will say what? The first filter, miles filter, you will come here, and you will say and. In the second bracket, you will have this is in, Cary and New York. Whatever, right? Even I don't know, I just have to try. I mean the answer, right? I should see if it is coming. So give me one moment, I will just try the answer. So somebody who got an answer, I mean then, oh, very good. So, great. So a lot of people actually got answer, that's good. So that means my question is correct, at least. I thought I was the only one who will get some answer.
And sir, for or there is two pipes or conditions.
Or pipe.
A single pipe or two pipes?
One pipe. That's what I think. Can you add the pipe and say? No, here it is and ampersand for condition, only in filtering conditions. So Pandas supports normal Python, you have and. Here or will be pipe. For filtering, for adding conditions. Oh, I think. Okay, one more small thing. See, one small thing I want to tell you is that this bracket and this bracket are different. Do you understand, right? This bracket and this bracket is different. Why? One is a method you are calling. The other is just implementing two AND condition. So it's not like wherever it doesn't work, you add a bracket. Okay. Okay, chalo, come on, one more bracket. Maybe it will understand this time. Oh, it is working. But this is for readability as well. Like you're saying that this is one. But this is different, I'm saying. Like this is easing is actually a function. Okay, somebody was asking a very interesting question and I wanted to answer the question, right? Can you guys have a look at what I'm going to type? Oh, why there is only 4? There is only 4 actually. Why I'm getting only 4? What was the question? Oh, what is the spelling? M-O? This one? It is C-A-R-Y. M-O-R-I. What is this?
No, only Morris is there, not
This will work, right? Now I have a very interesting thing I want to show you. So I created something called DF3. Now a lot of you were asking that, hey, there is a problem because if I look at DF3, the index is starting with 28. So you can do a reset. You are resetting the index of a data frame. But couple of problems. What are the problems you identify? So when you do a reset index, it will add an index column, but this column will remain, right? Also one more thing, very interesting. Look at DF3. It will not change the original data frame. Are you getting what I'm saying? So I did a reset index, okay. So what happened? There is an index column added. I'm happy. But problems, one, the existing column is there. Second problem, my original data frame doesn't change. So let us solve the problems one by one. Okay. First problem I am going to solve is that I want everything in the original data frame. So you can say, so this argument is very important, in place equal to true. What it means is that change the original data, right? So I am saying that reset the index on DF3 and I want that to be on DF3. So if I run DF3, what happens? Now the DF3 is changed, right? Original data frame is changed. So by default it is in place false, meaning it will not change. Now what is your problem? Original is changed now. I want to change it, right? Because this is my filtered output. In the filtered output, I want indexes from 0, right? I don't want this. I don't want this. I want this. So that is why I'm saying in place equal to true. Reset it. No, now the problem is this is anyway there. I want to remove this. This is my old index.
in reset index, when I am not passing any that parameter.
Then it is false. By default it is false.
It is not
CSV dot.
It will not work. So what I'm saying, so guys pay attention, no? So I mean this is a bit confusing. If I say simply reset index, right, what will happen? It will reset the index, but the original data frame will be unaffected. So what you can do? I can save it as another one, right? Are you able to understand what I'm saying? Are you able to understand? right? But I don't want this because I wrote a filter. The output of the filter condition is df3. I want df3 to be my final answer. I don't want to create another df actually. So what I can do is that here itself I can say what? In place equal to true. Oh, sorry. Sorry guys. I can say df3, I want to reset the index, in place equal to true means my original data frame reset will be index set reset. But again my problem is that this 2834 remains. So I can say drop equal to true. That is your final answer. It will drop that previous index. Yeah, so this indexing will be very confusing. So I will probably draw, that's easy, right? Rather than talking about this. So what I did, I had a data frame, right? I have a data frame. Let's say only 3 column. What is the index default? Like this, right? And let's say here you have a column called name and you have a column called age. Okay, so here you have some guys A, B, C, D, E, F. Age is 1, 2, 3, 4, 5, 6. I wrote a filter where I said I want age greater than 4. So this data frame is called DF. This is DF. What is the index of DF? 0 to 5. I wrote a filter age, I want to apply the filter age greater than 4, right? And this filter will be created as another data frame, right? DF1, because I'm saving as another data frame. So if I visualize DF1, what will happen? How many rows will be there? So it will have 4. Is this clear so far? Right? So now forget this. Forget. Because we are doing filtering. Now this is my data. Now my problem is I want to access rows and columns and everything. But my index is starting from 4. I don't want this. I want to reset. Right? So that is where you say in df1, I will say df1, okay, dot reset index. The problem is if I run this command, it will reset the index, but the original data frame will not be affected. Then what is the use? Right? I want df1 to be my final output. But if I say reset index, it will not change anything here. That is where you are saying in place equal to true. This means change the original data frame. So it will just remove from here. This will become 0. This will become 1. But the problem is now it will add one more column for your 4 and 5. You had 4 and 5 here, right? It will come as one more. So this is old index. This is new index. So to remove that, you can also say drop equal to true. Meaning drop equal to true means it will drop this column. This will be a final data frame. Well, it's a bit, complicated to understand, but that is what is happening. You are resetting the index and removing the old index. That's what you're doing, right? So you'll see these things when you work sometimes. And sometimes the requirement will be totally different because I don't want to touch the original data frame. Then it is fine. I save it as another data frame and work on my things, right? DF will anyway remain as it is because after filter, this is my new data frame. Filter will not affect here. This will remain there.
Use case of having in place. Will there be any use case where we don't want to commit?
Yeah, there can be many places. So this is where I want to change, but in many cases, so a use case will be that I have a data frame which is used for multiple purpose, not only one purpose. So I want to apply a filter or reset the index for my sub project or whatever I'm doing. But maybe somebody else is also accessing the data. They don't want to shift the index probably. So I will keep it as it is. So I will always say that either read it as a separate data frame, then I can do my activities, right? That depends on the use case, what we are working on. In the point of time, I'll just quickly show you some more things. All outputs clear. So there is a sorting. Okay, I don't want to spend a lot of time on sorting, but basically what you can do is that you can do a sort values by the column. You can say ascending false and head. So it's very simple, right? You are saying that the column is miles and ascending is false and then head. And you can also sort by multiple column. So what are you doing here? You are sorting by start and miles. Can you take a guess how this will work? If you want to sort by multiple column, first it will pick up the start, it will sort them in true. True is ascending order, A, B, C, D. With each, it will do a miles sorting in descending order. So I'm basically looking at all the trips in the alphabetical order with the highest length first, right? Because this is descending, right? So sorting we will see later. I mean, as of now, you just need to understand how to sort. So you look at here. If I do a head of 20, so see, it is starting with Agnew, Apex, A, right? And within Agnew, it is again sorting 4.3, 2.4, 2.2 like this.
If you don't give that ascending thing, then by default it will be all ascending.
By default, everything is ascending. You have to say false for descending. So that is one thing I want. And probably we will look at one more thing, then we will finish. Okay, in the time that we have, right? I will look at one more thing because see, this is very important. Conditionally adding columns. So you want to add a column. Now adding a column will make sense if you are doing some analytics, right? For example, like I said, I want to find out all the trips. I want to apply a condition. So there are trips and I want to categorize all the trips less than 5 miles as short trip, 5 to 10 medium trip, anything more than 10 is long trip. Then that I have to add as a column. Now for adding a column, you can use any technique that you want. You can use normal Python code for a condition. But here what I have done, I imported this library called the Numpy. We will talk about this a little bit more. So you will say import Numpy as NP, and this is how you add a column. So you are saying that I want to add a column called milescat. Okay, there is a very interesting function called np.where. This is like a if-else condition. What it does, it is saying that if miles is greater than 5, mark it as long trip, else short trip. Now you may think that what if I have 3 conditions? I will show you how to do that. Right, but right now we have only 2 conditions. So I am saying that look at the miles column. If it is greater than 5, it's a long trip. If it is not, it is a short trip. That's all I am giving, right? And if I run this, I will show you what is going to happen. So I'll just run this. Probably do a head of 30. Can you see? Now there is a new column, right? Called long trip. So that is a miles category column. So each it will apply this condition and gonna say long trip or short trip or whatever. So if you are having a quick if else thing, this np.where is very useful. Now what if I have 3 conditions? So I want to categorize to short, medium and long. You can do one more np where. I'll show you how to do that. You can sort of like an and it and say that, and it or it and say that this condition doesn't match this condition and this condition. So multiple conditions are possible. Now I don't remember exactly, but I think we can do this also. Let's say, but this is not really a good thing to do. So let's say I want to add a column. Let's call it as my year. I can say np.array. I mean, this NumPy has a lot of built-in methods. So there is something called a NumPy array. So right now what I did, I just added only 2000. So what will happen everywhere, it will get added as 2000. But if you are statically adding, then you need to pass every year, because this has how many columns? 1000 columns. So I need to pass 1000 values here if uniquely I need to add in the NP array. Right now if you give only one value, it's just gonna just add it everything. I mean, this is not useful if you are adding an year, but some common thing if you are adding, you can just say array push one number, it will populate that column. So now we have an extra column actually. You can also drop a column. We will see. This is adding a column. You can also drop a column. We'll discuss NPy. Okay, so that should give an error. Let's see. 2000 comma, let's say 2010, right? Yeah, that. That's what I'm saying. So if you are passing only 1, it will just replicate it. Anything more than 1, that equal number of rows you need to mention. Yeah. Or you need to write a code saying that read the rows and then apply. So that will be more complicated. But we'll discuss NP arrays. So NP arrays actual use case is not this. This is, I'm just showing an example. NP arrays, Numpy arrays are used for matrix manipulation and all. We will see that tomorrow. Okay.
So to add any column, we have to use this Numpy or
No. This is one condition where I'm using np.where because, or I can also write a normal function. So there is also, I can write a function, normal Python function, and then pass and get the output.
Can't achieve this function if that else thing in a Pandas?
Which one?
This why we use NP here instead of PD?
No, so this where is inside NP only. In Pandas, you don't have a where condition actually. So this Numpy library only has this where method. Pandas doesn't support a where method condition, right? Or other ways of adding column is that you can normally say, you can have a filter and say that the output I need to pass it as a column. Okay, so I say filter, then something. That is also possible. I just thought of showing you this np.where method because that is very common. Because most of the filtering you want to do an if-else kind of condition, right? If some condition is less or more, you want to. And there is also one more method I will show probably tomorrow. It's called apply. There is something called apply. Apply is a function in data frame where what it can do, it can take whatever logic you are written and apply to a set of columns and then manipulate it. So I will show you a couple of examples of apply anyway. But I think we are good at like basically reading a file into a data frame and at least basic selection, indexing, filtering. Then what did we cover? We covered sorting, selection, filtering, date format, also basics of how indexing works, right? How to reset it, how to save as a data frame. Well, then when you actually work, more methods will come, right? Now let me also see what we need to cover because we have to go to Numpy also. Okay. Yeah, since you have asked. So what if we want to do this, right? In class assignment. Create a new column with the following condition. I'll give you a clue. I'll give you a clue, but think if you can figure it out, how to do this, right? I will write a clue for this. So the clue is very simple. You will use two np.where conditions. In the first np.where, you will say if the distance is something, you will mark it as long trip. Else what will happen? Else the next np condition will come. Right? First np.where will say if the distance is more than 10, it is long trip. Okay? Else the next np condition where it is medium and short. Are you getting? That is two np.where you need to use. That's what first np.where will say long trip is more than 50. Else second np. In that you will say medium and short. Yeah, nesting sort of. Even I want to write, but I will give you some time. Let's see if you are able to do something. Right? So are you still afraid of Python? Like, so you are very much afraid of Python, right? It is manageable, I think. It's not like too difficult to understand. Practice requires. Okay, I also wanted to tell you this. Where is the marker? Can you search for this book? There is a very good book, in fact an excellent book. It's called what? Python for Data Science. Data Science by Wes McKinney. I'm not sure about the spelling. I think it is Python for Data, name is Python for Data Science. think it's Wes McKinney. Is there a book like that? Do you find a book like that in Google or somewhere? Sorry, Python for data analysis, not data science, data analysis, right? Python for data analysis by Wes McKinney. So that is a very good book. And if you really didn't like data frames and pandas at all, right? And if you have anything against me, you talk to this guy. He is the person who invented data frames and pandas, Wes McKinney.
Sir, I think in this case, it will return all the, multiple tuples, wherein if the trip length is more than 5, it will consider that as well as the, as the medium trip. But the fact is that we should be writing less than 5 short trip, and then writing the.
Now, first, what will happen? It will check if it is more than 10. That's a long trip, right? Anything less than 10, what will happen?
Then it will.
Next condition will come.
Okay.
So if it is 8, what will happen?
Medium.
If it is 8, it will fall to medium because 8 is more than 5, right? It will not go to short, right? Will it? I don't know. No, I don't think so, right? That was your question, right? I don't think it will. No, right? It's fine, right? Okay. I don't know. I just wrote. You guys also check your output is correct then comparing with me. Don't believe me, whatever I'm writing. So Wes McKinney is the person who created data frames and pandas, actually. And this book is very good if you are looking for some reference to read, actually, and very good book. So you can probably get a e-copy or something. And somebody was asking how to learn Python, right? And I gave couple of things. First thing is that you have about 2 months time because tomorrow your statistics will start. Next month is also statistics. Then only your ML will start. So this is Feb, right? March, April only I think ML will start, if I'm not wrong. I don't know whether ML will start along with statistics. Then next month. Still you have 1 month time, right? I think that should be more than enough. I will also be sharing some practice and assignments. There is a notebook called Basics of Python, where it talks about what is a list, what is a dictionary in more details. I will share that. Then some assignments and solutions for pandas and data Numpy. So tomorrow, what is the plan? I will spend 1 hour on data frames. Some more concepts needs to be finished. So we'll roughly spend an hour on data frame. Then 1 hour I will spend on Numpy. Numpy, the problem is I don't have data like this. See, data frames are easy because you get some Uber data. But when you're teaching Numpy, we don't have any data. So like ones and zeros or 5, something I have to create. The real data I don't have. So that part you may find it a bit difficult to digest. So I have to statically create the data, right? Because the real applications are different. But you need to spend some time on Numpy. So probably an hour we'll spend on Numpy. And then we will spend some time on visualization. Seaborn and Matplotlib. Visualizations, even if you can understand 4 or 5 types, that's enough. There are a lot of in-depth visualizations, but even if you understand the basic 4 or 5 types, that's enough for you. And then if I get time after that, probably you will get, I'll show you some data extraction methods if possible, like collecting the data from an API. So far in the activities, we have done selection, then filtering, adding a column, and then sorting. This is all we have done. And now 2 more things which are important in case of data frames. One is called an operation called grouping. Grouping the data. This is sort of like something that everybody want to do. Group and then apply something. And after grouping, there is something called an apply method in data frames. I'll talk about what is this. So this grouping and this apply, these 2 things are actually what is pending, right? And what is the idea of grouping, right? So normally when you say grouping in the statistical terms, this is called SAC, which stands for split, apply and combine. Split, apply, combine. So even though it's a group operation, we technically call it as a split, apply, combine operation. That's what we call. Why are you calling it as split, apply, combine? Because when you want to group something, right? So you remember the Uber data, right? So we have the Uber data. So one common situation is that I want to group all the rides based on the start city. So multiple rides are there, right? So my intention is I want to group it based on the starting city. So you just don't want to group it, right? So my splitting column will be, the starting city, start location, group. And then probably from each grouping location, each starting city, I want to calculate the average distance traveled. So let's say there is New York. There are 20 trips from New York, right? I want to know what is the average length of a trip, right? So then your apply column will be again the miles column. And the apply function is going to be mean. So basically you are saying that group by the start column, right? And then take the miles column for each start location, say New York. So miles column will have, let's say, 10 trips, 10 different distances for New York. Then apply this mean function on them. So 3 activities you do, that's what I'm saying. When you say group the data, first you take a column where you want to group it. And then you find a, so that is why it is called split, apply, combine. Then you take the next column where you want to apply some function. In this case, I'm interested in the average distance traveled. So I'll say mean. Or I can also say what is the maximum distance traveled. So I can say max. Or any function that I want. Or I can write my own function then apply there also. That is also possible. But this is the general logic that you actually do for grouping. And we can actually see this. Now, if you are running this notebook today, so the same notebook we are using yesterday, right? What you need to do, since this is a fresh day, you need to import the libraries again. Otherwise, it will not work. So you can just scroll up, right? And you need to first import Pandas as PD and read this Uber data and do a head. So do this. Once you import it, do a df.head and you can see the data. Then you can scroll down because these things we were covered. And if I scroll down again, sorting, columns, group by. So what I'm going to do, I'm just going to insert a cell above. Okay. And how do you do this is same thing, df dot. So I'm going to group the data. So the function is called group by. And I want to group by the start location. Okay. So it will start it. And then what is a column where I want to calculate something? That's a miles column. So I'll say miles star. And then there is an aggregation function. So I will say AGG, that's my aggregation function, and then mean. So this is the general way of writing a grouping. You will first say group by, then you pass say one column. You can also pass more than one column. So right now I'm saying that I want to group by start. So it will pick up all the start. See, Agnew, what is that? Apex, Arabi, something. Okay, Austin. So that is a start column. For each start, I want to calculate the average of miles. So you say miles dot AGG and then you say mean. So this is called the aggregation function, this AGG. There you can say what function you want to call, what is aggregation logic you want. And by default, I think depending on the Pandas version, but it supports mean, median, min, max, and certain other mathematical operations. And if you want more, you can also use Numpy along with this. But as of now, just for a simple calculation, this is how you find it out. Now, what is also interesting about this method, now it depends on the Pandas version. If you can find this, right? You can also do this. Look at here. So this is a bit confusing. So normally when you're doing an AGG aggregation, you are saying that I want to calculate the mean, right? But in simple terms, probably I can also do this, I'm guessing. Yes. So since mean is a very common operation, right? Average is a very common operation. You don't have to explicitly say aggregate and then do an average. You simply say mean, it will do a mean, right? But the common format is you say AGG and then you say mean within that. That's a common format. But sometimes if you simply say mean also, it will work. For this, so what it does is very simple. It takes one location. This is Agnew or whatever. So if this has 10 trips, mean is the average, right? What is mean? It will add it and divide by the total number. That is mean. It will pick up the location first, Agnew. So you are saying that group by start location. So first Agnew. Let's say Agnew has 10 trips, right? And then it will pick up this column, miles. So all those 10 trips will have kilometers and miles, right? So 10 different kilometers. It will add all those 10 divided by 10. That's the mean value. Now, I have a question for you to guess. You can try, but don't try. You can try and give me the answer, but don't try. Take a guess. Okay, what will happen if I do this? I just have a small question. If I remove this miles column, right? I'm just saying group by start, just mean. Do you think it will work? Should not ideally, right? But it works actually. Right, I mean, so this is again, so these are some of the shortcuts that are there. So what is happening here is that you are saying that I want to group by start location. So it'll pick up start. Then you're saying that I just want the mean. Mean of what? Well, there is only one integer column. So it calculates the mean. But if you have multiple, it may throw an error saying that, or it will do both in some occasions because it doesn't know. So for quick analysis, what we do is that if you are having the data where there is only one integer column, everything else is string, it understands that you cannot have a mean on strings. You say mean, it is, you are probably thinking about miles column. Okay, I'll give you the miles column output. So if you see this, you have to understand that the real query is not like this. The real query will be in miles dot agg mean. That is sort of like a shorthand notation you can say to represent. So sometimes for quick, code, we write like this. Just take the df and show me the mean. So it doesn't really care where is the mean. So you can just say group by start and mean. Very easily you will get. Same output you will get. You are interested in something like this. For example, let's take start and stop. And okay. So we have start and stop, right? So there is a start column and there is a stop column. Now I want to do group by both columns I want. That is also possible, right? I want to do a group by on start and group by on stop. Okay. Probably here I want to calculate something like a mean or something like that. And here I don't want a mean. I want to probably calculate the min or max or something, right? So the common situation is like you have the rights data and I want to group the data based on the start location. So for each start location, I'm interested in the mean distance traveled. Okay. And then I also want to group it based on the stop location where he was going. And I want to know based on the stop location, what was the longest. So if you say max, that is typically like the longest or min can be the shortest trip. So if you want to combine them, that is also possible. So how do you write it? It's actually very simple because again you will have your group by column, but now what you will do is that instead of passing one column, what do you need now? You need two columns, right? So how do you pass two columns? Yeah, within what? Within a list, right? So you will say start star, then what? I want stop star. Is it stop star? Yeah. Or let's do something interesting. Probably you want to group between start and stop, okay? And then you want to calculate, let's say, the mean and sum probably. Let's say that is the idea. So what I will do, I will say dot AGG. So AGG is my aggregation. Grouping columns are start and stop. AGG is my aggregation column. What you want to do, you want to calculate the mean and sum. So again, two values are there. So how do you pass two values? You can say in a list, and you can put them as strings. You can say mean, and then you can say sum, right? And probably I can do a dot head, right? Just to see. Okay, this is something very interesting. I will talk about this a bit more later, like how do you read this data, right? But I'll just talk about, oh, by the way, there was an assignment. Let me just check. So can you make some sense from this output? What are we getting? I showed you the query I wrote. I showed you the output also. What do you infer from this? What does this mean? If your customer is asking what is this, what will you explain?
It's grouped by on two parameters.
From Agnew, so how the grouping is working here? That's my question. First it will pick up start. Okay, then so let's say Agnew. Then what will happen? Yeah, so for Agnew, then you have stop locations, right? From Agnew, you again have stop locations to where you have traveled, right? Then it is calculating the mean and then the sum for each, right? But this looks weird, right? Because the columns are weird, right? If you look at the columns, do you find it weird? Yeah, it is weird. Because this is a nested column. I'll just come back to this in a moment. I'll show you. If you do a dot columns, you can see that these column headers will be nested. So if you are presenting this in a nice format or something, if somebody looks at it, they're like, okay, so what do you mean by this? You know, so it's miles, then mean, then stop. What do you mean, right? So you need to just reshape the columns. I'll show you how to do that. But basically, what are you doing? You're grouping by starting and stopping, and for each you are calculating what the mean you have and then the sum you have.
Where have you mentioned miles in the statement?
Where?
In the statement that you've written.
Oh, I have not. So it is automatically taking miles. I mean, since we have only one column, it will pick it as. I can also add a miles manually. It will read it.
And we only do one column that's integer. It's automatic.
Yes, that is why. So previously we looked at it, right? So if you look at here, this command, where is it? Where did I write? Oh, I deleted it, right? Yeah, so if you're having only one column, by default, if you calculate a mean or something, it will by default pick up that column. But if you're having more than one, you have to say miles and then do that.
Okay, I'm sorry if you've already covered it.
Oh, yeah. So yeah, but yeah, that's correct. So ideally, when you write the code, you have to mention that your column is miles, right?
If we have float and then it will be
Yeah, so then you have to say which column you want. So if you have more than one column, then it will not automatically do. So it depends on different Pandas version. So in one of the Pandas versions, what it does is that it will do that for both. So if you have like 4 integer columns and 2 float columns, for all 6 columns it will calculate. That is also not something you don't want. You want only specific column. So you have to say group by, then the whatever columns you want. Then in square list, you have to say this column I want, right? But anyway, if you have understood this, I have an in-class assignment for you, right? Look at here. Can you, okay, so this is again same thing, right? You are grouping by start, miles, then mean and head. This is already we have done, right? This is same thing we have done. And you can also do like this. For each start location, find the mean and the total distance traveled, for example, like this. So this is slightly only start location we have. In my example, I calculated start and stop. This example, here you have only start location.
How to label this?
I'll show you. So right now the labeling is a bit weird because if you look at here, you know, I actually have only 4 columns. The first 2 columns are fine, but you know, again here you have sort of like an indexed columns. Now we can actually do one thing. If you assign this to a variable, now if I am assigning this to Raghu, and if I do a Raghu dot columns, what it says, multi-index levels and then labels. So basically what is happening is that it is nesting. It is actually nesting your data. I will show you how to remove it and add proper column headers. But right now, can you try this in class assignment? Find the most recent and the earliest travel date and mean distance travel for each start city. So like in every class, the assignment is more complicated than my explanation usually, right? But before you try this, let's try to understand the problem, right? So what do you want to find? The most recent and the earliest travel date and mean distance travel for each start city. So let us break this down. What will be the grouping column first? So you have to say group by start, correct? And then, so this is first level. Then once you group it, you want to apply some logic, whatever it is. That is on where? What is your, aggregation columns that you are talking about? No, dot AGG is, so that is where you apply the function, not that. On which columns you want to apply the function? Find the most recent and earliest traveled what? Date. So you have two columns. One will be date, one will be miles. So the grouping will be start, right? Then the aggregation columns, two will be there. One will be date, one will be miles. And then the function. On miles, what you want to apply? I don't know what your each mean distance. So here your AGG will be what? Aggregation function will be mean, correct? On date, what it will be?
Minimum.
So we want to find out the earliest, what is that? Earliest and most recent. So we can say min and max. If you have a date, you can calculate the min and max. Min date will be what? The first ride. Max date will be what? The last ride, recent ride. So here you can to say aggregate, you will have min and max. So this is how you break down the problem. First, you want to find out what you want to group. So that is for sure start. I want to, from each city, I want to find something, right? Find on what column, right? So on date column and miles column, right? On the miles column, I want to apply mean. On the date column, this. But don't try this. Don't try this. There is a trick. This may not work if you write in any ways. Why? I mean, the logic is correct. But you need to do one small thing.
So start date and start and date.
No, I am not talking about this method. There is one small problem because if you want to work on date, this date is string.
Data string.
So what do you do? You have to convert to date type. So how do you will say PD dot, convert to date format, right? Probably I'll help you with that because one more problem is, can you look at the last row of our
Date should be minimum, right? The earliest one.
Which one?
As per the problem, it should be the earliest one, right? So it should be the minimum, right?
Earliest and recent. Earliest and recent means the first trip and last trip, right? Yeah, that is what I meant. I mean, earliest and recent will be same or what? No? What do you mean by earliest trip? First trip. What do you mean by recent trip? Last trip. It will be min and max, right? I don't know, maybe my English is bad. Yeah, I want to find out the first trip and last trip. That is the logic basically, right? So don't do this. The problem is you need to first convert the date to the date column to the date format because it will be string. How do you know? Because do one thing, create a new column and just do a, what is, df is our this thing, right?
Dot d types.
It's an object for sure. Start date is an object, right? Now, if you do a df dot tail, now you have a, so what do you understand from this? No. See, the last row we don't want. The last row is what? Something we don't want. So from the data frame, first you have to remove the last row. Okay, so tell me, how do you do it? Df equal to df dot. So why don't you use ilock? I want all the rows except one. So the first task is that you are removing the last row. So you will say df dot ilock colon -1. That means all the rows except the last one. Then again column, because I want all the columns. I'm not interested in the removing any column, and assign that back to df, because otherwise it will not affect. And now if you do a tail, you can see the last row is removed actually, right? Now what you do? Convert that to df of start, what is the column name? Date star, right? Date star equal to pd dot to date time df of Now you can think about the logic. So now just see if you can build it. I will also help you. I'm just giving you some time, so probably if you can try it out. You can see.
Some error, EOL while scanning.
While writing the statement, right?
For this statement, I can't.
This one?
convert. Yeah.
This one?
I can't convert the one.
This one should work, right? Which one? The ilock one?
The second one, I'm not able to convert it.
Are you sure this is exactly how you typed it? Because yesterday we did it, right? Yesterday we converted this column. df, this is in list, square brackets, equal to pd to date time. There is a bracket of df, again a square bracket. Is there anybody who's not able to do this daytime thing? Why? We were all doing that yesterday, right? What error you are getting? Not the assignment. I'm just talking only about converting to this. Forget the assignment.
For me, ilock is not existing. It's telling that to use log.
Yeah, so some of the problems might be, you might be using a very recent version of Pandas maybe. So it might have, sort of like removed the support for ilock.
It's giving an error for the viewer. You have created a view of it.
Which one?
-1. Df equal to the view of it.
So this ilock, if you don't want, you can use lock also. Here, what is your problem? Because group by column is fine. We are grouping by what is that? Start, right? Then the condition columns are a bit tricky, because you are saying that I want to apply min and max on date and then mean on miles.
Then it should be different, right?
Yeah, so then how do you differentiate, right? So that is, you need to use a dictionary there. So it is slightly tricky because previously I am saying only one. So if I have only one condition, I can simply say AGG call average, I will do it. But if I have multiple conditions, because I need to say for date, this key, I want to do these two operations because I want to multiple. And for miles, I want to do only mean. So if I try to write it, let me see if I can write it, then I will show you. So I'm gonna assign this to something like rest. So how do you start? Can you help me? df dot help me. Start date, right? Start star. No. What is it?
No, group by will be start.
Group by will be start.
Group by will be start.
No, start date, right? Who said start date? You are confusing me. What is the column name? I don't know, I'm just asking. Then you will say what?
You will have just a space.
It should be start date, right?
Yes. No, it's for every city.
No. It has to be start star. Start date is what? The date. I'm grouping by what? The location, right? You are grouping from where the trip is starting, right? Not from where the date is starting, right? So it should be start star. Okay, I just looked at here. Start star. And now, what is the technique that you want to do? You want to pick a column and then apply the function, right? So I should be doing an aggregation, right? Okay, so what I will do, I will call an...
But that list has to be given here.
Yes. So normally when you write, you will say list of columns and then apply. But right now I cannot do it because I am having one column and two conditions, then another column and one condition. So I need to represent the whole thing inside a dictionary. So I am first saying that I want to do an AGG, okay, and I will open a dictionary. Now let me see if it works actually because I have not tried it. What are the columns we do for aggregation? No. Aggregation is a function, right? Sorry. You will open a dictionary and then you will say miles, right? So within this, I will have miles star. And what do you want to do on miles? So you can say what? Mean. I can either pass it like this or I can pass it as a list. Let me write it, okay? Then I will come back to you. And what is the second thing? Start date star, right? And here, what will be my values? What do you want to do? Min, comma, max, right? You will write like this. You will say a group by. Okay, so normally you will say group by some column, okay, and then you will say I want to pick only one column, okay, so let's say column 2, and then you will say dot AGG, and then you will say mean. This is normally how you write, but here my problem is, first of all, I have multiple columns. So if I am passing a column 2 and a column 3, okay, how do I tell that for column 2 I need to have two things to be calculated? So I cannot write it like this. So that is where the dictionary comes into picture. So when you're writing a dictionary, how the syntax will change. You will again say group by. This will remain the same. You will say I want to group by this column. You will not directly call the column. You will say I want to apply an aggregation function. So this is my aggregation function. And then you say what function on which column inside this. So inside your this thing, you will define a dictionary. This is key value pair. So here I will say column 1 and what are the things I want to apply, column 2 what I want to apply. So can you try this and see if you get the output?
Yeah. Excuse me. So why don't we just learn this the second format only, even for a single element. Let's say.
But this is again a bit more lengthy code. If I have only one column, this is easy to write. So it's just a way of writing. So if I have like multiple conditions, this makes sense.
But the first example will work, that my string will work even with a dictionary with a single element.
It will work even a single element. Also, you see, I am passing a list here. I can pass a single column here. So here I am saying mean is a list. I don't have to say list. I mean, why I am using it? Because I want to just maintain the same way that I am using here. So these are all some of the what you say. And one thing which is very confusing is that even this is not something you can by heart. Okay, in certain Pandas versions, if you write something like this, it will start throwing errors, saying that, errors in the sense the syntax, there will be no error, but there is no generalized way to say that this is the only way to write it. Right, so common syntax is like this, but depending on the Pandas versions, sometimes what happens is that it will say that, okay, list or dictionary that you are passing here, the proper format has to be there. So what we normally do is that if you are having a single column, you will always follow this method. You will say group by and then the column and then you say aggregation. But if you are having multiple columns and multiple condition on the columns, so here the confusion is that for the start date, I need two aggregation functions. That is where I cannot say start date of min and max. That is where I am defining it as a dictionary. Otherwise, it is fine.
Even when I'm dropping that miles mean in a list, for example, just open, that is also.
It should work. But here I use it for a common format. Okay, that we are using.
There was a. Can you do miles dot mean here? I mean, kf dot
Miles dot
the mean function instead of
so in the aggregation you are saying, but here inside this I have represented as a dictionary, so it has to be a key and value. So I cannot say miles dot mean here because this is a dictionary, right? Dictionary has to have a key and value, so it has to be a key. Why dictionary? Because the start date has two values. So if start date had only one value, I can say dot and it should work, right? For both, then you don't even need a dictionary. You can directly use the previous method, right? What we were doing, that way you can do. Well, these things will, so what we will do, I'll give you some assignments on this further than this so that you can understand more about grouping. So this is just an example, but some more simple assignments on different columns, and tomorrow you'll have a practice session. So where you will have around 3-4 hours to spend only on these things again, right? So it's not over like after we finish today, the class is not over. You will still have some more time to brush up and some more assignments and all this. I just want to introduce that these kind of things are possible. Are you sure there is a proper number of brackets and syntax and all? Because that might be one reason, right? Okay, yes, sure. So I'll just zoom this, okay? Give me one moment. So I have a question to you, okay? I have a question to you. Now I have a question. In the same example, if I wanted only the average miles and the recent trip, what will you do? I want only the average miles and the latest trip. Will you write it like this? Yes. Well, you can, but you don't have to, right? Are you getting the point? You can write like this, but you don't have to, right? Because if I'm having only the min or max, I can simply call the column and call it there itself, like we were doing previously, right? So this dictionary notation came since we had multiple things we are passing actually. Okay. Now somebody was asking a very good question. This is fine, but if you look at the output, it's like weird, right? Because there is like all these cluttered columns here. So normally when you do a grouping, nested columns will appear in your output. So right now my data frame is called RES, and RES columns are like very weird. So what you need to do is, once you have done this, okay?
But generally group by will be eliminate the duplicate, right? So what is group by will eliminate the duplicate means group of those similar.
Yeah, so here also if you look at the start date, it is unique, right? There is no duplicate. So you are grouping by what column? Start. So it will pick up, so in Agnew there are like 11 trips. So Agnew is repeating 11 times, but you see it only once. It's grouped, right? But what you should also do is that you should do a reset index Can you tell me why am I doing this? Any idea? Any idea why am I doing this?
Index code 0 to
So look at the columns now. Now I'm going to run it again.
it had different.
So when I did a reset index, what it did previously, the index was this Agnew, almond and all. That is how it came, right? When I did a reset index, it started this 0, 1, 2, 3 as the index. But again, I'm not happy because, these are the different columns I have. So I can simply say res dot columns equal to, so what are the columns you want? First will be start city. What is the second column? Average distance, right? What is that? Mean, right? What is the third column? Earliest first trip, right? Not the recent trip. What was that? Earliest trip. Then what we had? Recent trip. Recent trip. Happy? This is what you should do, because once you do a grouping, these columns will all get nested. So you need to remove it, just add an index, because otherwise this will be the index. So this will become your index, and then you just say what columns you want. So now you have a proper data frame in this format, right? You can have your own columns. Now you can work with the data.
Index was by default, it should be there, right?
By default, the index was start city when I ran it. I don't want that to be the index. It will not. When you do a group by, it doesn't select the index as such. Index is only for selection. After group by, the output that you get is based on which columns you selected for grouping. So by default, that will become the index column. That is sort of like something. So if I'm removing these columns, right? Let's run this again. No. Let's run this again. See this. So what is my index now? Start star. This is the index, start star. Now if you want that to be the index, that's fine. Maybe my requirement is like my index column has to be the start column. That's okay for me. I don't mind. But a better option will be to remove it and add your normal index 0, 1, 2. And then you are interested in removing the column names and giving your own names. So just say whatever column names you want.
So in real time, whether it's required, this index?
It is, so this index is actually, there are some operations where the index actually comes into picture. For example, you can take an existing column and add it as an index. So in those cases, you want to call based on the index number, you can do that. That is only. It's not, it's not mandatory. So when you do reset index, it will become 0, 1, 2. Standard index. But in say, so let's say there is a country column. I can say the country column has to be my index column. So my index, so whatever values are there in the country, that will become my index. Then I can operate horizontally also. So usually all the operations are vertically in a data frame, but there are horizontal operations also I can do. Like when you're talking about LOC, lock, right? What if I want to use lock in the horizontal way? So let's say I got the data from 150 countries, right? And I loaded in a data frame. Now that will have a horizontal index of 0, 1, 2, 3, right? Now I want to do some calculation where it is horizontal. So then I have to say select 100, select 200, I don't know what to do. So if my country column is the index, I can just say select Japan, then do something, right? So that for selecting it might be important. Otherwise you can leave it as 0, 1. I will show you an example probably. We have a sales data example where the indexing might be very useful. There is a sales data example where the indexing might be useful. List is similar elements. Dictionary is if you have a key and a set of values. So if I'm using if I'm saying that I have 3 columns and I want to apply min, max on each column. So let's say you have 3 columns. On each column you are applying one aggregation function. Then you can use a list. So, so I'm saying that I have revenue. Revenue is a column, okay? then I have another column called sales, then I have another column called profit. 3 columns are there, right? Now on each column, I want to apply some sort of a mathematical function. So what I can do, I can pass all of them as a single list. I can say revenue, what is that? Sales, and then profit. So this is a list because this is a set of columns, and my aggregation I want to do, I can say I want to do aggregation. Again I can pass, let's say mean. If I simply pass only mean, what will happen on all 3 columns? Mean will be calculated, right? Or if I want all 3 columns to have different things, I need to pass mean, let's say max, let's say min, like this. So this is 2 lists actually, because on each column I am saying that this is what I want to do. But now my requirement is that on revenue column, I want to calculate, let's say min, max and mean, 3 things. So I have a revenue column. I want to calculate the min, the max and the mean, 3 things on the same column. So then what I need to do, I need to use a dictionary. So I will say revenue is my key, okay, and the values are, I can pass as a min, max and mean, these things. Because you understand, right, one is a column, one is a function. This is what a column that you are operating. This is what a function you are applying. So the question is that are you applying one function on one column? If you are just interested in applying one function on one column, you can pass the list of columns as a list and the function also as a list, it will apply. Okay? Otherwise, you need to use a dictionary.
So when to use a list and when to use a dictionary?
On the mathematical function, then we need to use
A dictionary. Right. Exactly. Exactly. So list is like you have one-to-one mapping. List is one-to-one mapping. So I pass a list of columns and a list of functions. First function will be applied. Second function will be applied, like that. But on the other hand, I have 1, 2, 3 columns. For each column, I am doing 3, 4 functions separate. I need to map them, right? What function should run in which column. So there I need to use a key value pair. So the idea of a key value pair is that for one key you have 3 values. So all 3 things will be applied for this key.
So for revenue, mean will be applied, for sales, max will be applied.
In this example?
Yes.
Right. So if you are passing as a list, one-to-one will be applied.
Revenue, mean will be applied, sales, max will be applied.
Yes, and profit, min will be applied. Exactly. But otherwise, if I have multiple, I will say dictionary. This is the key. These are the values, and then apply them.
Can we drop index from the result set?
Drop. Yeah, you can drop. We did, right? Oh, we didn't do. Okay, but if I drop it here, then it may not be good, right? Because my intention is to keep index starting from 0. So in the original
Group, right? This is already grouped. So then if I want to hide this.
Okay, so here give me one moment. Okay, I'll just comment this. So here you have the grouping. From here you want to drop the index.
No, from the results after labeling, right? It starts with we have resistance.
Hmm.
Then after labeling, we don't want to show the impacts in the results.
Yeah, so RES is your result.
Yes. Here it is showing index also.
Yeah, the index is start star.
Now, if you do the indexing, after that only you can do the labeling, right?
This line you are saying.
To label it, you have to do indexing.
Oh, okay. So you are saying that only after this you are able to add the columns, right? No, even without that also you can do.
So can you just put it previous?
Which one?
The labeling, then I will just.
So now you have RES. Oh, now you are saying, will you be able to do this? You are asking. Let's try. No, that cannot be done. So what it is saying, length mismatch. Expected access has 3 elements, new value has 4 elements. So what it actually says? Why it is saying the value has 4 elements? Okay, let me show you this. what is that res, right? Res dot columns. Oh, I need to. Exactly. So let me just print this, okay? So when you look at this multi-index, right? So 1, 2, 3. So actually you are having 3 columns in this. After grouping, even though you see multiple columns, it is all nested. So if you look at the number of columns you have here, you have something called levels. It is picking this as one column. Then this max, mean, min, it is picking as another nested column. And then this labels, it is picking as another column. So you are having 3 columns and you are saying that I want to, have 4 columns for my data frame. That is what it is saying, that value doesn't match. So you need to reset the index. You have to first say reset the index. So properly it will add an index, okay, and then the columns, and then only you can, remove it. So did you guys understand this? After you group it, so this is the grouping result, right? After the grouping, if you look at the columns, these are the columns. So how many columns you have? 3 columns. Even though it displays like in this fashion, if you actually look at the columns, it says multi-index column. So this is not your normal column. This is not your normal column. It does an indexing. So it is saying that on one level you are having miles and start date. So what was the grouping column? What did we group by? Start date, right? So start date is there. Then you have what? Miles. Miles is what? Where you are calculating the average, right? Distance travel, right? Then it is saying that you are passing this max, mean, min. These are the operations you were doing on date and the other thing. And then it is assigning some labels also for each column. So when you look at the columns of your grouping output, you will see there are 3 columns. And I cannot directly change it. That is what I am saying, that I want to reset the whole index of my columns. So when you run reset index, what it will eventually do is that it will add a column for index starting with 0, 1, 2, 3 and then level your columns. And then you will be able to add that my custom column name, whatever I want.
After leveling, can't we hide this index?
Which one?
We can change the index.
Let me see. So this is after leveling, right? So I will do a res reset index, right? Now if I run res, so now if I run res, you have this index and then these columns, 1, 2, 3, 4 columns. So you want to drop this.
After leveling.
You can say drop index, there is a drop index, but then what will be the advantage?
Just
Okay, so after you rename, so let's say you are adding these columns, right? Let's say we are adding these columns, then anyway that is gone, right? Where is it? Okay, from here you want to remove this index, right? I don't think that is possible. No, because a data frame must have an index. If you are removing this, then what will happen? Your start city will become the index column. No, there is no way you can. So that is in the first class I told you, right? Data frame is not like your Excel sheet. In an Excel sheet, you have only columns. You don't have a row, right? If I remove it or drop it, how do you use iLock on horizontally or lock on horizontally? How do you access a row? Not possible, right? If somehow, let's say I'm dropping the index, okay? Then how do I say I want only the 3rd column or 4th column? Not possible, right? Lock or whichever. No. No, she is saying I don't want the index at all. I want to remove the index. That is not possible, right?
Already indexed. Wait, we can access using log. Cannot be a log, but log using the start city is unique.
So this I can keep my index. If I want, I can keep this as my index. Okay. Now she is saying that I want to hide this, right? I want to remove this. So I don't think that is possible because you have column indexes and row indexes. Column indexes are column names. Row indexes by default start from 0, 1, 2, 3. If I want, I can take a column and say that I want this to be the row index. But whichever way, I just need it, right, for accessing. So I don't think it is possible to completely remove the row index. Then how do you say that I want the fifth row? There should be some way to say that I want the fifth row, right? So this number has to be here in one way. I have another data set. Probably I will show you how you can select a particular column and then probably make it as an index if you want. So I just want probably this column as my index.
Yeah, because this output can be a base now. Let's say it is assigned to any data frame or anything. This will be the actual source. And after that, we can.
But one more thing I'll tell you. You can try that. If you save this as a CSV file, do you think the 0, 1, 2, 3 will come? No, I'm not quite sure about it. Can you try? How do you save it? You say pd dot to CSV, give a CSV file. Can you try it right away? Create this, you have the 0, 1, 2, 3, okay? And then you say pd dot to underscore CSV, and in the brackets, in double quotes, give a CSV file name.
And you run only first statement and submit rest of the statements. I want to see the RES again.
This is only RES.
When you create that RES for columns, it was giving labels, right?
Yeah.
So, but it was mentioning only miles and start date, not the start columns. So, is it like that? Whatever we are passing in the aggregate function?
That is only one which is printing, right? So, in fact, directly if you do like this, it's very difficult to access the rows and columns because they are nested, right? That is why we are saying that add an index and give proper column names.
If the data frame is consisting of the start columns, right? Then why it is not included in the labels?
Which one? That is the index column now. You don't have, so it is picking the first column as index column now. That is why. So when you say columns, it will not usually show that, right? So in this data frame, that is the, so you can try to do an iloc or lock on that column, it will give you.
Okay, so here start will be the index for all.
Exactly. So if the requirement is like that, you can keep it like that. I want that column to have my index column, but that will not be calculated. In my actual data, that will not come, I am saying. Index column is not part of your data, right? So that is where it's not showing there.
So if I create dot data, then start will not be there, right?
It will not be there.
It will be treated as an index.
Right. So in this example, that this column is not there. The first column is like an index column. That is why you are not seeing it. But that is bad because I want that in my data. That is why I am saying the reset the index, because I want my own index column. So this will be pushed as a regular column. Start star will come as a regular column. Then I can just rename and keep it for me. So can you guys save it as a CSV and tell me what you see?
The first column.
Not taking? It should take, right? Let me run this, okay? I commented this. Okay, I forgot. I think it was to CSV, right? RES dot. It will take, right? Can you see my screen? That is a good question. It will come here. See? So this will be your workspace. So this is your root directory. You can just download it.
Oh, then we have to download.
So this is my CSV. And if I open that, let me see what we have. Oh, I can't even open it. No, that's not a problem with the file.
Okay. Oh, actually, index comes.
Index will come when you are saving it. So this you have to, here you can probably, if you want, you can hide. I'm saying. So I am saying in the data frame perspective, I may not want to hide because I want to access them. So I want to say from 5 to 10, I need the data. So, but in the Excel when I get, I don't want this column because I know how to get data in Excel. So I can either delete it or hide it from Excel when you're saving it finally. Even I'm not 100% sure if you're saving it, probably there is an argument to remove index and save it also. Probably.
Index is equal to x equal to false.
False, right? Then it will remove it, right? There is an argument. So when you're saving it. But when you're working in the data frame, you don't want to remove the index. Because then how do you access the rows? It's not possible, right?
But in the original Uber drivers 2016, there was nothing actually.
Yeah, there is nothing. So this index was added automatically. When you read it, it will add it automatically.
So while saving this itself, right? If I don't reset index and I save it, right? So it will start with what index it is?
Yeah, the original data, whatever it was there.
So it is starting with 455 index. Start with the 455.
You can try that. Check it. Just see how the data looks like when you save it. Original data, right? So guys, in the event of time, I'll move to the next topic. As of now, we are done with grouping. Okay, I'll give you more examples. We will also clear some doubts offline. I just want to finish one more topic before we go to Numpy and other kind of topics, right? So looping, we will look into that. Yes, so have a look at here. This is a very simple example, probably, so this is something that we do. We did not go in depth into control structures in Python, like for loops, if loops and all. But something very commonly we do is that if you have a list like this, right, I can open something called a for loop. So I'm saying that for I in temp. So when you say for I, it will pick up each number one by one. I'm saying that res.append. Yesterday I showed you, right, append, you can add something. And I'm saying I star I. And then I'm returning res. So res is an empty list. Basically what this is happening is that this for loop will pick up each number, multiply the number by itself and add it to this empty list. So if I run this, you can also run, you will basically get 1, 4, 9, 16. So instead of 1, 2, 3, 4, each number will be multiplied. It's a simple for loop, nothing. So in Python, it's very common that if you want to work through a list and do some action, you write a for loop. Because programmatically, you can say that for every element, I want to do something. And this is one way of doing it. And there is the same thing. There is also something called list comprehension. So look at this example. So here what we are doing is called list comprehension. The same technique, I can just open a list. Within the list, I can say x star x for x in temp. So basically, I'm saying that take every element in temp and then multiply by itself. So this is probably the long way. Like this code is very lengthy, but the same code I can write. This is called list comprehension. So very commonly in Python, you will see this. You will see a list, and within the list, they could have written a for loop. That means that loop is running inside the list to manipulate the elements. That's called list comprehension, this technique. See? For as many elements are there in the list. So this x star x for x in temp is nothing but your original list, right? Temp is here, right? And what is the difference between a for loop and a while loop? I mean, I'll give you some examples, but or in while can become an indefinite loop. For loop can never become an indefinite loop. It is always fixed. You will never end up in an infinite loop in a for loop. Only in while loop, there is a chance. I am saying while greater than 0, then some number, then it will keep on running for infinity, right? Now, I want you to do one thing. There is a data set I want you to upload. Can you open your data you downloaded yesterday? Final. In Python files, there is a file called store sales. Can you see? Can you rename the file? Just keep it as store sales. So remove the 1 and upload that into your Python like this. So here I have uploaded. Can you see? Store sales. See? So once you upload it, you come back here and you should be able to read it like this. So can you read it? And this is a very interesting data set because here we are having a store ID. So you have like S1, S2, S3 up to some 100 stores. There is a city for where each store is, and then there is like months, Jan, Feb, March, etc. and sales in thousands. So there's like $8,000, $20,000, etc., right? So this data is particularly interesting because here there is a horizontal way of working it and there is a vertical way of working it, right? Like you can look at it both ways. So basically you are having store IDs, then the cities, and then the months and the store that you have. So are you able to read it? What is not defined? pd.read CSV. You might, so did you import pandas? If not, do this, right?
It was already imported.
For me it is working. Okay, rename the file, no? Store sales, or give the store sales one. No, I thought he didn't do it, so I just added it. Not required. Now, first time you imported pandas, right? Then it is not required.
No, this one. pd.read CSV we have to do for the first time.
Huh. Oh, you are reading the file, right? And then you are doing a head.
That I did.
Okay,
Yeah,
okay.
I also did. You have to run that.
Okay, so tell me one thing. I just want to calculate the average sale for Jan month. What will you do? Only for Jan month, I want to calculate the average sale.
Across store ID.
Across Jan column, I want the average.
One column.
So you can say store sales. Then what you do? You want to group by?
No group by required. Just average.
I can say
Group by overall, right?
should work, right? So I'm just interested in calculating the average or the mean for Jan. The easiest way to do that will be, you can just, also I think I thought some of you might ask me, but nobody asked. What is the speciality in this code? Is there anything interesting that you find? Well, I think yesterday we discussed. So normally you have to say store sales dot log of Jan. I'm not using that, right?
You can directly access the column.
So that is like a shortcut. So ideally it has to be what? Dot log of Jan. But you can also say just Jan. It will pick up. And I'm just saying mean. So what you get? You get the mean of all these things. That's only the Jan column, right? But now I'm not interested in that. I'm interested in calculating, let's say, the mean of store ID S1. So probably for this store, I have like Jan, Feb, March, all these months. I just want to calculate the average of this one thing, right? Probably. So yeah, so store one is in Texas. I just want to operate in horizontal way, right? Possible, right? And vertical is like right now we have picked up only Jan. Maybe I'm interested in picking up multiple columns also. So let's see how to do this. So one interesting function that I want to introduce to you. Now this might depend on your pandas version. It's called the apply function. So I can simply say store sales dot apply. Okay. So apply is a function. Okay. And you can simply say mean. So can you take a guess what happened if I ran this? Yes. So basically, apply is a special function we use, and within apply you need to say what you need to do. So here I am saying mean. What it did was that it picked up each month and then calculated the mean. Is there anybody for whom this is not working, throwing an error? You might. Just run only this. If you are getting this output, it is fine. Otherwise, if you are getting an error, then sometimes you may get an error saying that some pandas version, this directly it will not. Because can you tell me why it might give an error? So right now you are getting it fine. So if you think about it, what this technique will do, it will pick up each column and then apply mean. But then what is the problem? We have a column which is string, right? So in some Pandas versions, what will happen, if you run this, it will throw an error. It will say that I'm trying to calculate mean of all column, but the second column is a string, so I don't know what to do. So I will show you what you need to do there, because that might be very handy. So there you have a command called select data types. So you can say that include only integer and float, don't consider string. But if it is working fine, then it is fine. Now what if I want to do it horizontally, right? For example, right now you did this, and I want to calculate for store ID S1 mean. Mean for the year, Jan, Feb, March, April, right? So this is what for S1 I want all the mean horizontally. That is also possible, right? For one particular store, I'm interested in the yearly average. Then you can simply say, comma, axis equal to 1. So there is a concept of axis. There is an axis 0 and then there is a axis 1. Axis 1 will be row wise, axis 0 will be column wise. By default it is column anyway. So if I say axis equal to 0, what will happen? Columns will come. By default it is this. I can say axis equal to 1, that will be
each and every row.
Each row it will calculate the mean. But this apply function is not used for these kind of things, because this is like calculating the mean. That is like very common. But you can also have a bit more complicated functions in apply. We will see that. Okay. Axis 1 is row wise. So for each store it is calculating the mean of this line. That is what you see here. Axis 0 is column.
So if I want to add another row as mean and put to max.
Yeah, so it is very rare that you want to do. Even I need to.
Total I want to add as my row.
You might want to add as a yeah. So how to add a row? I need to check, because adding a column is easy and removing a column is also easy. I need to check because it is. No, columns is possible.
So can we add this column to that? The one which we have calculated.
This one, yes, I'll show you how to add it.
Then if I give axis as 0, it is again showing the same what we had done for
columns.
Without the axis,
Yeah, axis 0 is column. By default it is column. By default, if you simply call, it will work column wise. The apply function works column wise. That is equal to axis 0. You don't have to explicitly write axis 0.
What if I have two integers? Now that there is just, okay, just takes it on Jan. Okay, how many I have, it just calculates.
It calculates. But what I'm saying is that in many cases what I have seen, when you start working in production probably, you will have a data frame that will have a mixture of string, then float, then integer and so many other columns. So sometimes when you simply call the apply function, let's say you're doing like mean, it will throw an error saying that I was trying to calculate it, but I encountered like 10 or 20 string columns, which I don't know what to do. So there you need to use a small technique. I will see if it works. I'm not quite sure. So you have to say mean.
So in the mean we can give the column that we want to keep.
No. So I will show you how to do this. Directly you cannot. Okay, here it is just the mean of the whole. Each column it is calculating the whole mean, or each row.
Can't pass any argument with these columns should be calculated for.
No, but it is not considering the point is that store ID and the city column.
So store ID is what? City is string, right? It is not considering right now, but I am saying that sometimes you will see that you have a string column. It will throw up an error saying that I cannot convert. So in case if it occurs, what you need to do, I'll come back to your question, okay, in a moment. You have to say dot select d types. You have to say include I think you can mention like this. Let's say integer 64, comma, float 64. Guys, give me one moment, okay? Yes. So just make a note of this because this is not something which you see normally. But if you are getting an error saying that I'm not able to calculate the mean, you just add this thing. Select D types. You can say include integer 64. I mean, whichever. So this will say that I want only integer. It will forcefully omit the string columns, right? I'll show you. Just give me a moment.
What is the difference between apply and add?
Apply and aggregate. See, apply is a function which will work row wise and column wise. So there in apply it is not directly possible to say that I want to apply only on selected ranges. I will show you how to do that. In AGG it is an aggregation function. So where AGG will work is that first you will group it and then on that you are saying that I want to apply a function. So this is like in a common data frame I want rows and columns to be done something. This is how you do it.
Prabhu, if for example, let's say across cities we have like the multiple entries for the store IDs. For example. Let's say S1 was like spread across multiple other cities also.
Right.
So let's say we wanted to do for, let's say it was like Walmart, Texas, Walmart, wherever. So all.
Then you need to group it.
Okay.
Right.
So when we, let's say, group by, so this apply because.
No, then it will not work. So that's what I'm saying. Apply is something which normally takes a function like mean or something and applies to either whole rows or whole columns. That is the idea. And I will show you where that actually matters, where that condition will come. So group by and then the function that you are writing, that is where I want to group something, then you know, probably aggregation function I want to write. So for that aggregation, the logic is that first I am combining all the. So can you try to find out the city-wise sales probably? Can you do a group by what? City. I want to do a group by city. Then so I want to group the stores by city and then want to calculate what? Probably average or means sale. Can you try to do that?
When you use that function, right, on the calculating the list of all the numeric values, right? So in between, the string comes, right? So it will be more because it's already ignoring the other string columns.
No. What I'm saying, usually when you apply the apply function, if you have string and integer, it will omit integer. But in some pandas version, it will not. It will try to calculate the string's mean and throw an error saying that I cannot find out what is the mean of a string. So there you need to say.
So what if the column name is of data type string, but the values are integer?
Column name is.
I don't know. It is by default the column data type.
No, column name can be anything, right?
No, data type. The data type is string, but store is numeric, value is numeric, value is numeric.
But still you cannot, right? Because the end goal is that you take the value and calculate the mean or whatever you want. So if my values are all string, I try to do a mean, I will not get anything, right? It will throw an error. So I didn't get your situation. Where will be such a situation come? Can you give me an example? Where you have a column name as a?
Column name, the type. Column type is string.
Okay, fine. How come that? But that will be string only, right? It will not be numeric. Yeah, so now you tell me what you will do. So he is saying, okay, so there is a question. He is saying there is a column. Let's say the column is what? Sales. There is a sales column. Okay. This is defined as a what? Integer, right? String column. This is a string column. Okay. But inside the values are integer. For example, I have 3.33. What is the solution? 2 integer, right? We just discussed today morning, right? Today or yesterday? It will not. I mean, so in my version of pandas, it will avoid that column, omit that column, because it is a string column. Because it is looking at those numbers, but they are within the chords, right? It will consider them as strings only.
How to check the data type of this?
D types.
Store underscore sales.
D types. Dot D types.
But
Can you do it by providing columns, column names?
No, the apply function works on the whole. So all the columns or all the rows. So usually the idea is that if you want to select certain columns and do it, either you need to subset it, okay, or you can say group it and then. So we did it.
But Raghu, you did for Jan, right? So similarly, how can you do for store ID, single store ID?
Which one? Which one? The store sales.
No, not Jan, right? First step.
This one you are saying?
Yes. So similarly, we can.
I will show you. So this is not apply function. This is simply the mean I am calculating.
So same thing we can apply for store ID, right? Single store ID.
Now I was asking, if you have a data frame like this, apply function usually works on whole rows and whole columns, not like selected ones, right? And one thing I showed you is how to apply the mean actually, but some more interesting example will be, so let me show you this. Probably rather than discussing, I'll just show an example. Insert a cell above. Yeah. So have a look at here, guys. Do you know how to define a function in Python? So normally if you want to define a function, let's say I want to define a function like add, I will say add, you can say a comma b, I want to pass 2 elements, sorry. And then, so if you are passing a and b, what will happen? You will say there is something called res equal to a plus b, and you can simply return res. And how do you call the function? You will say add, and then you will say 3 comma 4. So have a look at here. What I did, I created a simple function. It is called add. And I am saying that there is a and b. If you pass a and b, it will add a plus b. This is how you define a very simple function in Python, just to show you the syntax. Now my condition is that, so look at the store sales data. I have the store sales data, right? I want to probably give a bonus. So I have stores, right? There are store IDs. And what I want to do is that I want to pick up a column, right? So let's say the Jan month sales. If the Jan month sale is, let's say, more than 10,000 for a store, then I want to give them a bonus. So my idea is that, so these are the situations where apply function will come into picture. So it is not like apply function is used for everything, but one common example is that I have this store data, and what I want to do, I have the Jan column, and my condition is that if the store has made a sale, okay, which is more than 10K in Jan month, then I will call this store as eligible store. I will give them bonus. If the value is less than 10K, I will say not eligible. Now, can you tell me how can you make sure whether it is more than 10 or less than 10? Any technique? We did yesterday, right? np.where, right? So what I can do, I have already written it, I think. So then I can save some time. Look at here. So I have defined a function called bonus function. And the bonus function takes something called sales numbers. Okay. Or I can say sales column. Right. And probably I wrote it as a comprehension. Okay. So I'll just write it in a bit more easy way so you guys can understand. So tell me, how do you write the bonus? So you can say np.where, right? How do you write? What will be the condition? So first let's do one thing, let's call it something. So I will say I have something called eligible values. If you guys want, you can write it along with me. We will see if we can define this function. So I will say just type def and then bonus function, and this function is taking a column. I will say eligible values, okay, where I will say np.where, what is the condition? When my sales column is greater than 10, I will say eligible, or I will say what? Not eligible. And then what you need to do in the function? Return what? Eligible values. So what am I doing? I'm defining a simple function which will take something called sales column, and it will compare this. It will say eligible, not eligible, right? But that is not the end of it. So I will just see whether it works. Store sales, I can just say Jan bonus. Then I can simply say bonus function, and I will pass what? Store sales. What is a column? JAN, right? Some error for sure. Oh, no, I need to import it, right? I don't have. So how do you say?
Import and
Numpy as NP. Very interesting. So what did I do here? This is my function. What my function does, it takes a sales column and it will just say np.where. If the column value is more than 10, it is eligible. Otherwise not eligible, and return that true or false, eligible or not eligible to this. And I'm just adding a new column. So somebody was asking, how do you add a new column? So this is one way. I'm just saying that I want to add a new column called Jan bonus. And what is a new column? I will pass this Jan column of store sales to the bonus function, and the result will be the new column called Jan bonus. You can see that here. Yeah, so np.where, what it will do, it will, so what are you passing to the function? So what is this sales column? This will be Jan, right? So if you take Jan, it will take all these 8, 12, 16, all will be compared. So 8 will be not eligible, 12 will be obviously eligible. You can also say return np.where, everything you can write as a single one. So that is how I wrote before, I guess. But it has to be a list, I guess, if you're doing like that. Let me check that. So you were writing what? Return? Oh, no. I don't think directly you can say return np.where. No. I don't think that's possible.
The defined DEF is for adding a column, is it?
DEF is a keyword for defining the function. And this is the name of the function called bonus function, right? Now let me ask you one more thing. Okay, so a little bit about the function. Let me ask you one more thing. What if your manager is saying that, so this month we will give them bonus if the store sale is more than 10. Next month it will be 20, right? Not every month it will be same. So how do you do? So this 10 is not fixed. Every month, so what you do? You will say sales column, comma, sales number. And then what do you do?
Instead of 10, we write sales.
So you will say, do you guys understand this? Yeah? So here you are passing it as a variable, right? Well, it's not required, I'm just saying. Sales column is less than 10. But what is more interesting will be this. I can say store sales new df equal to store sales. I can say dot apply So I have to say select D types include equal to integer 64. One moment, okay? Why it says invalid syntax? Where? Include, right? So now see what I have done, right? Now see what I have done. So this is the actual use of the apply function. So like I said, apply is something which will take your function and apply to every column by default. In the function that I am calling here is bonus function. So what is the bonus function doing? It will compare each value whether it is more than 10, okay, and I am applying to the whole data frame. So for each month I decided if the sale is more than 10, they are eligible. So if you look at my new data frame I created, it has just the eligible and not eligible stores. Of course you have only the ID, right? But now you have a problem, right? What is the problem? So this is fine. The previous data is gone. Gone in the sense like we created a new data frame out of it, right? But by looking at this alone, you may not be able to make sense, like which store is actually eligible or not eligible. So that is where you can do one more thing. You can actually concatenate two data frames. Like my original data frame is what? DF, right? Store sales, right? I can say I want to add store sales and new DF together. I can do a concatenation. But you have to be very careful when you are doing concatenation, because ideally when you do concatenation, you can either add them horizontally or vertically. Horizontal adding means two will be added like this, vertical means like this. So ideally their rows and columns should be equal. Otherwise you will end up having problems. So now my requirement is I have two data frames and I just want to add them together, right? So let's see how to do that. Then I will pick up your questions. So I can say something like this, pd dot, one moment, okay, concat. I think the function is called concat. What are the data frame names? Store, sales, store sales and new DF, right? Right? So what do you think happened? So, and it is always good to check this. And I'm just, let's do one thing. Raghu dot, what you do? What happened? I concatenate. How many rows are there now? 200. So my data set has 15 columns and 100 rows. And I did a concat, and what happened? It appended horizontally below. So you don't believe. Again, do a Raghu dot tail, right? Can you see? So if you don't want this, you can say what? 1 or 0. Now we are talking. More or less looks like, easy to. So you may argue that this is much more easy in Excel to do, but but if you have 100 rows, I will not come to this to do it actually. But if you have 1 million rows, probably this is not a good idea. So what did we do? We created a data frame called new DF, right? Where I have applied this bonus function, and check with your Pandas version. When I applied this, I got an error, cannot convert string. That is why I added this D types here, okay, and I created a new DF. And now my original data frame is store sales. The eligible, not eligible is new DF. I say concatenate them together. Access equal to 1 because I want to add them horizontally just after that. And look at the shape and print it. You are getting the data frame that you want. So that, yeah, so you have to either rename them or, because it will have the same column names.
But this frame is created now, so how do I pick up March?
Yeah, so if you do a March, so you need to reset the column names actually.
This bonus function had a additional parameter.
Which one?
This function, bonus function.
This data frame is created.
So if I say Jan,
but if you want to include,
you cannot. If you are picking up Jan, you will get 2 Jan. So either you can rename the columns, okay? You can just say that select, lock of this to this range and change the names. Dot columns. So one way you can say dot columns and manually reset all the column names. So instead of Jan, you can call it as Jan bonus or something like that. But in the default operation, it will add the same column names. We are not changing it. So but this is also good, I think, because not good, but you can see Jan and Jan's eligibility probably.
It causes some confusion because generally this returns a series. When you get a column, you get a series. You can convert it to a Numpy array down the line. Can you print the columns of this? Or maybe the
of the data? Yeah, I can print. No, this should not be. It should not be. If I say Raghu dot columns, no, they are not nested. They are having all the columns, but they are sort of like how do I say, repetitive, right? So one thing you need to take care is that if you are doing this kind of concatenation, so the column names you might have to change or manually add them. They will remain the same. You can, one thing is you can say dot columns and then you can manually add it. That is one way to do it.
But if it is like so many like this,
Then you can pass as a list and give a new name. So you can say df of the column name equal to, and then you can give another column name.
just like ilog, do we have like I column by numbers?
ilog.
Just like ilog, rows by numbers. We have columns.
Column in ilog you can access columns by numbers. When I say dot ilog, I can use only numbers, either row or column.
Okay, so ilog is to fetch the rows, right?
No, to fetch the columns also you can use. You have to use the 0, 1, 2, 3 like column numbers. It won't consider the column headers.
can I move the Jan and Jan eligibility to the next column? Can
No, there might be a method, I don't remember. So I don't think. So not in the original data frame, you can say select, lock and then move it.
Couple of things, let me just check.
Sorry for this.
Realign the? There is a realign.
एक ही कॉलम हो सकता है.
I just want to discuss one small topic which is very important, but it is not there in your notebook. I have another notebook, I will share it with you, but this seems to be a bit important. So can you guys tell me what is happening here? Okay, so I will just run this. Oh, you need to import, right? How do you import? Import Pandas as PD. So guys, have a look at this. I just brought this example to show you something. What I'm doing here, what is years?
A list.
List. What is F1? Dictionary. So I can create something called a series, okay, by passing F1 and index equal to years. Well, these things may not be really important because it's very unlikely that you manually enter some data and create a data frame. Usually you read it, but my point here is that what will happen is that series is a single column, even a single column with row index. Even though you say single column, it has a row index, right? So here, if I show you, let me firm1, right? Okay, so is it printing something? No, it's not printing. So if I say print firm1, this is how firm1 will look like. Okay, what is firm1? Firm1 has an index of years. So 90, 91, 92, these things will be the index, right? And then it will also have this F1. So it will look at this dictionary and find out the values. It will add it here and create it like this. Okay. So basically what I did by running all this, I created a data frame like this. This is my data frame. So in the data frame, the index is this 90, 91, 92 and all. I have 3 columns, firm1, firm2, firm3. The point that I want to actually discuss here is this NaN values. So it is very common that when you do data analytics, you will get a lot of NaN values and what to do with them. So one of the things you can do is that you can say there is a drop Na method. So I can say, so what is firm2? Firm2 is a series, and here what is this data frame called? df3, right? So I can say df3 drop Na. df3 dot drop Na. So can you tell me what happened when I did a drop? So my question is it dropping them row wise or column wise? Are you sure? Only 93 and 94 was retained. Row wise, right? So it will drop it row wise, NaN values. So wherever you have an NaN value, that row was dropped and you got only the remaining one. That's okay. But if I say df3, what will happen? The original data frame is unaffected, right? So ideally you should assign this drop Na, or I think you will be also able to do a in place true. So if you want the original data frame to have this, what you say? In place true. What will happen? It will drop from the original data frame, and so your original frame will get affected, right? And usually you don't want to do that, so you can assign that to a different. So this is one way of dropping the value. You can also do something else. For example, you can say axis equal to 1. What will happen? Row wise or column wise? Yeah. So axis equal to 0 means column wise, right? In the sense like it is picking this. Axis equal to 1 means, so it is checking wherever NaN values are there and it is dropping them. That is also possible, right? And another interesting thing is there is a threshold you can mention. Okay, so have a look at here. I am saying I want to drop axis 1, threshold equal to 2. Okay, so what do you mean by this threshold? So let's say threshold equal to, what are the values we have? Okay. Yeah, so threshold df. So what is the original data frame? df3, right? So let's print that also. Print df3. Okay, not here, because this is the last line anyway, it will print. I will say print threshold df, and I will print df3. So did something happen? Nothing happened. Right? Because my threshold is 2, so let's say the threshold is a bigger number, 8. Empty data frame. Okay, what is the number? 5. 90, 91, 92. So this is also having same, right? So what is this threshold value doing? So you can define a threshold. In this case, rows having more than 2 NaN values, it will be dropped. So threshold works like that. So it will look at the other values, and if you mention a number, then anything more than that will drop, otherwise it will keep it. Why this is important? Because you will encounter probably millions of NaN values in the data frames, and you might want to change them or drop them. You can also replace them. So one common thing that we do is that we replace them. You can say fill Na. So what am I doing? Fill Na 0. So instead of all NaN values, it will be filled with what? 0, right? You can also say fill with the mean, right? For example, so here what am I doing? I am saying fill Na df3 dot mean. So the mean will be calculated, or you can pass a function, and that value can be filled. So that's something we commonly do, because let's say you are getting the annual revenue of 10 companies every year. Okay. Now it comes in a data frame, right? Now what happens in 1 year? There is no revenue. They forgot to give you the data. So that will become an NaN, right? So now when you start working with it, you just don't want to consider there is no data. So what we do is that the last 10-year data we have, only 1 year is missing. You say mean of it and fill it there. So you have some value to experiment with. You cannot simply say drop everything, right? So if it is 0, doesn't mean like, so you have to justify that. So what we do is that we'll replace that NaN value with a mean. So 10-year revenue of the company is this, 1 year is missing, the mean will take care of it.
It's mean for that series or for the entire mean of row?
For that company is all years, that column mean. I mean, one technique I'm saying, anything you can do, I'm just saying that will make sense. Otherwise, if you say that value is 0 and then you're calculating something, it will have a huge impact, because that it is as good as like the company didn't do any business on that year. But ideally they forgot to give you the data or something like that. So always it is a good practice to find the NaN values and then manipulate them, right? So I will share this notebook with you. This has some explanation also of these NaN values. This is not with you right now, but I will share it with you. So you guys can practice on this. Now on data frames, there is an assignment, not now, don't worry, so later, but I'll share this file with you. Where is this final? Okay, final Pandas, okay, where is it? Practice, Pandas exercise. So Pandas lab. So there is a, can you see this? There is an automobile data and there is something called Pandas lab exercise. So the idea is that you load this notebook and try to see if you can get the answer. If not, there is something called solution. So in the solution, there is Pandas exercise solution you have. So if you are not able to get it, for example, I'll just show you one of them. How do you upload it? You will go here, upload, and you can say practice, Pandas exercise. And we want the automobile data and this, and say open, upload both. And I can just open this. Yeah, so this is like this. We shall now test your skill using Pandas package. Answer each question. So yeah, check the head. So you are supposed to read the data frame. That is not given, right? Answer each question, load Pandas as PD and upload the automobile data. So what is automobile data? Practice, here is the automobile data. Let me open and show you. So the automobile data actually has lot of columns. So there is a make and model of the car, how many tires it has, what is the engine, what type, that is automobile data. And check the head of the data frame, how many rows and columns are there, what is the average price of all cars, which is the cheapest make, how many cars have horsepower greater than this, 3 most commonly found cars, which cars are priced, etc., etc. So this is one sample practice. So we'll give you more like this, so it's easy for you to go through and understand. Solution is also there. Have you guys heard about Kaggle? Yes, right? Why it is not giving any output? Oh, yeah. So for those who are not aware of it, Kaggle is probably one of the best places where you can find all the data that you want. It is a website which shares data to you. You get a lot of data, and there are a lot of competitions that happen in Kaggle. So you can sign up for a competition, they'll give you the data, and then they will ask you to find a solution. So for data science and ML, this is the best place to get all the data. You can also see the previous competition results which people uploaded, and that also can help you get more idea. So this automobile data set is actually taken from Kaggle, right? You can get a lot of free data sets in Kaggle. And I have shared this notebook with you. It will be uploaded in LMS now. You can just download it and add it to your Jupyter. Okay, meanwhile, let's have a small discussion about NumPy, right? Basically what is NumPy? Like I said, it is called numerical Python. That is why it's called NumPy. NumPy is a special data structure library that is available in Python, which allows you to play around with multi-dimensional arrays. So the basic idea is to create multi-dimensional arrays, right? And NumPy supports something called array. Okay, so the array can be 1-dimensional, 2-dimensional, 3-dimensional. That's what it is. The practical application may not come right now for you. You will see NumPy arrays later when you start working with deep learning or any other projects as such. So NumPy is very useful, and the pandas and data frames were actually built on top of NumPy, right? Now, so that is like very simple. So you are saying that, okay, there is NumPy, but I have a very simple question to you. Can you see this distance and speed thing I created? What is distance and speed? What are they? No, they are not array, right? List. It's a normal list, use square bracket. Now, don't run this. I think you don't have the notebook. So I have a question. I am saying time equal to distance by speed, okay? And then I am saying printing time. What will happen? So I mean, you can take your time.
It will take the average of
Okay. So you are saying 45 by 5, 50 by 10, 35 by 7. Absolutely wrong. Nothing will happen. You get bunch of errors. It will not work, right? How it will work? No, it will not. It will never work actually. The question is why? Yeah, it's a collection. A list is a collection where if I want to really do this, I should write a for loop. I will say for every element in this, take every element in that, do a division. I mean, why am I saying this is that, but it's very common that I'm looking at some data points. So again, like the Uber data, I got the Uber data, probably not in an Excel file, probably in some other format, where I have a distance covered by each Uber driver in an array or a list, and I have the speed of each car, okay, and I just want to do a distance by speed. But I cannot do this here on list. If I do it as a list or dictionary or anything, I will end up in an error for sure, right? So, I mean, I just wanted to show you that it is not possible first. Then if I say it will make, so what is the error you are getting? If I scroll down, unsupported operands for this list, right? Well, now what I am going to do is something very simple. So I'm just going to import NumPy as NP, okay, and this part is not required, okay, and look at what I'm doing. So what is distance? It's a list. You can convert this to a NumPy array by simply typing array of distance. Then I can say, so you don't have to say np dot array. I think, did we import it separately? Import NumPy as np. Okay, let me do one thing. Just comment these things for a moment. So let's run them one by one, okay? No, you have to say np dot. So this is how you create a NumPy array from, let's say, a list called distance. So I'm just converting this into a NumPy array, and again the speed I'm converting np dot array, and then we can just print them. So let's have a look at how the data looks like right now. The data looks pretty much like a list as of now, okay? But now what is interesting is that I can simply do this. I can directly say distance by speed, and the result is time. And if you check the data type of time, it's a NumPy n-dimensional array. That is how you know it's an array, a NumPy array, right?
Excuse me.
So,
You have already imported array, right? From NumPy array you have imported.
Yeah.
Then again, why we have to use np.array?
No, I override it actually. So you have to say np dot array ideally. I originally imported NumPy as np. So whenever that import statement is there, you have to say np dot, right? Now, so the real question is that why this is useful? Why this is useful? Because this NumPy data structures like arrays are pre-compiled data types, meaning if you create an NumPy array of, let's say, integers like this, they are already compiled, and any operation you write on them like addition, subtraction, they can apply that on all the elements really fast. So a NumPy operations are 10 to 100 times faster than normal list operations. You have heard about this Fortran, right? Fortran, what's the language? Fortran. Fortran is considered to be one of the fastest languages ever created. So NumPy array operations are as fast as the Fortran operations. Because once you create an array, it has pre-built functions and data types on the array. So when you say sum, it takes the whole array as an integer and apply whatever logic you are saying. So the common use cases will be that I have data points in different formats like length, width and all, and I want to apply a common operation in them, right? Now a question to you, okay, so let it be there. Are you able to get this notebook? Now you can also do things like this. Okay, so what about this? Now you will be able to answer my question, right? Can you have a look at this code I'm going to run? Will it work? These 3 lines. It will work, but what happened? Concatenation, right? So when you say add to list, what will happen? It will concatenate the list. That is the default nature of a list. But you don't want that. Your idea was to add the individual numbers, right? That will not work. So, but what I can do, so this is how you can create an array. I can simply say this. np.array. Give me one moment. Where it is giving the error? F plus G. Okay, I'll just comment this. I'll tell you why it is not working. Oh, we don't have F and G, right? From where you're getting F and all? F and G is there, right? Okay. So I'm just creating an array with 1, 2, 3, 4, 5 and 10, 20, 30, 40. I can print A, print B. But one thing did you check? Because I was trying to do a F plus G, I got an error, right? I did an F plus G, I got an error. Why do you think we got an error? Because if you are manually creating an NumPy array, their dimension has to be exactly same. What do you mean by dimension? The number of rows and columns. So if I add a 50 here, it should work. It works, right? So if you do an F plus G, this will work. You can also say I want to print add 5 with every element. So all these common operations can be broadcasted to the elements in the array. That's the advantage of an NumPy array. Are you able to run these things? But if you closely observe, the data type is integer 32. In the array, the data type is integer 32. So when you actually go to Pandas and data frames, it is integer 64 and float 64. So they allow, I don't know, like more space to be there. I have a question, don't try this. What if I create a NumPy array with, let's say, 1, 2, 3, 4. Will it work? Will it not work? Will it throw an error? No? NumPy is numerical, right? what do you into print f, right? So can you tell me what happened here? So ideally you should not do it. The Numpy is a numerical Python. So you are trying to play with numbers and string values are not really advisable. But if your Numpy array contains a string value, what will happen? So why this is happening? There is a reason behind this. If you look at the data types, there is something called object. This is your string. There is something called object. Then there is float. Then there is integer. The lowest layer of data type is integer. The next one is float. Next one is string. So if in your NumPy array you have a mixture of float and object, it will automatically cast everything as string. If you have a mixture of integer and float, it will cast it as float. Right? That is how it will automatically change the data type. So right now in my array I have some numbers and then one string. So it is saying everything I will convert to string. So that is not a good thing to do ideally, right? But if you encounter something like this, sorry, D type. So this U11 is object. That is an object. How do you know? If I remove this, let's add it as 5. What is that? Integer. So if I say 5.5, it will be what? Float 64, right? So you can do a D type for that. So now some very important functions you need to remember in NumPy. There is a function called aRange. It's called aRange. So I'm gonna comment some of this. Let's say we don't want this. Okay. So aRange is a function which will generate a range of numbers. Why it is again np dot. No? No, it comes by default. We imported it, right? Yeah, it is np.arange. There has to be some problem, guys.
Both should be there. np.array. No, we did not run the top one. We have
it. Which one?
Go on top.
Both np.array.
No, it has to be np.an-array, then arange should work automatically. You don't have to say np.array and np.arange. That is not the idea. I don't know. So ideally if you say, you don't need array at all ideally, right? You can simply do an arange. It should work. I think I was trying to mess with the code, I guess. You don't have to say array. You can say np.arange, it should work. So basically what is arange? It will generate a range of numbers and you say 10, so it will be from 0 to 9, right? This will be useful in case, you are looking at some sampling data. So if I say 15, it will give me what? 0 to 14. So this will be a NumPy array basically. Now where this can be useful is you can also mention this. So I am saying 5 is my starting point, 56 is the ending point, and 5 is the step function. So can you see this? I did a np.arange 5, 56 and 5. So what will happen? Let's start with 5 and 5 is the step function. So it will add 5, 10, 15, 20 up to 55. It will never include the last element. There is a difference. So if I keep it 55 here, what will happen? What do you think will happen? Will it print? No, it will print only till 50. Because start with 5, add 5 till 55, last element is omitted. So it's like a step function to generate numbers. Can be sometimes very useful because you want to generate a set of numbers and work with them. And there is also a very similar function called a linspace. Arrange and linspace are very similar. The basic difference is this. Let me run it once, then you can understand the difference. I don't know why there is an array everywhere. I think I was doing something. I will just hash it. Yeah. So there is a np.linspace function. And what it does is very simple. So let's say I want from 30 to 100. Okay, and the step is 5. Yeah. Can you take a guess? I ran this and I got this. What could have been happening? So when you say 30 and 105, first will be 30, last will be 100. So two numbers are fixed, right? This is fixed. And then what is this 5?
5 is a number of elements.
So you will get 5 equidistant numbers like 30 to 47, 47 to 65, 65 to 82, 82 to 100 will be same number. So, and what is the formula? So how does it calculate this number between 30 and 47? 100 minus 30 divided by 5 or 4, I think 4. 5 minus 1, right? Can you tell me what is that number? 100 minus 30 will be what? 70. 70 by 4 is what? That is what you see here, right? Yeah. So the formula will be 100 minus 30 divided by 5 minus 1, 4. That's how linspace works. So, and you can do this for any number. For example, I can say I want between 1 and 10, I want some 30 equidistant numbers.
But is it only for floating? Because I tried just for 10 to 100 in 10 steps.
Okay.
It is writing as 10 dot 20 dot.
So the output will be in float. Because why that is? Because in many cases you will not actually get the integer. So the output of linspace is normally casted to float for precision. So here you see I'm printing between what? 1 and 10, 30 equidistant numbers, right? So like that. So this might be useful. Are you able to run these things? So now comes the real thing, right? So dimensions, right? 30 point. It won't. So if it is a whole number integer, you just say 30. If you want to say 30, it will say 30, right?
No, it's giving 30 point, then 47.5. It's not giving 30.0 for example. Let's say if I have.
No, the answer is 30. No, 30 is the first starting point, right? You are creating numbers between 30 and 100, right? So 30 is an integer. So it won't print 30.000, it will say 30 generally, right? See, a little bit about dimensions, right? So you know what is a dimension, right? So normally we say there is 1 dimension, there is 2 dimension, and there is 3 dimension. Is there a 0 dimension? Do you think there is a 0 dimension? No. Theoretically, yes. Practically, no. No, actually there is something called 0 dimension. A dot is 0 dimension. Dot. Actually, dot is called a 0 dimension because there is no diameter or anything. In mathematics, it's called 0 dimension, 0 dot. one dimension is what we created, this array. One dimension is what? This NumPy array we created, right? So you are saying 1, 2, 3, 4, this is one dimension. A two dimension is called a matrix. Not two, anything more than two is actually a matrix. Three dimension is also a matrix. But see, when you visualize it, that's totally different. For example, if I want to visualize 3 dimension, I will say probably a globe is 3 dimension and a circle is 2 dimension. But in case of NumPy, you can have 2, 3, 4, 5, any number of dimensions, and you can visualize them also. Not like 3D and all, but normally in NumPy steps, right? So let's have a look at dimensions. Here, if you scroll down, what are we doing here? I am creating an array. Can you see? These are the numbers I have. So I just want to selectively, uncomment. That is why I am commenting everything. Okay. So people are thinking like, why are you doing this? Yeah. So basically, what I am doing here is that I am creating an array, right? And what are the numbers I have? 32, 45, etc., etc., etc. Right? Now, one of the very commonly used functionality in NumPy is this reshape function. So, what is this reshape function? So, I am saying that data.reshape 8, 3. What will happen? This will convert my NumPy array into a 8 by 3 matrix. So you will have 8 rows and 3 columns. Can you see here? 1, 2, 3, 4. How many rows? 8 rows and 3 columns. So how many dimensions this has? 2. 2 dimensions, but we will normally call it as a 8 by 3 matrix. Right? So reshape is very useful. For example, I can say I want to have something called data 2. I can say reshape 2, 2, how many elements we have? Total 24. Total numbers are 24. So I can say 2, 2, 2 times 2 is 4. 4 times what is 24? 6. I'll tell you. So right now, let's say you do this. This is 3-dimensional array. How? Because I said reshape 2, 2, 6. What does this mean? 2 rows, you cannot say 2 columns because it is 3-dimensional. Axis 0 will have 2, axis 1 will have 2, axis 2 will have 6. So if you look at the data, it will have 2 rows. 1 row, 2 row, in each you have 2. Each you have 2. And within each you have 6 elements. Can you visualize? That is how a 3-dimensional array will look like. Well, it is not important to visualize this. I mean, nobody is going to ask you like, I'll give you a data, visualize in your mind. But sometimes your data, mathematical calculations and all, right? The data will come in this format. The data will have a 3-dimensional matrix format. Now somebody was asking, so take a guess. If you want, you can do. Take
what
a.
we are doing here, exactly we are breaking the 3-dimensional array into a 2-dimensional array.
Correct.
If there is a 4-dimensional thing, then we can break it into
Correct. Correct.
2-dimensional.
Right.
Permutation, combination.
Right. You can do. Now one more thing. No, this is actually 3 dimensions. Right. So this when you do a reshape, you just pass 3 arguments, that means 3 dimensions are there. Right. How do you visualize is a totally different thing. So one way I told you that you can just imagine. So if I am looking at this 6, this number 6, it is in the first, so you have 2, right? 1, 2. So in the first axis, okay, you have 2 columns. In that again the 5th element is this. That is how I have to access it. So there are 3 layers I am saying, 3 dimensions are there to this data actually. Now what will happen if I try to do this? Can you tell me? I say a 2, 2, 10. Error, absolutely error. Why? You can't fit, right? 2, 2, 10 will be what? How many elements? 40. how do you fit 40 into a, this search? So the shape actually matters. So you have to say 2, 2, 6. Then it should work. Right? How do you make this 4-dimensional? Four. Yeah, so sometimes, so that's fine, but sometimes it is more easy to add a 1, right? That is 4-dimensional, right? So this is how 4 dimensions looks like. Christopher Nolan stuff. Right? Well, it is difficult to see, but you got the idea, right? I mean, the numbers are in more brackets you see, more dimensions you have. I mean, I don't know how to explain this. So some things are very hard to explain. Don't worry about 4 dimensions right now. So right now I think 8, 3 is enough for us because 2 dimensions are easy for us to work. Which is data 2? Data 2. Okay, data is, so you can do things like this. For example, what is data? Oh, I didn't run reshape. The problem is this all will get confused end of the day. So your original is data, and let's say we keep it as data 2. I reshape it and let me just print it data 2. Okay. Is it working? Yes, that is working. So I can do this, I guess. Yes, and I can print this. So this is very similar to your Pandas concept. In Pandas, you remember we had a filter. So same way what I am doing here, I am saying that take data 2. What is data 2? Your matrix percentage 2 equal to 0. So what am I doing? Even numbers, right? And if I just print it, I'll get true false because it is getting applied on the matrix. And I can just pass it as an argument to filter my data, right? So I can simply say data 2 even data. And you will get this. So you are getting only even numbers on the array. Just as an example I am saying.
So what does percentage 2 mean here?
So you are calculating the whether the number is divisible by 2 or not to get the even. Mod you can say, right? So whether so this will pass through each element of the matrix, right? And the output necessarily may not be the same structure because here it is properly 8 by 3 or something, but not every element will satisfy the condition. So here it can be a normal array. Output can be a normal array. You also have a method called np.zeros which can produce 50 zeros if you want, right? But this might be more useful because I can say np.zeros 3, 5 plus 6. So what is happening? You are creating a 3 by 5 matrix, adding 6 to every 0. So you will get a matrix like 6 and 6. This. So these things will become handy when you start going further in machine learning. Okay, so not right now. You may be wondering why you have so many zeros, but there is also a np.ones method which can give you like ones, right? And I can say 5 by 9, any shape I want, right? What is an identity matrix? Anybody know what is an identity matrix? So if I am creating a matrix, let's say 4, right? Then what do you do? What is this? This is an identity matrix. What is the speciality? If you flip the rows and columns, the matrix will remain the same. So diagonal values are 1, right? That is called an identity matrix. Now this might become useful, but you can actually create an identity matrix. I can simply say np.I and just say 5. Question to you, can I do a np.I 5, 6? No, don't run this. I just have a, so np.5 will create 5 rows, 5 columns equal. Can I do a np.identity of 5, 6? I want 5 rows, 6 columns. Yeah, so theoretically this does not work as an identity matrix, but strange it is, it will create a 5 by 6. So some concepts are very confusing. The command is trying to create an identity matrix, but this is not identity, right? Now this will become, right? So probably close one column and show to somebody. This is an identity. I absolutely have no clue it is working. Don't ask me. Okay, why? I mean, I don't know. So I've been trying to find out. I mean, God knows how it is working, but normally an identity matrix should have equal number of rows and columns. Then only the concept makes sense. But you can also say I want more columns and then it just adds. I don't know, maybe it works like that. Now if you want to print something like, so what is happening here? I'm just filling the diagonals with the numbers 1, 3. So identity matrix will have ones, right? But in certain use cases where you want to fill it, you can actually fill it like this, right? Well, that is all you need to know right now about NumPy. Not much, just to understand that that these operations are possible. So see, when you are building a machine learning model or something, right? So let's say your customer comes to you and say that he gives you some data and you want to build an ML model on top of it. One thing that people do is that they will actually build the model and test and all, but it is always very good that if you can come up with a story about the data. So visualizations actually help you to make a story from the data set and then show to your customer or somebody. So in Python we have a library called the matplotlib, okay? That is actually the original library for visualization. But these days it's very rare that you use matplotlib directly. We are using a library called Seaborn on top of it. So Seaborn is the actual library that people use. Seaborn is built on top of matplotlib and this has much more visualizations. There is also one more visualization library that's very popular. Tableau is BI, business intelligence. That is not this. So in Python there is a separate library. There is a not sklearn. I'll tell you what is, but mostly what we use is Seaborn, but I'm talking about an external library. So now let me ask you something. So let's say you have some data, okay? Let's say you have only integer. So when you say visualization, normally we say there is something called a univariate and bivariate. There is something called univariate and bivariate. Univariate means you are looking at a single variable and then you are visualizing the data. Bivariate means you are looking at two different variables and then you are visualizing the data. For example, let's take the ages of people in this class, okay? So let's say I want to plot a graph, okay, considering all the ages of people in this class, okay? So that is my intention. I just want to plot a graph and I'm just considering only one thing, which is nothing but the age of people in this class. Oops, sorry. So can you tell me what kind of visualization, not in Python, in general, if I'm asking you to plot integers, what will you do? Do you know any names or anything?
Bar graph.
It's not bar graph. So if you are having integers or floating numbers, and if it is a single univariate, it is called a histogram. It's called a histogram. And how does a histogram look like? It will look like this. Okay, and you will see this kind of or like this. So here you will have the age of the people, right? So different ages will be there. So let's say, I don't know, like 20, 30, 35, 40. Pie charts normally is categorical, right? Different categories you want. Bins. This is bins. So this is a bin actually. So you will have an age between 20 to 25 or 25 to a bin, and then how many people in that. So basically the idea is that you have an axis where the integer or the float, normally integer number is there, and there will be sort of like a bin, right? A range, right? So 20 to 25, 30 to 35, and then how many are there in that. So I have like 5 people or 10 people. So you look at it, it will look similar to this. I will show you this practically, but I'm just saying normally. Now in the same thing, if I want a string, so this is like people, but let's say I just want to draw a graph of people from this class based on the city you are coming from, say Bangalore, Chennai. That's a string column. What is that called? That's not a histogram. That's a bar chart, right? So that is a bar chart. Well, there is not much difference between these two. The only difference you can see is that here you will have, I don't know, Mumbai, Chennai, Bangalore, and these bars will be separated. They won't be together. In a histogram, these are all together. Here you will have separate ones, like Mumbai, Chennai, Bangalore, because you are basically looking at a string column and saying that how many people are from Mumbai, from Chennai, from Bangalore. Categorical. You will have spaces between this thing, bars in this. That's why it's called a bar chart, actually. So in univariate, normally you will draw a histogram or you will draw a bar chart. That's very common. Now let's talk about bivariate, where you have two variables to compare. I want to compare. Which one? So usually we say there is something called histo, or the other one is bar chart, right? Now what if you have two variables, right? Bivariate analysis. For example, I am just considering two integers, for example. I am considering two integers, for example. So I am looking at the age of people and then the salary. So I want to compare age and salary. So both of them are what? Integer or float, or let's consider them as integer. So what kind of plot will you do for this? 2D. Yeah, XY is there always. Yeah, who said scatter plot? It's a scatter. This is called a scatter plot. Why? Because your graph will look like this. So here you will have, I don't know, age. Here you will have salary. Right? And then you will have people like this. Scatter plot. So each dot will represent a person, a combination. So age of 30 and the salary, it will be like this plot. So you'll have a lot of dots like this. Now this is a bit confusing. Confusing in the sense the plot is good, but normally you just don't want to plot it. You plot it, and it is in most of the statistical methods, you will learn statistics afternoon. What we do is that we try to fit a line into the plot. So you will fit a line like this. Why? Because this will show you the trend of your analysis. By simply looking at a scatter plot, you don't know what is happening. There are so many things, right? So there are statistical methods using that you can fit a line. So now if I fit a line, the line is in the middle and it is like this. So this means there is a relation. As the age goes up, the salary also goes up. In some other scatter plots, when you do, let's say you are plotting something else. If you fit a line, the line will fit like this. That means there is no relation. So you have some commands and methods to fit a line using distributions. You can call a distribution and say that I want to fit a line to this, and I will show you. So it will fit it and show you that what is the tendency of your graph, right, towards what side you have. So this is called a scatter, right? What if you want to do something else? You want to look at people who are coming from different city, bivariate analysis. You want to take a look at people who are coming from different city and then compare the salary. So I want to find out whether salary has an impact of a person who is coming from a city. So that is again bivariate, but what is the problem here? My variables are, the city is a string and the salary is a number. What will you plot? You can't plot this thing. Scatter will not work. Bar will not work. By pie chart. Okay, pie charts we are not discussing now. That's off topic. I'll discuss that later. So you may not know.
4 bubbles or 3 bubbles.
There is something called.
You have 3 bubbles. Like you can plot each bubble, like Bangalore with a bubble with a.
So technically there is something called a box plot. This is what we use in Seaborn. So there are 1,000 types of plots. We are discussing specific to Seaborn, like your analytics, right? So because you are learning more from the statistical point. If somebody asks you like what kind of a plot, your answer is box plot actually. And I don't think maybe you have seen box plot. It's very rare, right? But the idea is very simple. What box plot does is like this. So let's say there are 3 cities. So city will be here, Bangalore, Chennai, then what is there? Delhi or Mumbai, something. 3 cities, and then you will see something like this. It's a weird kind of plot. I don't know how many of you have seen this. Have you seen this kind of a plot? Probably something like this. Have you seen some weird plot like this? This is called a box plot. But it is more important to understand what it means, right? So, by looking at it. So, what it actually does is that there is something called mean and median. You will know already. Mean is mean. So, what is the difference? Are they same? No. Median is different. For example, you are calculating the average salary of people in this class. We are all here. Now, let's say I invite Mark Zuckerberg to sit in the class. And then if you calculate the average salary, all of us will be millionaires. That is mean. Understood? What will happen? It will impact it. So, Mark Zuckerberg has billions of dollars salary. You calculate the mean, what will happen? The average class salary will be 10 million, 100 million, You all can easily become millionaires. That's mean. But if I do the same with median, what it does, it will order the salaries in the ascending order and pick the middle value. You will get much more sense on the data, right? So in the box plot, what happens is that it will pick Bangalore, okay, and the salaries will be arranged in percentile in a median fashion and will show you the middle value. So right now, if I look at, you can see that people from Delhi has more salary because this is the median of Delhi and this is more than this. So by looking at this, you can say that people from Delhi has more salary compared to people from Chennai, compared to people from Bangalore. So this will draw you percentiles, 25 percentile, 50 percentile, 75 percentile, and box it like this. So when you have an integer and string, normally what we do is a box plot normally to get an idea, right? Now the point is that what if I want to further divide this into male and female? So going from bivariate, I want 3 variates. So I want to look at Bangalore, Chennai, Delhi. I want to plot the salaries. Within that, I want male and female. So things will become more complicated. You will see some more like this. Here one more box will come. That's how the thing will work. Because now again you are categorizing what? Male and female. But that's not a good idea, because if you do 3-4 variable plotting will work, but you cannot make sense of what is happening, right? So the visualizations are not very powerful. But so normally we do univariate and bivariate analysis. Anything more than that is not typically a good idea to do, right? And that is exactly where your ML and all are going to help, right? Machine learning and all. So for example, I have some sales executives and my sales are declining every month. So I want to know why the sales are going down. So I can easily draw a graph. I can say the age of my executive and the sales he is doing. That will give me a graph and it will show me that, okay, probably the reason is age. But now I am thinking I want to include the age of the person, the sale, and also from which city he is coming. Now I want to include age, from which city he is coming, is he married, how much distance he is traveling. So I want to include, let's say, 7 or 8 parameters. So you cannot draw that. That is where you say, call a machine learning algorithm, let this guy work on all these features, 7 or 8 features, and then tell me why my sales are declining. That is where actually ML works, right? So basically, you can say that it is an extension of your visualization. Not visualization, but problem solving, basically, right? So sometimes I handle the intro to ML class and I give a very interesting example. But this is not related to visualization. So normally people ask a lot like, what is machine learning? Can you explain it? So people talk a lot about machine learning, but I always give them a very simple answer. So if you draw a quadrant like this, right? So let's consider 4 scenarios. So first quadrant is called a KK. So that means there are things which you know that you know, right? For example, you know Java, for example. So you're a Java developer. So you know that you know Java, right? I mean, that is your understanding. So first quadrant is where you have the knowledge of something which you already know. The second quadrant is KDK, meaning you know things you do not know. So what is that? For example, machine learning. You don't know machine learning, which you know, right? So that is the second quadrant. So what will be the third quadrant?
Don't know but know.
Yeah, things which you don't know that you know. Right? I went to Kashmir and I went to this, skiing. Right? Have you ever done skiing? No, right? Yeah. So I went to skiing and these guys fitted all these things to me. And then normally what they do, they will come with you because you don't know skiing, right? And they will slowly make you ski. But for some reason, I don't know whether he didn't like me or not, he just pushed me from the top. Then I was in the third quadrant. I knew I know skiing. I really skied. I mean, I never thought I know skiing, but he pushed and I'm like, oh my God, I'm actually skiing. Right? So the third quadrant is things which you do not know that you know. You learn from experience or feedback. Then what is the fourth quadrant? Huh? Things you know? Don't know that you know. No, that's already there, right?
It is existing, but you do not know it yet.
Okay. Maybe things, things which you don't know that you will never know, right? Well, yeah, so now how do you put it in perspective? So this is your normal analysis. This is like your SQL queries, programming, right? Because things which you know that you know. So you have some data, you want to write a SQL query, you know already the data is there, you know the query, you do everything. And the second quadrant is things you know that you don't know. For example, this is where business intelligence and all comes into picture, BI. For example, I have some data and I have a visualization tool like Tableau. So I'm plotting a visualization in graph. So things which you know that you don't know. So I have the last year sales data, but I don't know whether my company is doing good or doing bad. So I use a visualization tool. It will visualize the data. After it does, I know that, okay, I know what is happening. Third quadrant is things which you do not know that you know. So that's like a feedback mechanism. So some of this data mining and all will help you to do this. So data mining and all falls in this. This is machine learning. Fourth quadrant is the gold mine. That is where you are. Meaning somebody is going to give you some data and they are going to tell you that, tell me something which I do not know about this and I can never figure it out, which will help me as well. That's where you fit. And that's the actual definition, right? The machine learning is where you have some data and you have no clue. I mean, you already know something about the data, but you are trying to figure out something which is not possible through any three quadrant. Alright, you are trying to understand something which nobody can otherwise give you an idea about. So you are just going to get some data and then you have to get a useful insight from the data and then show. That's all you are doing in ML. So fourth quadrant is actually where ML algorithms and all will come into play. So I usually give this example and that is why this is actually very costly. Right, the people who are working in this quadrant, so this may be the lowest salary, I mean not generally, but then these guys might get more salary, this is the highest salary probably, because.
When do we use plotting?
For plotting these graphs, I'll show you.
I mean, how do I know when should I import?
Yeah, so we use only Seaborn. Plotly we don't use much. So the only difference between Seaborn and Plotly is like Plotly can have this kind of, if you hover your mouse and all, it will show the data. Seaborn doesn't do that. So if you do a plot, you can see the plot, it will not show the numbers. Plotly is much more interactive. Apart from that, not major differences are there between them, right? So let's look into this visualization also from the, notebook point of view. So you just need to upload a notebook. I'll tell you which notebook. Just go to upload and in the desktop you should have a notebook. Can you see this Python visualization? Just open that. Upload it. Also we need some data, so I can say upload this housing prices. There is a housing prices data. You can upload it. Both. One is the notebook, one is the data you are going to use. Well, I am not covering everything, but something which is important for you. So just run this first cell and also the second cell. So basically, what are we importing? We are importing Pandas as PD. You are importing Seaborn as SNS, Numpy as NP, Matplotlib, PyPlot as PLT. So we are importing Matplotlib Seaborn. And the last line you see, this Matplotlib inline. What this means, normally when you plot graphs, the problem is that the notebook will not display that. Graph will be plotted, but it will not display on the screen. So you have to add this inline functionality, so it will display that in the cell. That is why we are adding this inline. And what we are doing here is that we are just reading the housing data and just look at the shape of the data. So this data set is actually quite complicated in the sense it has around 81 columns. Lot of columns actually. So if I show you that, where is it? Housing prices. See, this has around 81 columns, so it's very difficult to show the whole columns. But what it actually has is that this is the housing sales data from US. So you will have the square feet, number of bedroom, number of bathroom, and all the properties of the house basically, and the sale price and all, right? So you have different columns. you can actually do a head to understand how, see, so you have lot frontage, lot area, street, lot shape, utilities, pool area. No, these are all the columns we have. So many columns are there. So read the data. You can also look at the columns. So these are all the columns we have. What is the foundation? What is the basement square feet? What is the basement exposure? What is the bedroom square feet? And all these things are there. So you can actually, are you able to read the data? I mean, load the data? Yes, right? Yeah. So let's look at a univariate analysis. So what I'm going to do, I'm going to do a dist plot on the lot area column. So lot area is a column which has integer kind of value. And normally in cases of your Seaborn, when you want to do a histogram, you will say dist plot. Dist plot is your histogram. And it is very easy. You will say SNS dot dist plot, and you will say I want to look at lot area. There is something called KDE which is false. I'll tell you what it is, but if I run this, this is how it looks like. So this is a histogram which is talking about what? The lot area, and there is something called KDE. KDE stands for kernel density estimate. I'll tell you what it is. It is false right now, okay? But can you make some useful inferences from this plot? If you see this, are you able to make any inferences from this plot? No? No. Yeah, so what one inference which I can make is that there are a lot of outliers in the data, or what you say, there is a lot of skewness in the data, meaning a lot of data is actually shifting here, right? I mean, most of the data that is coming in this 600 or 500 range, right? This range actually, and here also you have points, but they are very small. So this is called outliers in the data. Outliers means in some of the machine learning problems and all, you need to remove outliers, right? So a common example is, like I said, the salary of Mark Zuckerberg. Like, so if I'm plotting the salary of everyone, and if there is a millionaire or billionaire, that's called an outlier, because that may impact our overall, analysis. In some cases, in ML algorithms, we consider them as an outlier. In some cases, we remove them to avoid messing with the data. So this actually has outliers. This is actually shifting towards this side. Okay, it's not a uniform distribution that we have. That's one thing. And if you keep this KDE as true, what will happen? So let's keep this KDE as true.
What x and y represent? X and y dimension?
Well, there is only one dimension, x. That is a lot area. So you are taking the lot area, and the lot area starts from 0 to, let's say, 2 lakh or something, and then you are finding how many points are there. So there are probably 200 or more than 100 houses in this lot area, 0 to 50 or something, and then again this much, like that, right? So these are the number of houses which has this lot area. So if you run this with KDE equal to true, the only difference is that it will sort of like draw a graph kind of structure within this and try to fit all the points. So the total will be 1. So you will learn about KDE distribution later, but basically what it tries to do is that it will try to fit all these points within sort of like a graph, so that the sum is actually 1 if you add them together. So KDE is a technique we use in statistics more.
So how do I make it plot only till the 50,000?
Only
Range of the x-axis, can we reduce that?
range of x-axis. You can. So right now you cannot. There is a way to remove outliers. I'll show you how to do that. Okay. So now if you are looking at this, have a look at this. Here I am saying an SNS dot count plot. Okay. And what is the thing that I am considering here? Exterior first, and data is housing. So let's just run this and see what it is. So what is this? Can you tell me? What kind of a graph is this? It is a bar chart, because what are you doing here? If you want a bar chart, you will say count plot. And the exterior, the coating, the exterior, coating, what you are using, that is this vinyl, metal, so these things. So it will plot a bar chart like this. Now, what is this second line I have added? So if I just comment that, I'll tell you. So this is useful. See, the second line is actually what I'm doing is that I'm taking the x-axis and rotating it a bit to fit the points. See, now you have vinyl and everything, but you're not able to read them, right? Because they're all cluttered. So to remove that, it's like a standard line of code. You add this code. You will say set x tick labels. You will say get rotation 40. So basically what will happen, they will just spread evenly so you can read them. So this line you can add if you just want to read them. So right now you can see that most number of them are vinyl and least is what? Something else, brick or something. So this is how you plot a what plot is this? Bar, right? Okay. Give me. So let's go to so have a look at this. So what is this? This is called a reg plot in case of Seaborn. It's called a reg plot. So what are you plotting here? It's a bivariate analysis. You are plotting lot area and sale price. So you are thinking whether there is a relation between the lot area and the sale price. And lot area and sale price both are what? Integers, right? Both are integers. So what is that? It's a scatter, right? And what it will do is that it will fit a regression line along with this. That is this regression line. This is the regression line that it fits. Now I think I have added it. So I have added it here. So let me show you something. So now again, if you look at here, even though this plot looks nice, there are a lot of outliers. Look at this point, right? And look at this point. So here is where the density actually shows it very clearly, but you have a lot of outliers here. So this is your sale price and this is the lot area. So there are some houses like this where the lot area is very high and then the sale price is very low also. And here, you have some houses where the lot area is very less, but the sale price is very high, right? But they can be very less, not very more. But so you just want to remove the outliers. You don't want them. So there is a way you can do it. So in Seaborn, let me see if it works alone. Have a look at this code. What I'm doing, there is a function called quantile. There is a function called quantile. What I'm doing, I'm picking the lot area. I'm saying that I want quantile 0.5, 0.95, 0.99. What do you think this is doing? This is finding the percentile. So in the lot area, I want to find what is the 0.5, 0.95 or 5th or 95th or 99th value if I arrange them in the median order. So if I run this, I can see 0.5 is this, 0.95 is this, 0.99 is this. Now there is a problem because 0.5 is 9478, but when I go to 0.99, the value is very high, 37,567, etc. Right? So because of outliers, because that is very high. So what is 0.5? This is your median. Median value is around 10,000, right? But your highest value is around 37,500. So that means clearly there are some outliers in my data. So if I want to remove the outliers, I can do things like this. I can simply say, I am again doing a plot, but I am saying that housing log, I just want to pick the lot area which is less than quantile 0.95. So I am removing everything which is above 95, and if I do a plot now, okay, so we need to housing sub, right? So data is housing sub. If I do this now, can you see? So now what I did, I just saved it as housing sub. Okay, now I'm plotting again with lot area and sale price. Can you see it's much more, what you say, without outliers, because I am considering only the data till 95 point, and the points are much more, aligned together. So by looking at this graph, we can probably say there is a variation. I mean, the line is actually pointing towards upwards. So you can say that as the lot area increases, sale price also. So one way to remove your outliers is to use the quantile. So find out the quantile and get the median value. Then if you feel that after 70% every value is very high, you say I want to filter it, I don't want after 70, then put it. And removing individual values, I don't think that is possible. Like I cannot pick an individual value and remove it. Some of the values you can remove like this.
But this quantile.
Which one? No, I just took 0.95. It can be any number. So right now when I did the quantile, I saw that 0.95 is 17,000. Right? So my median is 10,000. Okay, that is a middle. So up to 20,000 is fine. So up to 0.95 I am okay. But when I go to 9.9 it is huge difference. So I just thought I'll keep it at 9.5. So it can be any number. So that you need to decide and take a decision. What number you want?
How do you get it? Like 0.5 and 0.9?
I run here this line of code.
No, the number. How do you get it?
This 0.5. So that is we need to decide. So the number is from 0 to 1.
No, how do you decide?
No, any data the numbers are same. 0.5 is 50%.
Yeah, I agree. So it is common for all the data? Okay.
Any number of data you get. So let's say you have 1 million points. Okay, 1 million houses are there and price of 1 million houses. If I say 0.5, it will give me the middle value. That's it. It will arrange them in the order and give me the middle value.
Every data outlier, number of outliers will be different.
Right.
Then how would we understand that?
No, that is depending on the column. That is depending on the column, right? You are not looking at the whole data. So here, my analysis is on lot area. So I will first pick the lot area and run the quantile to get how the distribution is.
So this quantile gives me which data has transformed.
No, I am running quantile on the lot area column. It doesn't consider data, it considers only lot area column. So what it does is very simple.
So whether it will give you the median data?
That's what. So I am saying lot area, right? Lot area dot quantile. And then I am saying, let's say 0.2, just as an example. Okay. So what it will do, it will arrange the lot area in the ascending order. So lot area may start with 1, 2, 3, 4, 5, up to whatever number you have. And then it will calculate the median of that. So if I say 0.5, the middle value will be given. If I say 0.2, 20 percentile, whatever value comes in that part will be given. So then you can look at the data and say that, okay, 0.2. So this is roughly the 20% of the data if you reach, at that point this is the value coming in. So then you know, right, okay, whether it is an outlier or I should remove it or not, and then you can make a decision. Well, that's up to you to decide how to make a decision, but this is one way of doing it. So now you see this is much more what you say. Okay, so I just want to pick up one more interesting thing. So basically what it is, if you look at the columns of our data, there is something called square feet. There is something called square feet. But what is the original data? What is the name of the data frame we created? Insert cell above. Housing? Is it housing? I don't know. Housing, right? So when you look at the columns, right? There are certain columns where the square feet comes into picture. Let me show you. Where is it? So here you have basement square feet. Here you have total basement square feet. Then again some basement. Then again some basement square feet. So basically what I am doing here is that by running this, I am just selecting all the columns where there is an SF. So you want to do some analysis based on the square feet. Now imagine I want to plot a graph where I want to plot multiple graphs. So how many columns are there with square feet? 9 columns. I have 9 columns where there is a square feet in it. Now for each column I want to plot a graph. Because there is basement square feet, there is square feet of the kitchen, total square feet. For each, I want to plot a graph. Multiple graphs I want to plot, but all in a single canvas, right? So if you want to do that, let me split it, otherwise.
So basically, this if f of in call names, this is the function of the string actually.
No, this is a list comprehension we discussed, right? X star X in list. This is called list comprehension because all of this is within a list, okay? So I can say column name for column name in housing.columns. So basically what it does.
Okay, it is actually for column names, it is not for a data.
No. For the housing.columns, it will say if SF is in the column name, it will just return it. That's what, and store it as SF underscore columns. So if I look at SF underscore columns, somewhere it will be there. SF underscore columns. You will get all the column names where there is SF, square feet written. So now my problem is I just want to plot 9 graphs in one graph, okay? Because I have 9 square feet data. For each square feet I want to plot a sale. Probably my customer is saying that I just want to know whether the square feet of my basement affect the sale. Or probably the kitchen square feet actually is affecting the total scale. I don't want the total, I want each area to be plotted. So how do you do it? But in order to show this, I need to first show you something before this. So there is a very useful function. I don't know how to show this. Can I reduce? Can you see? So what I did, you have the notebook with you, right? There is something called as subplots. You can say number of rows 3, number of columns 3, fixed size 10 by 10. Basically what it will do, it will return a canvas to me where there are 3 columns and 3 rows. Basically it is like a subplot. So what you're doing here, you have one canvas, within that there are like 9 individual graphs within that. So the command that you need to use is that plot.subplot, how many rows and how many columns. And if you change this fixed size, the total size will change. That's only what is happening. So if you run only this line, what you get is this plot. And if I want to get the first graph, I can say 0, 0. Then I can say 0, 1, etc. So if you look at this code, so here what I'm doing is for I in range, column, and let me say if I want to print it, print rows and columns. Oh, I just increased this font. So now I think you are able to see that, right? Yeah, let me see if it works, okay? Have a look at what I'm doing. This first line is basically plotting a canvas where you will have 3 rows and 3 columns. So totally you will get 9 small graphs within that. Then look at this for loop. For I in the range of 0, length of SF column. What is length of SF column? 9. So I am opening a for loop. I am saying that the range is 0 to the 9. So 0 to 8. I am saying rows equal to I division 3, columns equal to I percentage 3. So what will happen for each? So this will basically, if you run this code, it will print 0, 0, 0, 1, 0, 2, 1, 0. Can you understand how it is printing this? Because first I will be what? 0. So if you take 0, it will say 0 modulo 3, this one, you will get 0, right? Again 0 percentage 3 will be 0. So this is like accessing the first graph. If I say 0, 0, I will access this graph. I'll show you how to use in the code. But if I say 0, 1, it will access this. Again 0, 2 means it will access this, right? So I'm just first writing a simple for loop. So I have the index positions to access the individual subgraphs, right? So basically if you run this code, you will get this. And then what are you doing? If you scroll down in this code, I will say rows and columns, and again I will say I want to write a regex plot, okay, where I will say x equal to columns of I, so this will start from 0 to y equal to sales price, data is housing. If I run this, I should ideally get it. Can you see? So basically what is happening here is that again you are doing a reg plot. This is a reg plot only. The only difference here is that you will say SF columns of I. So what will happen? Initially it will be columns of I, means it will go to 0, 0, then 0, 1, 0, 2, etc. Y sales price, and data is this. So you can plot multiple graphs. So here you can see, probably you look at this second graph, there is this basement FI and SF2. The graph is very linear, the middle line, right? It's very horizontal. So this means there is no impact on the basement FI and SF2 square feet with the sales price. But if you look at the first graph, you can see there is a very steep climb. So that means there is a impact on that, right? So you can also plot like sub graphs and all if you want. So just to show you a simple example.
What is the use of this sale price?
So that is, so you are plotting the basement area with sale price. On each of this, the y-axis is actually sale price.
That is to just write it, right?
No, so see, it is a bivariate analysis, right? What do you mean by bivariate? There are two variables. What are the two variables? One variable is sale price. What is the other variable? Other 9 variables are there. Square feet of basement, square feet of this. So for each, this x-axis is changing. Can you see? This x-axis is what? Basement SF1. This is what? Basement SF2. This is basement unit. But y-axis is same, right? Sale price. So for each square feet, you are plotting against the sale. So imagine like you have a house with 10 rooms. For each room's square feet, you are plotting a graph. So you have to pass the y-axis, right? What is a y? That's why I'm passing here.
SF column I, will you explain that?
Which one?
SF columns I.
This one, right? So basically here what will happen if I call this I, so this is like the first, if you run this for loop, what will happen? It will generate, I showed you, right? 0, 0, 0, 1.
Yeah. So AX I'm getting, so probably the first time it runs, so it accesses the first graph. And the Y is sales price, the value is sales price, so what is it calling?
I is calling this basement SF, whatever is there, this variable, this column, whatever you are having. The column you are plotting on X. You need something on the X axis, right? So each column name I am calling. Because my, where is that SF underscore column is a list. So if I just print SF underscore column, let me just print it, okay? SF underscore calls, right? If I just print it, it is just a list. SF underscore call is just a list, right? From this, I am calling the individual what? Values. Let me run it again, then I'll show you. So this is the x-axis, right? What is the x-axis? From SF underscore columns 1, 2, 3, 4, each one. Did you understand this? Give me one moment. Let me go up. Did you understand this line? No? So this is where we created SF columns, right? I think probably you missed it. See, the point is, where is it? If you go up, my original data is called housing. And if you look at the columns of housing, I have around 80 columns, right? And in that, there are 9 columns which has square feet. So, which are those columns? Where is it? In this. Yeah. So, this is one column. It is called basement final SF1. Wherever you have SF, that is square feet. Then you have total basement square feet. So here what I am doing, I am writing a list comprehension. I am saying that I want to filter all the columns which matches SF and store it in something called SF columns. And if I simply run this, you can see the columns. Sorry. These are the columns. So how many columns are there? 9 columns are there. From that I am plotting in x-axis. That's what is happening here. So you are getting one by one, right? Okay. So there are more visualizations, but we will not go to everything. I mean, so you just need to have a basic idea, right? Okay. Oh, we didn't see that this thing, right? Box plot thing. I think I removed it. There is a box plot. Somewhere it is there, right? Here. But there will be one problem. Okay, so what are you doing here? You are saying that box plot, you are plotting exterior and sales price, right? But again, the same problem will happen here, because if I do a box plot at the x-axis, if you look, you are not able to understand, right? So you need to add that line. Let me just get it from here. Where did we use it? Scatter we used, right? No, here we used this one, rotation. So I just need to add this, I guess. I scroll down. Yeah, so now if I add it here and then run it, now it's more like it. No, it's not printing. Should print, right?
You wanted it to a plot.
Sorry. Okay, I should set it first, right?
Set it to plot.
Where?
Plot is equal to SNS box.
It should work, right? Let me just keep it here.
Plot equal to SNS.
Plot is equal to
SNS box plot
SNS.
should be something, then you do use that.
Sorry, I didn't get.
So second line you need to assign it to.
Second line you should assign it to a variable, then use that as a plot.
Okay, yeah. So, sorry. Yeah, what I meant. Got it. So, why that? Because got it. So, you need to assign it first, because why you need to assign it? Because the original plot cannot be altered. So, you are saving it as a plot and then you are saying that on the label I want to change it. So, this is how the box plot looks like. And what are we plotting here? You are plotting the material used for exterior painting against the sales price, right? So you can see that. So what is the inference you can use from this? What do you understand by this plot? Make some inferences from this.
That first column has a lot of outliers.
Outlier is fine. Apart from outlier, what this tells you about the house? So if somebody is asking, so how is the cost involved in this? For example, if somebody is using vinyl is here, right? Vinyl is here, right? Then what do you have? This is what? Metal, right? Metal is cheaper, right? Because here you have the different coating and there you have the sale price. So you can see that vinyl is actually, very high. But also look at the length of this guy. That also matters. So this means, what is this thing? I don't know, plywood or something? No. Cement. So this is very big. That means there are a lot of houses actually in this. That also matters actually, right? And these dots you see, they are the outliers. In this box plot, these dots you see, right? They are the outliers. There is a way to represent them, but normally you see it as a dot. So probably, in this plot, most of the ranges are here, but there may be outlier here. Actually, that is what you represent here. And if you look at something like this guy, this is very costly. I don't know what it is, something, but it is again very costly because the median value is very high. So you always look at this median value and see how the plot is actually going. That's a box plot. This line. Now this is a standard, axis representation. Oh, this one. So this one actually, so if you look at some of them, this actually encounters the outliers also. So it just says that this is pointing towards outlier. Some of the, in general, there is nothing to be done. The size actually matters. For example, this data is very big, right? So if you look at this line, you can see that the total length is actually big. And this one is very small because the amount of data that you have is very small.
Are the vertical lines representing the range?
This one, which I don't know, I don't think so. No, I don't think the length actually matters. The median line actually matters where it is. Median line is what actually matters where it is, right? I don't think length actually matters. But general consideration is like if the amount of data you have is more, then the length will be more. Total line I'm saying. These are the values that falls in that range. For example, plywood, these many values are there. You don't get a number, but if this box is bigger, more values are there.
And the same line also what will be?
Now, line is just a sort of visualization. This is actual values are here only. Because you look at this guy, this is very small, right? And this is bigger. So box plot actually starts with 2 lines actually.
There is a kind of confusion.
No. You should not consider this. You should consider this boxes actually. Not these guys. And also in the middle what you see, this line, what you see, that is a median value actually, right? This is the total range. This. This is 50th percentage. Yes, in this range. Oh, that's what you are asking. Yeah, so if you look at the whole graph, this is the minimum, this is the maximum. Okay, this is the minimum value, this is the maximum value, and this is clearly an outlier. And this is the, median value that you have. So most of the points are centered over here, it seems. Okay, so visualization, I think basic visualization we have covered. If anything is else pending, that will be discussed in your respective statistics classes, right? Because you should know what is the difference between, let's say, a box plot and a normal plot, and how it looks like, what is the use of it. Apart from that, conditions and all, later when you get the actual data, you will be adding and discussing them, okay?
What you now need to do is you now need to be able to get the data to solve this problem. So therefore, the statistical way of thinking typically says you formulate a problem and then you get the data to solve that problem. The machine learning way of looking at things typically says, here is the data, tell me what that data is telling you. Many of my colleagues and I myself have run into this problem when going for interviews, etc., etc. And so sort of statisticians say that we're not getting jobs out there. And so I go to people who are hiring and saying that, why don't you hire statisticians? And I reach an interesting conclusion to this entire discussion, that sometimes around the way the interviewer who's interviewing the statisticians for a data scientist job asks the question, here is my data, what can you say? And the statistician answers with something like, what do you want to know? And the business guy says, but that's why I want to hire you. And the statistician says, but if you don't tell me what you want to know, how do I know what to tell you? And this goes round and round, right? No one's happy about this entire process. So there's a difference in the way these two communities approach things. My job is not to resolve that. Because in the world that you will face, you'll see a lot more of this kind of thinking than you'll see in this kind of thinking. Because in this world, the data is cheap and the question is expensive. And you're paid for asking the right question. In this world, the question is cheap and the data is expensive. You're paid for collecting the data. So sometimes you will be in a situation where this is going to be important. For example, let's suppose you're trying to understand who's going to buy my product. You're asking the question, let's say that my products aren't selling, and you want to find out why. What will you do? Get what data? So let's say that you're selling, I don't know, what do you want to sell? You want to sell watches, say? So let's suppose people aren't buying watches anymore, which is a reality, correct? So you're a watch company. Who buys watches these days? The entire business model of a watch is disappearing. Do you have watches? Some of you have. Right? He has. Actually, a surprising number of you have. Maybe they do different things these days, right? That seems like a very... That's a fitness device, is not really a watch at all. So something like this was actually with my daughter at lunch today. So she got something like this. I'm not sure. My wife, who's an entrepreneur, runs her own company. She came back from Delhi. She came back with 2 of these. I don't know where she picked them up. So my daughter, the first thing she did, she took one of this and she took this thing out, because she thought of the whole wristband as an unnecessary idea. I mean, that didn't occur to her. I mean, that's a separate thing. That's a nice little beautiful red wristband, etc. So a watch is a different thing. But let's say that you're a watch company, nobody's buying your watches, or fewer people are buying your watches. Now, how are you going to solve this problem? Or how are you going to process this information? What do you want to do? What do you want to know?
Check the models testing do not say.
Okay, but remember, I'm asking this question also from an analytical perspective. So when you say that, to check the model and see what is not sold, that assumes the whole data question. So first order, you'll see sales. For whom and when and how? How do you structure your data? How will you arrange the problem?
What are your competitors selling?
Okay, that makes problems even harder, because now you're going to look for data that isn't with you. No, he's right. Maybe people are not buying watches because they're buying something else. That's a reasonable thing. But let's keep this problem simple. Let's consider only data that is within you. We'll go outside, not to worry. But let's say that I'm looking at my data. What data do I want to see and what questions do I want to ask of it? So sales year by year, types, and then what comparisons do I want to do?
Year on year.
Year on year?
Region wise.
Region wise, age. With what purpose? What question am I asking the data?
What section of customers are buying my product, or
what section of customers are buying my product compared to what?
What has changed in terms of the
what are my biggest set of customers?
So that's one thing. Who are my biggest customers? Okay. That's a very interesting question to ask, except that question implies that I needed to know who my biggest set of customers sort of could have been. But it's a good point. Where is the bulk of my sales coming from? Then someone else says something about time. Is it going down? So you can look at things like saying that for which group of customers are my sales going down the most? For example, you could ask that. I'm not saying that's the right question, but that's a possible question to ask. So let's suppose you follow that approach, that I'm trying to understand. I know that my sales are going down. That's an obvious thing. My CEO is telling me, my CFO is telling me, and if I don't stop this, we're all going to be out of a job. Correct? The HMT factories in Bangalore are not in good shape. One of them, I think, has become the income tax office. Right, somewhere in the Malleshwaram area. So that's going to happen to me if I don't do this well. So I know my sales are going down. But I don't know by how much and particularly for whom. So are there segments for which the sales are going down? Which segments are sales going down the most? In which segments are they going down a little bit? How fast are they going down? I can ask questions of that sort. Now, what conclusions at the end of this do I want to be able to do? How do I want to use this information? Now, for this, you usually follow something like a 3-step process, and you may have seen this, and this covers both these sides. And these words should be familiar to you to some extent. The first is called descriptive. The second is called predictive. And the third is called prescriptive. Have these words been introduced to you, at least in this you've read it, I'm sure. You all cruise the web and look at blogs and things like that. Nothing new in this, I'm sure. But I just want to set a context because it's going to talk a little bit about what we're descriptive. There's a C here. So descriptive, predictive and prescriptive. Now what is a descriptive problem? The descriptive problem is a problem that says that describe for me where I'm losing my sales and when I'm losing my sales. It just describes the problem for me. It tells me where the problem is. It locates it. It isolates it. The predictive problem says, look at this data and give me an idea as to what might happen or what would happen if I change this, that or the other. So let's suppose I do the following kind of idea. I say that, let me relate my sales to my prices. Let me try and understand that if I reduce my prices of my watches, will more people buy them? Conversely, if I make my watches luxury items, increase the price of a watch, remove a low-end brand and make a watch an aspirational thing, a decorative item, a luxury item, a brand item, so that people wear a watch not to see the time but also as a prestige statement, as a fashion statement. Whatever it is, if I do this, then what will happen? That's predictive. I'm trying to predict something based on it. I'm trying to say if something happens to, let's say, one part of my data, what will happen to the other part of my data? And then based on that, the doctor carries out a predictive analysis of you. Because I see this, I now think you have this issue. You have this thing going on. Let's say I'm diagnosing you as being pre-diabetic. You're not yet diabetic, but you're happily on the way to becoming a diabetic. Now because of this, I now have to issue you a prescription. I now should tell you what to do. So there's the data that comes from you. That data in some way is modeled using the domain knowledge that the doctor has. And that model has translated into an action. That action is designed to do something. Typically it's designed to do something actually fairly complicated. The first action that the doctor tries to do is, number one, let's say do no harm, the Hippocratic Oath. First let me make sure that I don't do any unnecessary harm to the patient. Then let me, shall I say, optimize his or her welfare by making sure that I control the blood sugar the best and that I postpone the onset of diabetes as best as I can. It's a complex optimization problem of some sort. In a business also it's a complex optimization problem. Right? I need to be able to sell more watches. But I also need to be able to make money doing so. I can increase my sales, but if I increase my sales and my profits go down or my earnings go down based on the cost, then that's a problem. But at the same time, if I try to run a profitable business and nobody buys my product, that also is not a particularly good idea. Then there are other issues maybe in running the company. I've got employees that I want to keep on the boards. How do I run the company in such a way so that it needs that particular labor force? I have finances to take care of. I have loans to repay. How do I get the cash flow in order to repay the bank loans that I have? So the prescription has to meet lots and lots of requirements. If you are building an autonomous vehicle, you'll have situations saying the car has to do this. But it also has to follow certain other rules. For example, if it sees someone crossing the road, it should stop. But it shouldn't stop very suddenly. Because if it stops very suddenly, it's going to hurt the car, it's also probably going to hurt the driver. So it needs to stop, but it shouldn't stop too suddenly. It has to follow the rules of the road. Because otherwise the computer will simply say, oh, you want me to avoid the person crossing the road? I'm just going to go behind the person. And you're going to tell the car, please don't do that, because there's a house next to it. You can't just sort of do that, oh, you didn't tell me that. You just told me to avoid the person. You didn't tell me about the house. Okay, we'll put that as a constraint in our program and see how well it goes. So prescription is problematic. Another simple way of doing it might be to say that description is how many centuries has Virat Kohli scored. Look up Cricinfo and it will give you the answer. Prediction might be try to guess how many centuries Virat Kohli will score in the World Cup. Prescription might be how do we get Virat Kohli to score more centuries in the World Cup. And as you can figure out, You're going from a purely data-based version of the problem into something that's only notionally about the data. Data will help you, but there's a lot more than the data when it gets to that. What we'll do today, what we'll do now, once I've finished talking to you, is we'll take a look at what the descriptive part of analytics is. So the descriptive part of analytics is talking about simply describing the data without necessarily trying to build any prediction or any models into it. Simply telling you the way it is. This is hard. This is in itself not necessarily an easy thing to do, because you need to know very well how to do that and what are the ways in which one looks at data. This is skillful in itself. So, for example, let's suppose that you're a doctor. You go to the doctor, and the doctor is looking at your symptoms, and the doctor recommends a blood test. Now, how does a doctor know what blood test to recommend? Based on the symptoms. But remember that potentially there's an enormous amount of information in you. All of us as biological things carry an enormous amount of information in our blood, in our neurons, in our genes, or wherever. You know, if you're talking about big data, as I said, there's 2 meters inside every cell, and there are a few billion neurons in your head. You don't need to go far to see big data. You are big data. You are one walking example of big data. We all are. Right? Now, in that big data, what little data does the doctor know to see? That's the descriptive analytics problem. The doctor is not doing any inference on it. The doctor is not building a conclusion on it. The doctor is not building an AI system on it. But it's still a hard problem. Because given the vast amount of data that the doctor could potentially see, the doctor needs to know that this is interesting to me, and this is interesting to me, and this is interesting to me. And this is interesting to me in this particular way. For example, a blood test. Let's suppose that I draw blood from you for a particular purpose. Let's say for blood sugar. Correct? Leaving aside the biology of how much blood, etc., to draw. None of you, I guess, are a doctor. Any of you are doctors here? Any doctors in the room? No doctor, so I can say whatever I want to. You won't understand what I'm saying. No, but I'm old enough that this is a real problem for me. So you have a large amount of blood that's flowing through you. We all do. This blood carries nutrients. What that does is that every time there is a nutrient inflow, the blood looks a little different. So if you eat, your blood looks a little different. Because that's your blood's job. The blood's job is to carry nutrients. So if you want to run, you want to walk, if I'm walking around, my legs are getting energy from somewhere. The energy needed to my legs is being carried from the blood, and it is being generated through inputs that I get. Some of it because of the air that I breathe, from where it gets the oxygen to burn things. Some of it from the food that I've eaten, the nice lunch that I had, where it gets the calories to do that. So therefore, based on what my energy requirements are, and based on what I've eaten, my blood is not constant. My blood content is what is known as a random variable. What's random about it? Because it looks a little different all the time. Your blood at 12 o'clock is going to look a little different. 12 o'clock at midnight is going to look a little different from 12 o'clock at noon, because it's doing something a little different. The same phenomena is there everywhere. If I were to, for example, measure the temperature of the oil in your car or in your two-wheeler, what do you think that temperature will be? It depends. First of all, it depends on whether the car is running or not. It depends on whether it has run or not. It depends on how much oil there is. It depends on how you drive. It depends on the temperature rest of the car. The answer is it depends. And the same is true for your bodily fluids. So this becomes a slight problem. Because if it is random, then from a random quantity, how do I conclude what your blood sugar is? How does a doctor reach a conclusion of any sort? Average of what? Average of particular duration. So there are multiple averages that you can get. First of all, there is a question of saying that if I take blood from you, how is the blood usually collected? So the phlebotomist comes and usually takes an injection from one point. Let's say by some strange accident, this is thoroughly inadvised, but let's say by some strange accident, two different people are drawing blood from two hands at the same time. Do not try this at home. But let's suppose they do this. Will they get the same blood?
Depends. Ideally, yes.
Ideally, yes.
It depends.
What time?
Same time. Right, at the same time, as I said, do not do this at home. But at the same time, you're getting two different samples. There's not just a question of time. Your blood is not going to look the same even within your body at one period of time. Even from the left hand, even from the right hand at exactly the same period of time, it's not going to look the same. There is a slight problem that's somehow a little obvious, that you know your heart is in the middle. Right? Your heart is actually in the middle, but it beats to the left. Why? Because the heart is what? The heart is both a pump and a suction device. The pump side is on the left, the suction side is on the right. So your blood pours out from your left side and it goes back in on the right side. So there's a slight asymmetry in your body between left and right. One side tends to go out, the other side tends to come in. It's slight, it mixes up all in the middle. So one sampling idea is that I'm taking a sample of blood from you, and it's just one example. The second question is, as you were saying, it's a question of time. So you can average over time. Now if you average over time, this is a little easier. You can say I'm going to do this maybe before eating, after eating, a little after eating. So for those of you who have blood pressure tests, for example, blood sugar tests, once they ask you to do it, fasting. And then they ask you to do it some 2 hours after eating. Do they tell you what to eat? Sometimes with glucose. Okay. Sometimes they don't. They sort of say that based on what you naturally eat, let me figure out what you are processing. They expect you to eat a typical meal and not go and eat, large amounts of KFC if that is not what you normally eat. Just eat what you normally eat. If you're vegetarian, eat normal vegetarian, eat normal food and then figure it out. Let's see how good your body is at trying it out. So it's saying, do a normal thing and I'll take another normal sample. Then one of you said something very interesting. They average things out. Now what does averaging do?
Neutralize.
That's an interesting word to use. Neutralizes things.
Provide a general idea. Provide context.
Provide context? Context of what? Context, that's a good point. So what is the doctor trying to do? So let's simplify things a little bit and say that let's suppose that the doctor has a threshold. Let's give it a number. Let's say the doctor says that if your blood sugar is above 140, I'm going to do something. If your blood sugar is say less than 140, I'm not going to do anything. I don't know whether this is the right number or not, but just let's make it up. Now the doctor is going to see from you a number. It may be a single reading, it may be an average, it may be a number of things. How is the doctor going to translate what they see from you and compare it to the 140? How is that comparison going to be made?
Maximum number of people.
Normalizing the value.
Maximum.
So let's suppose I have just one reading. So let's suppose that I have one reading and that reading, I don't know, is 135. I've just got one reading from you, 135. What does that tell me?
Standard, how much it is made?
No test required. One argument is, it's simple. Let's take a very machine learning computer science view to this. 135 is less than 140. So now he's saying, yeah, but you know what? Let's say that 135 and another guy who say 120, there should be something that says that this 135 is a little bit more trouble than 120. Closer to the threshold, as he says. So maybe in other words, this threshold isn't quite as simple as I thought it was. So I can solve this problem in one of two ways. One way to do this is to make this 140 a little range. This is sometimes called fuzzy logic. Right? In other words, the question you're asking becomes fuzzy, not as crisp. You're not fiddling with the data, you're fiddling with the boundary, you're fiddling with the standard. The other way to do that is to create a little uncertainty or create a little plus minus around the reading itself, around 135. Saying that if this is 135, and let's suppose that I go and get another reading, and the second reading that I get is say 130, and the third reading that I get on the day after that is say 132. And I'll say, okay, seems to be fine, I might say. But let's suppose after 135, the guy goes and I do my usual thing, and I measure it again. And this time, it comes out as 157. And I do it again, and it comes out as 128. And I do it again, it comes out to be 152. So, in both cases 135 was probably a good number, but in one case 135 was varying very little, and in the other cases 135 was varying a lot. Which gives me different ideas as to how to process it. So what descriptive analytics talks about, essentially, is trying to understand certain things about data that helps me get to conclusions of this kind a little more rigorously. Now, to be able to quantify what these plus minuses are is going to take us a little bit of time, and we will not get there this residency. We'll get there next residency. To say that in order to say it's not 135 but 135 plus minus something, that question now needs to be answered. But to do that, I need to have two particular instruments at my disposal. One instrument that I need to have at my disposal is to be able to know what to measure. I need to say, what does an error mean? I need a statement that says that maybe I'm 95% confident that something is happening. I'm 95% sure that this is below 140. I need a way to express it, and that is the language of probability. So, what we will do tomorrow is we'll introduce a little bit of the language of probability. It will be sort of unrelated to what we're doing today, so there's going to be a little bit of a disconnect. But what we're going to do is we're going to create two sets of instruments. One instrument that is purely descriptive in nature, and one set of instruments which is purely mathematical in nature, so that I can put a mathematical statement on top of a description. And the reason I need to do that is because the pure description is not helping me solve the problem that I've set. So therefore, what will happen is, you will see in certain medical tests, you will not see points like this, you will see intervals. Your number should be between this and this. Your cholesterol number, your HDL, whatever, should be between this and this. You won't see a number, you will see a range that typifies a variation. And in certain cases, you will see thresholds, and maybe it's just a lower limit or an upper limit, but you'll also see a recommendation that says, please do this again. In other words, I'm going to compare, I can't compare one number to one number. One number to one number is typically a very bad place for any kind of analyst to be in, because you've got no idea of which is error prone and where the error is. So therefore, what happens is you try to improve one of those numbers. And so either by fiddling around with the range or by getting more measurements. And you'll do that, and you'll see that as we go along a little later. So this is a context for what we have. In terms of data, let's see. So this is a set of files that has been loaded. It's a very standard set of files. It's not mine, to be honest. I just want to make sure that I'm doing what I'm supposed to be doing. So for reasons that are more to do with security, my understanding, the notebook will not access your drives. So keep it on your desktop and not complicate life. So, and there is this notebook. It's called Cardio Goodness of Good. The word statistics refers to the idea that this comes from the statistical way of thinking. which, as I said, opposed to the machine learning way of thinking, tends to be a little more problem first, data next, which means we worry about things like hypothesis and populations and sampling and questions like that. And the descriptive part refers to the fact that it is not doing any inference, it is not predicting anything, it's not prescribing anything, it is simply telling you what is there with respect to certain questions that you might possibly ask of it. Now, what is the context to the case? The market research team at a company is assigned the task to identify the profile of the typical customer for each treadmill product offered by the company. The market research team decides to investigate whether there are differences across product lines with respect to customer characteristics. Exactly what you guys were suggesting that I should do with respect to the watch. Understand who does what. Entirely logical. The team decides to collect data on individuals who purchase a treadmill at a particular store during the past 3 months. Like watches, they're now looking at data for treadmills. And that is in the file, in the CSV file. So what you should have is, you should have a CSV file in the same directory, and through the magic of Python you don't have to worry about things like path. Before we get there, remember, because we're looking at this statistically, before we get the data we should have a rough idea as to what we're trying to do, and so they say that here are the kinds of data that we are looking at. The kinds of products, the gender, the age in years, education years, relationship status, annual household income, average number of times a customer plans to use a treadmill each week, average number a customer expects to run walk each week, on a self-rated fitness scale on 1 to 5, where 1 is in poor shape and 5 is in excellent shape. Some of this is data, some of this is opinion. Some of this is opinion masquerading as data. Like for example, number of times a customer plans to use a treadmill. Hopeful, wishful thinking. It's still data. You're asking someone, how many times will you use it? Her rows, daily, no problem, 7 times a week. Oh, we'll see. But it's still data. It's come from somewhere. So what has happened, the way to think about this is to say that I want to understand a certain something. And the certain something has to do with the characteristics of customer characteristics. And to do this, you can then use you can either take, let's say, a marketing point of view, who buys. You can also take a product engineering kind of view, what sells, in other words, what kind of product should I make, etc. In business, as you probably know, for those of you aren't, any of you entrepreneurs? One hand up. One hand up. They're closet entrepreneurs from what I could figure out. Right. Sometimes it's unclear what that word means. In other words, you think you are, or you're not confident enough to call yourself one, or you're doing that. In IT space, if you're an entrepreneur, for example, in physical product space or even in software space, one of the things you often think about is what's called the product market fit, which is you're making something. How do you match between what you can make and what people will buy? Because if you make something that people do not buy, that doesn't make any sense. On the other hand, if you identify what people buy and you can't make it, that also doesn't make too much sense. So the conclusions that we will draw on this, we will not draw on today. But the purpose is to be able to go towards conclusions of that kind. Either isolate products, isolate customers, and try and figure out what they tell us. Pandas generally has a fair amount of statistics built into it. That's what it was originally built for. Numpy is something that was built more for mathematical problems than anything else. So some of the mathematical algorithms that are needed are there. There are other stat plots in Matplotlib or Seaborn and many other things that you've seen already. Python is still figuring out how to arrange these libraries well enough. Shall we say, the programming bias sometimes shows through in the libraries. So I, for one, do not remotely know this well enough to know what to import up front. But a good session, you know what to import up front and you do all this up front. So you don't get stuck with what you want to do. The naming is up to you. If you like the names as they are, then that's fine. If you want a standard set of names. So when you wrote the data set, if this is in the right path, just this will work. .csv. It's usually smart enough to convert Excel forms into CSV. In other words, if you have this as XLS and things like that, it's usually smart enough, but if it isn't, then just go in and save an XLS file as a CSV file and operate that way, in case it doesn't do it on its own. But more often than not, what you see is that when Jupyter sees it, it will see any XLS file as a CSV file, or go and make the change yourself. Or you can have other XLS, other restatements in it as well. You can change functions inside it and you can figure out how much to head. What this tells you is there's the head and the tail of the data. This is simply to give you a visualization of what the data is. This gives a sense of what variables are available to it, what kinds of variables they are. We'll see a little bit of a summary after this, etc. So for example, some of these are numbers. Income. What is income? Income is annual household income. That's a number. Some, for example, let's say gender, male, female, this is a categorical variable. This is not entered as a number. It's entered as a text field. If you are in Excel, for example, right at the top, if you go in and you see that, it will tell you how many distinct entries there are, how many distinct settings there are. So usually what happens right at the beginning, and a data frame like this, if it is created, this is a data frame. If a data frame is created, when it gets created, the software knows as to whether it is talking about a number or whether it is talking about categories. There are certain challenges to that. You can see one particular challenge to this. What does this 180 mean? Counts. Why do you think there are so many decimal places that comes here? 14 years of experience, 16 years of experience. Why is it going 0, 0, 0, 0, 0, 0?
No, that's because mean, median, and next.
By default,
Yes, it does this because it sees other numbers where those decimal places are needed. So what it does is, what any software typically does is, when it sees data, it sort of says that at what granularity do I need to store the data. Sometimes this is driven by your computer, your 64-bit, your 32-bit and things like that. But what it does is, it means that the data is stored in the data frame to certain digits. Now, usually you don't see that, you'll see it in this way. But sometimes, for example, when you say include equal to or and you ask for a full description, the data comes out in this slightly irritating way. Because of something here, because of, let's say, the income field or any of that. Now, when it looks at the descriptions of this, what is the description that it is reporting and how does it choose to report out the description? In this particular situation, so let's take a little bit of a closer look at this. One thing here, look at the way it's done here. So count, unique, top, frequency, and then there are certain things here, mean, standard deviation, minimum, 25%, 50%, 75% and max. When it sees a variable like gender, it reports out lots and lots of NANs. What does that tell you right off the bat? It can't do that, which means it's not a number. This is not a number. In other words, if you ask me to find the mean of something and you're giving me male and female as inputs, I don't know what to do. Which is an entirely reasonable stand to take for any reasonable algorithm, right? It requires another kind of description for it to work. But the problem with describe this syntax is that it's asking for the same description for all of them, whether it's in significant digits, whether it's in columns, etc., etc. So it's chosen this description and it says that that's all that I'm going to give you. where it makes sense, let's say for example I look at age. Now for age I've got 180 observations and it is calculating certain descriptions for it. Correct? So what are the descriptions it is calculating? Let's look at these. It's calculating a description like say minimum. Minimum is what? 18. Maximum is 50. These are easy to understand. Then let's look at something a little interesting. Suppose I want to report one number, one representative age for this data set. This is like asking the question, how do I get a representative blood sugar number for you? I can give you a minimum and a maximum, but to do the minimum and the maximum I need to draw blood many times from you. But let's suppose I want one representative age for you. Somebody asks you, what is your blood sugar? You want to give them one number. Similarly, somebody is looking at this data and asks the question, give me a representative age. How old is your typical user, or what age do you want to build it for? Or you're even asking, let's say, a product question. You're a product designer, and a product designer building a treadmill. Now, how do you design a product? Those of you who are engineers, based on the weight. Now, very good. What weight? Whose weight? Who's the user? What is the weight of the user? He's got a good point. As a design engineer, I need to know what weight will be on that treadmill. Now, what is the answer to that question? Max?
Users who visit the gym.
So there's a question of saying that if I want to measure a variable by one number, how should I even frame that question? What makes sense? What is a one average? No? Max? In this particular case, you might argue the max is the right number, because I want to be able to say, if I can support him, I can support anyone. But there's also a downside to that. I've now engineered that product. You could argue that I have, shall I say, over-engineered that product. Correct? I'm sorry?
Factor of safety.
A factor of safety? Okay. Alright. So let's suppose that you are doing this for a mattress. You all sleep on mattresses. We're all relatively wealthy based on the fact that we're here. So we probably sleep on a mattress. Not everyone's fortunate enough to sleep on a mattress, but let's suppose you do sleep on a mattress. How much weight should that mattress be designed to bear? If you over-engineer it, what will happen is that number one, for a reasonable weight, let's say weight a lot below that mattress is not going to sink. Let's say that you design it for 100 kilos. Now if you're 50 kilos or 60 kilos, that mattress is not going to sink for you. Because it's going to feel comfortable for someone who is 100 kilos. And for someone who's 50 kilos, you're just going to bounce on it. You're not going to feel its soft silkiness or whatever it is you want to feel from the mattress. It won't work. So what to do? So that's a hard problem. It's a description, but it's a hard problem. Who do I engineer it for? And so therefore, people have different ranges of what I mean to represent it. So here's one version of it. This is what is called a 5-point summary. I report out the minimum, the 25% point, the 50% point, the 75% point, and the maximum. Variable by variable, I report 5 numbers. I report the lowest. What does 25% mean? 25% of my data set or the people are younger than 24. The youngest is 18. 25% or a quarter of them are between 18 and 24. A quarter are between 24 and 26. A quarter are between 26 and 33. And a quarter are between 33 and 50. This is what is known as a distribution. This is what is known as a distribution. And statisticians love distributions. They capture the variability in the data and they do all kinds of things with it. So I'm going to draw a typical shape of a distribution. We'll make more sense of it later on. This is a theoretical distribution. A distribution, for example, let's say has a minimum, has a maximum, has say a 25% point, has a 50% point, it has a 75%. In terms of probabilities, there's 25% here, 25% here, 25% here, 25% here. If you want to think in terms of pure description, this is not a probability, it's just a proportion. If you want to think in terms of probabilities, what this means is that out of 180 people, if I draw one person at random, there's a 25% chance that that person's weight is going to be below 24. Sorry, age 24, correct. If you want to think in terms of probabilities, we'll do that tomorrow. But this is a description. So what this description does is it gives you an idea as to what value to use in which situation. So for example, you could say that I'm going to use 26 as my representative age. If I do that, what is the logic I'm using? This 25%, this 50% point, so to speak, this is called the median. This is called the median, and we'll see it. Median means the age of the average person. First sort, take the middle person and ask, how old are you? The age of the average person. I could also ask for the average age of the person, which is what? Which is the mean, which is 1 over n x1 plus xn. Now this is algebra. What you have to do is you have to put n equal to 180. This is the first age, the second age, the third age up to 180. 1 by 180, age 1 plus age 180. This is called the mean. This value is what? 28.79. The average age is about 28 years or 28 and a half years, 28.8 years. But the age of the average person is 26. Yes?
So could you please repeat the median and the mean?
The difference between the two?
You described what is the age of the person.
So I described the median as the age of the average person, and I described the mean as the average age of a person. Now he's looking at me like saying, you have to be kidding me, right? That's confusing. I admit to it. The easy way to understand it could be this. What is the mean? Add them all up, divide by how many there are. What is the median? Sort them from the smallest to the largest, pick off the middle. If they're an even number, what do? You take the average of the two middle ones. If they're the same, it'll be the same number. If they're not, it'll be a number between them. So sometimes the median may show up with a 0.5 or something like that for that reason. If there is an integer counts, but there are an even number of counts. Now, which do you think is better?
Depends on the problem.
You're giving the right answer. It depends. You'll figure out that I like that answer. They both make sense. They both make sense. It depends on what context you're going to use it for. In certain cases, yes.
You said that median is basically the mean of the.
It's the age of the average person. It's a reading from the average person.
So what is the parameter we are saying? It is the average person. How we are getting that average?
Okay. So if you're talking in terms of parameters, so he used an interesting term. He's saying, what is the parameter I'm after? Parameter is an interesting word. Parameter refers to something what generally in a population, it's an unknown thing. that I'm trying to get after. For example, blood sugar is a parameter. It exists, but I don't know it. I'm trying to get my handle on it. Correct? So if I'm thinking in terms of parameters, then these are different parameters. So let's look at a distribution here. I'm not sure whether this will pick up things. I hope so. So the median is a parameter such that on this side I have 50% and on this side I have 50%. This is the median. The mean is what is called the first moment. What that means is, think of this as a plate of metal and I want to balance it on something. Where do I put my finger so that it balances? It is the CG of the data, the center of gravity of the data. You can understand the difference between these two now. If, for example, I push the data out to the right, what happens to the median? Nothing happens to the median because the 50-50 split remains the same. But if I push the data out to the right, the mean will change. It will move to the right. Your lever, the lever principle, right? If there's more weight on one side, I have to move my finger in order to counterbalance that weight. So these are two different parameters. If the distribution, for example, is what is called symmetric, symmetric means it looks the same on the left as on the right, then these two will equal. Because the idea of going half to the left and half to the right will be the same as the idea of where do I balance, because the left is equal to the right. So when the mean is not equal to the median, that's a signal that the left is not equal to the right. And when the mean is a little more than the median, it says that there is some data that has been pushed to the right. And that should be something that you can guess here, because the mean and the median to some extent are what? 24, 26, etc. The lowest is 18. That's about 6 years, 8 years less than that. But what is the maximum? 50. That's 25 years beyond. The data is pushed to the right a little bit. Instead of saying pushed to the right technical term is right skewed. There are, shall I say, people are more not average on the older side than on the younger side. There was a hand up somewhere. Yes.
I was just confused with the statement that median would not move, but then you explained it.
Yes. So therefore, one reason that the median often doesn't move is because it is not that sensitive to outliers. So let's suppose, for example, we look at us and we ask ourselves, what is our mean income or our median income? And we have that. Each of us make a certain amount of money, we can sort that up and put that in. Now let's suppose that Mr. Mukesh Ambani walks into the room. Now what is going to happen to these numbers? Mean is going to go up, right? He alone probably makes a very large multiple of all our incomes put together. Possibly. I don't know how much you make. I know how much I make. But what's going to happen to the median? It's going to stay almost the same. The typical person may move by at most half. Because what is a typical person going to be? The typical person is going to be an actual individual in the room, or maybe an average of 2 individuals in the room. And that person is not going to change. Yes. Yes. That's one conclusion we can draw on this. There are other plots below which will also show the same thing. You're not being able to draw that conclusion. Well, good logical reason. I haven't shown you the full data. We'll see the histogram, we'll do that. So hold on to that question. The conclusion was drawn is that there are two things to do. See here. One is, if I simply look at this without seeing any more graphics, where is the middle of the data from a median perspective? At 26? Correct? Now from 26, look at the difference between 26 and the smallest. 18. Between 18 and 26, that's 8 years. This 8 years contains 90 observations because there's 180 total. Now, what is on the opposite side of this? 26 to 50. That's how many years?
24.
24 years. This 24 years now contains how many observations? Same 90. So there are 90 observations that are between 18 and 26. and there are 90 observations between 26 and 50. So if I were to draw a picture, what would that picture look like? Yes, exactly as you're drawing it, right?
What we can say is skewed on the left hand side or right?
This usually by definition is called right skewed. This is a problem that BABI has. Does this mean it's left skewed or right skewed? As a word, right, it's called right skewed. More data to the right. Sorry, more data is a dangerous word. No, it's the same number of observations. I'll say the data is pushed to the right.
More variation on the right side.
More variation on the right side is probably a safer way of putting it, yes. So skewness is often measured in various things. One measure of skewness is typically, for example, mean minus median. Mean minus median, if it is positive, it usually corresponds to right skewness. Mean minus median negative usually corresponds to left skewness. This is a statistical rule, but sometimes it is used as a definition for skewness. There are many definitions for skewness. Skewed data sometimes causes difficulties in analysis because what happens is the idea of variation changes. Being variation on one side means something a little different than variation from the other side. By the way, what's happening to you with respect to things like books? Are you getting books? Are you not getting books? You have no idea what the books are? You got one book, which is what? Which is the statistics book? Okay, I'll take a look at that book later. So, this book, right? Okay, show me the book. Okay. Comment 1, very nice book. Comment 2, not a Python book. Right? That doesn't make it a bad book. So if you're looking for help on how to code things up, this is not the right book. Get a book like Think Stats or something like that. But if you want to understand the statistics side to it, it's an excellent book. So everything that I'm talking about is going to be here. I might talk about which chapters and things like that at some point. And I might talk about how to use this in the book. So for example, at the back of this book, there are tables. There are tables at the back of this book, which we'll learn how to use. And then I'll try to convince you that you shouldn't use them. But remember, many of these methods are done in ways in which either you don't have access to computers, or if you do have access to computers, you don't have them, shall we say, at runtime. In other words, when I want to run the application on it, I can build a model using a computer, but I can't run it within one. The runtime environment for statistics is often done when there are no computers around. The build environment can include computers, but the runtime environment cannot. A lot of statistics is done under that kind of situation.
Even probability is also covered here?
Yes, very much so. Very much so. Okay, so definitions of skewness and things like that. Do it in the way you usually use a book, which means you go to the index and see if the word is there. And then you go back and figure it out, and it will give you some ideas as to how that works. It's a nice book. It's one of the best books that you have in business statistics, but it's not necessarily a book that will tell you how to code things up. That is not a deficiency of the book. Not every book can do things of that sort. There are other books around that will tell you how to code things up, but will not explain what you are doing. It's important to know what you are doing. It's also important to know why you're doing it. But books can't be written with often everything in mind. Yes?
Can you suggest some book which tell us how we can think that way?
The thinking is here. I think this is good for thinking. I would absolutely recommend this book on the thinking side.
Because the problem lies that in which situation what we need to apply.
Yes, and that answer I think is very, very good here. Where you won't get is it will say do this, and it won't give you the Python syntax to do it. That will not be here. So if you can solve that problem through some other means. I used to have a colleague in corporate life who had a very big sticker on his board. It said, Google search is not research. Right? Now nobody agrees with him anymore. So I suppose that when in doubt, you do what normal Homo sapiens do today, which is you Google for an answer. So one possibility is that you understand something from a book such as this, and if you want to understand the syntax, just Google for the term. Say Python, that term, whatever, it will probably give you the code. Things are very well organized these days. There's also the question, and I should give you a very slight warning here, not to discourage you from anything. But in the next 9 months or thereabouts, the duration of your program, there's going to be a fair amount of material that will be thrown at you. Correct? The look and feel will sometimes be like what we would often call at MIT as drinking from a fire hose. You can if you want to, but you will get very wet. So therefore, pick your battle. If you want to understand the statistics side of it, please go into the depth of it. But if you try to get into equal depth on every topic that you want to learn, that will take up a lot of your professional time. Now the reason we do the statistics part first, one, it's a little easier from a computational perspective, although harder from a conceptual perspective. So we begin it this way. But hold on to that idea, and then as you keep going, see if this is something that you want to learn more on. And if you can, you're welcome. Just write to us or let us know, or let anyone know that Hoita's just come in, let her know, and we'll get the references to you. But if you want to, say for the first 2 residencies, please read the book and see what happens. If there are doubts, yes, but it's a well-written book. Its instructor is one of our colleagues here. If you want, we can also help explain things. So, alright, so this is the summary. What did the summary tell you? This summary gave you what's called the 5 numbers that help you describe the data. Minimum, 25, 50, 75, max. We'll see another graphical description of this. It also described for you a mean. There is also another number here. And this number is indicated by the letters STD. STD refers to standard deviation. STD refers to standard deviation. And what is the formula for a standard deviation? STD is equal to the square root of little bit of a mess, but 2 steps. Step 1, calculate the average. Step 2, take the distance from the average for every observation. Ask the question, how far is every data point from the middle? If it is very far from the middle, say that the deviation is more. If it is not far from the middle, say that the deviation is less. Deviation being used as a synonym for variation. I'm talking about variation. Variation can be more or variation can be less. More than the average, less than the average. If someone is much older than average, there's variation. If someone is much younger than average, there is variation. So therefore, both of these are variation. So what I do is, when I take the difference from the average, I square it. So more than x bar becomes positive, less than x bar also becomes positive. Then I add it up and I average it. There's a small question as to why it is n minus 1, and that is because I'm taking a difference from an observation that is already taken from the data. Now I have squared. When I have squared, my original unit was in age. When I have squared, this has become age squared. So I take the square root in order to get my measure back into the scale of years. So the standard deviation is a measure of how spread a typical observation is from the average. It is a standard deviation, where a deviation is how far from the average you are. And because of this squaring, you need to work with a square root. In sort of modern machine learning, people sometimes use something called a mean absolute deviation, MAD, very optimistically called. So what MAD is you don't take a square, you take an absolute value. And then you do not have a square root outside it. And that is sometimes used as a measure of how much variability there is.
So why it is squared then?
Why is it?
Why we do it just?
We square it because we want to look at both positive and negative deviations. If I didn't square it, what would happen is it would cancel out. What was the word that one of you used? Neutralize, right? I love that term. Your positive deviations would neutralize your negative deviations.
So I went to this x minus x bar is there.
Yes.
So it should be like x square minus x square. And if you are seeing the positive and the negative.
This number is going to be positive if say x1. So let's look at the first number here. So if I look at the head command here, when I did the head command here, what did the head command give me? The first few observations. So now this is an 18-year-old. This is probably sorted by age. This is an 18-year-old, correct? Now I'm trying to explain the variability of this data with respect to this 18-year-old. Why is there variation? This 18 number is not the same as 28. And 18 is less than 28. So what I want to do is I want to go 18 minus 28.7. What I'm interested in is this 10. This 10-year difference between the two. Now the oldest person in this data set is how old? 50. When I get to that row, this 50 will also differ from this 28 by 22 years. So I'm interested in that 10 and I'm interested in the 22. I'm not interested in a minus 10 or a minus 22. I can do that. I can do that. In other words, what I can do is I can represent 18 minus 28 as 10 and I can represent 28 minus 50 as 22. And that is this. As I said, 1 over n minus 1, absolute x1 minus x bar plus absolute xn minus x bar. That is this. With n minus 1. And this is done, as I'm saying. This is what is called mean absolute deviation. And many machine learning algorithms use this. You are correct. In today's world, this is simpler. Now, when standard deviations came up first, this was actually a little harder. But people did argue about this. I think, well, 150, maybe more about, I forget my history that much. There were two famous mathematicians, one named Gauss and one named Laplace, who argued as to whether to use this or whether to use this. Laplace said you should use this, and Gauss said you should use. Now the reason Gauss won was simply because Gauss found it easier to do calculations. Why is this easier to calculate with? Because Newton had come up with calculus a century or so before that. And so, for example, let's suppose that you want to minimize variability, which is something that we often need to do in analytics. Which means you need to minimize things with standard deviation, which means you need to differentiate. This function, the square function is differentiable, you can minimize it using calculus. This is not. So therefore what happened was, Gauss could do calculations, but Laplace could not, and Laplace lost. And Gauss won the definition of the standard deviation.
We haven't much used 25% or 75, so
okay. Why do we not do that? So, today, this entire argument makes no sense. Because today, how do we minimize anything? Our computer program. You don't use any calculus. You run fmin or something of that sort. You basically run a program to do it. So therefore, this argument that you can both do calculations equally well with this as in that. So today, what is happening is that Laplace's way of thinking is being used more and more. This one is a lot less sensitive to outliers. This one, what it does is, if it is far away, the 22 squares to 484 or something like that, which is a large number. So the standard deviation is often driven by very large deviances. Larger the deviance, the more it blows up. And so therefore, this is often very criticized. If you read, for example, the finance literature, there's a guy called Taleb, Nassim Taleb, he writes this book called The Black Swan and Fooled by Randomness, where he left and right criticizes the standard deviation as a measure of anything. So today this argument doesn't make a great deal of sense, and when in practice something like this makes sense, it's often used. So a lot of this is done historically. It looks this way because of a certain historical definition, and then it's hard to change. So today in centuries after Gauss, sad people like me are trying to explain it and having trouble doing it because there's a logic to it, right? I mean, and that logic doesn't hold at all anymore now. Yes?
Standard deviation in simple terms is that 18. How far generally is that from the median?
How far on the average is an observation from the average? Confusing statement again. He's again going to be unhappy. But how far on the average is an observation from the average? If that answer is 0, that means everything is at the average. But you're asking the question, how far from the average is an observation on the average? If I take your blood pressure, how far from your average blood pressure is this reading? If this is exactly equal, then I don't need to worry about variability. Every time I measure blood pressure, I'll see the same thing. What is your average bank balance? Don't tell me that, but you know what I mean, right? You have an average bank balance. Your bank account manager or your bank actually tracks this, what your average bank balance is. But you're not actually, your balance is almost never or very, very rarely equal to your actual average bank balance. It's more and it's less. How much more, how much less is something that the bank is also interested in order to try and figure out, how much of your money, so to speak, to get out there. Because the bank is going to make money by lending it out, correct? But when it lends it out, it can't give it to you. So it makes an assessment as to how much money, I don't want to get into finance now, but you get the drift. So therefore, it is a measure of that. It is not the only measure of that. So for example, here's another measure. So you remember this 25 number and the 75 number that you're asking about? Let's say that I calculate a number that looks like this. Let's say 33 minus, let's say 33 is a 75% point, minus 24. So 33 minus 24, let's say this is my 24 and this is my 33. Between this, how much data lies? 50%. Why? Because this is 25% and this is 25%. This now contains 50%. This is sometimes called the interquartile range. Interquartile range. Big word. Right? Now, why is it called an interquartile range? The reason is because sometimes this is called Q3 and this is called Q1. Q3 stands for upper quartile. You can understand quartile, quarter. So upper quarter, and this is the lower quartile. And the difference between the upper quartile and the lower quartile is sometimes called the interquartile. Why is it called the range? Because what is the actual range of the data? The range of the data in this particular case is 50 minus 18. And 50 minus 18, which is your max minus your min, this is sometimes simply called the range. Range is maximum minus minimum. Interquartile range is upper quartile minus lower quartile. And these measures are used. They do see certain uses based on certain applications. You can see certain advantages to this. For example, let's suppose that I calculate my 5-point summary. With my 5-point summary, I can now give you a measure of location, which is my median, and I can give you 2 measures of dispersion, which is my interquartile range and my range. So those 5 numbers have now been twisted to give me a summary number, which is the median, and a range number. Interestingly, I can also draw mental conclusions from that. For example, I can draw conclusions from these 5 numbers in the following way. 24 and 33. Half my customers are between 22 and 24 and 33. So if I want to deal with half my customers, I need to be able to deal with a range of about 9 years. Within this 9 years is all that I'm interested to get this right. So if I'm building my machine, I'm going to make sure, let's say, that the 33-year-old is okay with this and the 24-year-old is okay with this. Will the 50-year-old be okay with this? No, may not be. But if I want to make the 50-year-old okay with this, I'll have trouble with the 18-year-old. So I can do a lot with even these 5 numbers. We'll see more descriptive statistics as we go along. By the way, this is only for age. I can do this for usage, I can do this for fitness, I can do this for income, I can do this for miles. Income is interesting. Here's the median income, $50,000, and the mean income about $53,000. If you see income, in almost all real cases, the mean income is going to be more than the median income. The per capita income of India is more than the income of the typical Indian. Say, what does this command do? If I say mydata.info, what this is doing is, my data first of all is a data frame that I created. Just to review, I read the PDF file this way. Now this is a describe, and this here is info. Now describe and info in the English language are similar things, description and information. This is interpreted in the software as 2 completely different things. Information is like your variable setting. It's like your integer field, your real field is setting like that. It's giving you information on the data as data. The word data means different things to different people. To a statistician, data means what? To a statistician, data means a number. To an IT professional, what does data mean? Bytes, information. I've lost my data. I don't particularly care what the data is. I've lost my data. So this is that information. It tells you about the data. It's an object. This is description. It's a 64-bit stored integer. It's an object. So it tells you about numeric, categorical. It tells you about the kind of data that's available. Non-null fields. In other words, there are objects in the field, etc. There are so many integer types which are stored at 64 because this computer is probably capable at 64. And there are 3 categorical variables. This is, shall we say, a data object summary of what is there in that data frame, not a statistical summary. Useful in its own way, particularly if you are processing it and storing it. For those of you who are going to go into data sort of curation-like careers, this kind of a database is a nightmare. Because typically what happens is, when you store real data, in addition to data, you often store what's called a data dictionary. Sometimes that's referred to as metadata, data about the data. Because simply storing a bunch of numbers is not enough. You have to say what the numbers are about. This adds a layer of complexity to the metadata. You now have to store not only what the variable is about, but what kind of a variable it is. So many professional organizations say is that archival data should never be a mixture of both numerical and categorical objects. And they pay a price for that. Numerical things should become categorical or categorical things become numerical. But what happens is, if you are storing large volumes of it and archiving it and making it available for people who have not seen it before, it sometimes gets convenient. So therefore fields like this are often useful to see how big a problem you have. Right? Now I want to plot a few things. To plot, you can plot anything. Simon, I think, is coming a little later. But this plot, this is from Matplotlib library, and it is plotting through a command called hist. Hist means histogram, which you've already seen. You've covered histograms, right? I think you've seen histograms. So this is a histogram. Now histogram as a syntax has bin sizes and figure sizes. So what you can do is you can play around with these and see the differences in what this histogram does. But there's a certain default that shows up, and that default is quite good. And here is a histogram distribution of the age. This is not a set of numbers, this is a picture. This is a picture. What does this picture have? This picture has a set of bins and it has a set of counts within each bins. Between these two numbers, between say 10 and whatever this is, let's say 22 or thereabouts, I have a count of, let's say 17. So it gives a count, and it does this by getting a sense of how many bins there are and plotting this shape. It's a little bit of an art to write a histogram program. There's a Python book out there, I think ThinkStat one of it, in which sort of the first 1/3 of the book is basically how to write a histogram code. It's a wonderful book, but because it treats this example, it got terrible reviews. Reviewers said, why do I want to learn how to code a histogram? And the book's author is, I'm teaching you how to write a code. A histogram is an example of how to do that. And I tend to agree. If you want to test yourself of your understanding of data and your understanding of any programming language and any visualization language, code a histogram in it. And have fun. So it's a nice challenge from many perspectives. The data challenge, the language challenge, the visualization challenge, all of that. Yes?
So you said archival data should not be numerical plus category.
Many companies do that. That they want archival data to be of only one data form, only one format. Why is that so? Because, as I said, when you store data, how do you store it? Let's say that you've generated an analysis. The analysis is done, correct? And you've decided not to destroy the data. You're going to keep the data in your company's databases or in your own database. How will you keep it? You can take a technology. Let's pick an example. Let's say pick an example. SQL, Excel, whatever. Let's say Excel. Let's say I keep it in Excel. Now, if I keep it in Excel, what will I now do? So let's say I have an Excel spreadsheet. Let's say my cardio data set. Let's say this data set. Now, in addition to the data, what do I need to store with it?
Metadata.
Yes, metadata. How do I store that metadata? Yes, so one possibility is I can have a text file like that, like I had at the top of this, describing all of this, which is typically what happens in Excel storage. It describes this and it describes, there's one file called .dat and another file called .disc or something of that sort, which basically describes the variables, and the idea is that they have the same name, and one extension gives you the data, the other extension gives you the description of the variables that are in this data. Correct? Now this is good. Now what's going to happen? On that data, certain code has been run. That code is going to assume certain things about the data. What do you want that code to assume about that data? Whatever you want that code to assume about that data should be available in the data dictionary. Now, if that code is stable enough to realize that whatever fields you give me, I will run on, that's cool. But if that code requires you to know what kind of data is being used, let's say discrete data, let's say continuous data, in the future you'll be doing things like linear regression, logistic regression. Linear regression will make sense if the variable is a number. Logistic regression will make sense if the variable is a 0 or a 1. If you have that problem, now in the metadata you need to be able to tell not only what business information this variable contains, but also what kind of a computational object it is, so the code can run. So therefore what people often say is that I'm going to make it very simple and I'm going to assume that my entire data frame consists of only one kind of variable, so that when I run any algorithm on it, I know exactly what kind of data input that algorithm is going to get. But I'm saying it's a practical answer that many companies often have. And I've worked in a couple of companies, at least one company where this was very seriously done. So we had to when we put data back in, we had to convert it. And in the situation that I was in, it wanted everything in categories. So what we would do is we'd take continuous data and we would do what's called fine classing, which means that we would divide not into 4 pieces but into 10 pieces. Decile 1, decile 2, decile 3, decile 4 up to decile 1. And every variable was stored now not in its original numbers but as 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So let's suppose that I tell his income is 9. What that means is I know he's in the 9th decile. 10% of the people or more have income more than him 80% have less than him. He's in that bracket. And all variables were stored that way. Now what happens is every algorithm knows that every variable is going to be stored that way. And you can keep writing algorithms that way. Otherwise, what would have to happen is every algorithm would need to be differently. And let's say you're doing credit scoring. Let's say you're doing CRM models. You're doing something of this sort. And you've built a very sophisticated CRM model that tracks your customers. And it works. Now suddenly you've got a new variable coming in, the Twitter feed. And suddenly nothing works. What to do? Go back and rebuild that entire model. That's going to set you back 3-4 months. That's going to set you back a few $1,000s. So you say, no, any variable that has to go in this form. And if it goes into this form, my algorithm can deal with it.
So, well, in such case, it might not affect the efficiency of the model that we generate?
Yes, yes. And in practice, I'm going far away from topic now. In practice, a professional analyst has to struggle between doing the right thing badly and the wrong thing well. You want to do the right thing well. But the right thing well is going to cost you time, money, data, and everything. So you struggle between saying that I'm going to get a flawed model quickly built on a new data set, or I'm going to get an inefficient answer on a model that's already been built. And let's see how far it goes. And so these are more cultural issues with how an analytical solution is often deployed in companies. They vary very much from industry to industry. They vary very much from company to company, from the culture of a company to a culture of a company. They depend on regulatory environments. In certain environments, an auditor-like entity comes in and insists on seeing your data. Show me your data. Let's say in finance, this is sometimes happening. Regulatory agency, let's say Reserve Bank of India, goes into a bank and says, show me your data. All this NPAs, etc. Show me your order book, show me your loan book. Correct? And now that has to be done, and the decisions you made have to be done in a way that is patently clear why you have done this. So very often people say, I don't want to make the best risk decision. I want to make the most obvious risk decision. Which may not be the same thing at all. But I'm being audited. So that's a practical question. And I don't have a clean answer to that. But I do know what happens. Is it right? No, it's not. But we live in a world that has that kind of imperfection. One of my teachers, his name was Jerry Friedman. You'll see some of his work later on. He came up with algorithms like projection pursuit, CART, Mars, gradient boosting. He created many of the algorithms that you'll be studying. One of my teachers at Stanford. When he ran our consulting classes, he would say this: solve the problem assuming you had an infinitely smart client and an infinitely fast computer. After you've done that, solve the real problem, where you do not have an infinitely smart client and you do not have an infinitely fast computer. This was in the early 1990s, where computer speeds were a lot slower. And we didn't have powerful machines like this around. So a lot of this is done in that kind of situation, where you are struggling for continuity, when you're figuring it out. Imagine yourself as an analytics manager, and I hope many of you will be. And you have an analytics team sitting in front of you, correct? You're looking at them and you're looking at them in the eye, and you know how much you're paying them. And you know that half of them are going to leave at the end of the year. What are you going to do with regard to the modeling and things like that? Your first order of business is going to be to ensure continuity in some form. Keep it simple, right? Keep it simple. Keep it obvious for the next bunch of people who are going to come in. And for that, you'd be willing to trade a little bit of make it right. So now the new person coming in will now not want to solve a very complicated kind of situation. This is not where you want to be, and I do not want to depress you on day one. But it's also the fun part of the profession, right? It's also what makes it interesting and exciting. Right? It's not all bad. Okay, so the histogram command summaries of what these histograms are, and each gives you a sense of what the distribution is. And as you can see from most of these pictures, most of these variables, when they do have a skew, tend to have a right skew. Maybe education has a little bit of a left skew. Maybe education has a little bit of a left skew, that a few people are educated and most people are here, but even so. Right. Now here's an interesting plot. Matplotlib has this as well, but Seaborn has a better version of it. This is what's called a box plot. You've seen a box plot? This is a box plot. People are unsure as to where this box came from, because there's a statistician called Box who's used this before, but this box came from, it used to be called a box and whisker plot. These are the whiskers. This whisker will go, this is the median, this is the upper quartile, the top edge of the box, the bottom edge of the box is the lower quartile, the end of the whisker is 1.5 times the interquartile range above the box. Right? If you want a formula. Sort of the whisker, the length of the whisker is 1.5 times IQR. Should I have a break now? A little bit maybe, huh? So we'll, okay, 3:45 or whatever, we'll go up to there at least. Yeah, I haven't stopped, I just got distracted. So 1.5 times the, so it goes up to that. If a point lies outside it, the point is shown outside it. If the data ends before it, the whisker also ends. Correct? What is the whisker? Okay, what is the whisker? Alright, let me explain another way. The whisker is the maximum, the top of the whisker is the maximum, the bottom of the whisker is the minimum. Okay? Not okay. Okay. Some of the points are outside. So, this point here, now what is this plot here? Age for males. So what this means is, this is the minimum, 18 or whatever it is, and this is the maximum, 48 or whatever it is. Minimum and the maximum. So if you see nothing else on the box plot, no other points other than just the box and the whisker, then your 5-point summary is sitting there. That's it. Right. Now, what happens if you see points like this? Outliers. What is an outlier? An outlier is a point that lies more than 1.5 times the interquartile range above the box. So this whisker will not extend indefinitely. It will go up to 1.5 times this box, and then it will stop. And if any points are still left outside it, it will show them as dots. You can treat this as a definition for what an outlier is.
Okay, what about the lower whisker?
Same thing.
1.5 times?
Same thing in the other direction. The logic is symmetric.
1.5 times from there.
No. That means this it hasn't. The data is ended here.
The data is ended.
The data is ended here.
Was there any other number tried instead of 1.5?
I suppose so, and you can change it. I won't try it now, but you can go to the box plot syntax and change that. So you can go to box plot syntax and you can change that 1.5. It's not hard coded into the algorithm. I think 95% sure. As a statistician, I'm never sure about anything. But it's a parameter in the you should be able to pass the parameter in the box plot function. Default is 1.5. You should be able to change it.
And what's the color part? That's the median, is it?
Which one?
The color.
Color? Oh no, these two colors? These two colors are because I've asked for two things. I've asked for male and female. If I had 3 of them,
That's okay, but how the range of the color? The box.
Oh, this one here. Oh, this is Q3. The lower is Q3 and the upper is lower is Q1 and the upper is Q3.
So this is the quartile range.
Quartile range. So for males, between the bottom whisker to the end of the box is a quarter of your data. The box is half your data, and the top of the box to the end of the whisker is quarter of your data.
So the middle line is
the middle line is the median. The middle line is the median. There is also a function in box plot you can play with where it will give you a dot, and that dot is the mean. I mean, you can ask box plot to do that, but a mean is not a general standard component in the 5-point summary. It's a different calculation, not a sort. But if you want to, you can make box plot to give a dot on the mean as well, by definition. Yes. So mean median. So half the data is between 24 and 34 or whatever that is. Half of all the men in my sample are between those two numbers. I think box plot doesn't allow you to change the shape of the box. I think that is set. That's sort of central to the idea of a box plot. It does allow you to fiddle with the size of the whisker, but I don't think it allows you to fiddle with the size of a box. In other words, if you change that to something else, let's say the 20% point to the 80% point, 80-20 rule, that's no longer a box plot. It's another interesting plot. The significance of it is exactly this, as we had seen before. The significance of it is that the data looks like this. It's right skewed. Think of the picture. So if this is your Q1 and this is your Q3, this is your Q2 or the median, then the median is going to be closer to Q1 than it is to Q3. In the same way that the minimum will be closer to the median than the maximum, same idea. This is a summarization for numbers. If you want to summarize for categorical data, what's called a cross tab or a cross tabulation, this is simply how many products are there. Product category 195, 498 and 798. They've got three kinds of treadmills and they're trying to understand who was using what kind of treadmill. Our business problem is to understand who was using what products. This is a cross tab. What is this? This is something that will be used for categorical variables. No box plot will make sense here. There are no numbers. So now you can ask interesting questions here if you want to, and you can think about how to answer it. Is that, for example, you can ask a question, is there a difference between the preferences of men and women? Possibly. Is there a difference in the products that irrespective of gender, is there a product that they prefer? You can ask all kinds of interesting questions and you can find ways to answer it, which we will do, not in this residency, but next time around.
For those we can categorize it also?
Categorize?
For those preferences?
So this is simply, once again, this is descriptive. All this has done is it has simply told you the data as it is. What I'm saying is that if you want to do a little more analysis on it, you now have to reach a conclusion based on it. So for example, one conclusion to ask is that do men and women have the same preferences when it comes to the fitness product they use? Now that's a question. To answer that question, it's enough to look at the data. But just looking at it will not give me the answer. I need to be able to find a statistic to figure that out. A statistic that does what? That in some way measures that difference. Let's say measures the difference between men and women, or what we will do is not measure that. What we'll do is we'll measure that if there was no difference between men and women, what should this table have looked like? And then we'll compare the difference between these counts and that table. But that's the interesting part of a statistical statistic, which we'll do. That's called a chi-square test. It's coming up in the next residency. But that's the prediction part or the inference part of this description. This is just the description. You can do a similar thing here. This, for example, is for marital status and product. What product you use. Are you not very dependent on whether you're partnered or single? What is marital product versus product? Maybe it has to do with age, or maybe they're correlated. Should you use one as opposed to the other? Okay. You can use counts as well. If you say instead of doing it this way, instead of seeing it as a table, if you want to see it as a plot, you can ask for counts. So there are things like count plots and bar plots, which allow you to do counts. In the lab, you'll do probably a few more of these. This is simply another visualization of the same thing. For those of you who like things like pivot tables in Excel, Microsoft has made, wonders of us all. In corporate life, I was told that you can have a master's in bachelor's and master's in anything. Engineering is good, etc. And it's nice if you have PhDs in a few areas. But what you really need is a PhD in PowerPoint engineering. I mean, that's a necessary qualification for success. So certain tools have been used. So therefore, those tools have been implemented in many of these softwares as well. This is the pivot table version of the same data set. This is the last not last, but still this is a plot. Let me show you this plot and then we'll end or we'll take a break. This is a plot that is a very popular plot because it is a very lazy plot. This plot requires extremely little thinking. Pair plot of a data frame, right? You don't care what the variables are. You're telling it nothing about the plots. You're simply saying, figure out a way to plot them pair by pair. And it does that. So for example, how would you read this plot? On this side, so it creates a matrix. The rows are a variable and the columns are variables. What is this? This is age versus age. Age versus age makes no sense. So what it plots there is a histogram of age. Doesn't like the gap. Nature abhors a vacuum. I suppose Python does as well. So it'll now plot what it should have plotted is age versus age. You're right, it should have been a 45-degree line. But a 45-degree line is a useless graphic, particularly if the same 45-degree line shows up in all the diagonals. So to make a more interesting graphic, it plots the histogram there. This analysis, this kind of analysis sometimes has a name associated with it. The name is univariate. Univariate means I'm looking at it variable by variable, one variable at a time. When I'm looking at age, I'm only looking at age. It's called univariate analysis. It's just a word. Uni as in uniform, same form, unicycle, cycle with one wheel, things like that. Univariate. Unit.
But for the other set of data also, will it replicate the same kind of pattern? If I'm going to give the other set of data.
Another set of data, it will replicate the same. It will replicate the same nature of the data. There will be histogram here again.
Age and education versus education, this visualization.
So yes, so what it will do is, remember that this graph, the nature of the graph. So let's see this. Right? So where is gender here? Where is gender here? Is it there? Is gender in my data? It is there. So when I did pairs plot my data, What did it do with gender? Yes. Remember in info, when we did info here, remember how it had stored the data? No, not NAN, here. So it had product, gender and marital status, it had identified as objects in the data frame when it had formed the data frame. So now what does it tell you about the command, the pair plot command? Yes, it will ignore those objects. So in answer to your question, if the data frame has been stored, has been captured with integer 64, basically integers or numerics in it, it will plot. If it's only objects, it will probably give a null plot. Yeah.
So how come age is not the
Say again, age is not?
Why it is not a linear line?
Why like that? This is the histogram, this is the same plot, this plot is the same as, which plot? This one. It's the same as this one here. No, this is not age versus age, this is just age. Age versus age would have been a 45-degree line, but it is not plotting that. It's not plotting that. In the diagonal, it is not plotting age versus age. In the diagonal, it is simply plotting age's own distribution.
With count. Age with count.
Yes, with the count. So what it is doing is, it is essentially running hist on age, on each observation, and putting it on the diagonal. Yes.
What can we infer from the histogram of like 20 to 25 bins?
20, say again?
There is a bin, right?
There is a bin.
What can we infer from that? From each bin?
From each bin, it's a count.
Count of people in that age.
It's a count of the number of people who are in that age group. Here, this is age. No, this is miles. This is age. This is age. So let's say between here, between let's say 40.5 and 43.5, or whatever these numbers are, there are 3 people. Remember, the histogram is a visual thing. You can data mine a histogram if you want to, which means you can find out what those are, and you can see it inside histogram. Just ask for a summary of that, it will give you what the features are of that histogram. But the histogram is not meant to be used that way. It's meant to be used as an optical device, to see the shape, to see the count. It's an art to do a histogram. If you change the bins a little bit, the histogram will look a little different. So I would suggest that unless you've got a lot of experience in this, or you really enjoy the programming, do not fiddle with the histogram. Its shape will change. I'll show you a little later after the break. Not change the histogram, but what shape is. No, not in default. You can go in and change it on size. But the bin width, etc., the bin width of histogram takes a little more to change. Right? So there is stuff out here. You can find other things in which you can play this. So there are ways to do it. Okay? So quickly ending, we're losing our food. So these different plots, and we'll continue after the break. The rest of it is simply an X versus Y. So for example, this is age versus education. This is age versus education.
So the second graph from the first one is just rotated.
Yes, he's right. If this is education on the y-axis and age on the x-axis, or vice versa, then these two plots, 1 and 2 and 2 and 1, are just mirror images of each other.
It's not a mirror image, it's just rotated.
You're right, depends on where you look, see where you put the mirror, but yes. Mirrors. So I remember when I was a kid, mirrors would confuse me. So I would ask a question like this, that when I see a mirror, left and right get switched. but top and bottom don't. And I never understood why. Right, you know, due to gravity? You can think, I mean, left and right gets switched, but top and bottom don't. I thought it was something to do with the mirror, and then I thought it was something to do with my eyes, you know, maybe because they left hand. So I looked at it this way, and that didn't help. So yes, it's an important point. When you do symmetry, it's a good catch. It's a good catch to realize that there aren't so many plots. There are actually only half as many plots, because the plot on this side of the histograms and the plot on the opposite side of the histograms are the same. There was another question that one of you asked, is that many of these seem to look like rows and columns. In the sense that, what are these rows? Now what does this row look, what does this mean? It means that this variable fitness actually has very few numbers in it. It has a number 1, 2, 3, 4 and 5. Now why is that? Because remember how I defined fitness is my perception of whether I was fit or not in my original definition of the variables. Here you go. Self-rated and fitness on 1 to 5 scale, where 1 is in poor shape and 5 is in excellent shape. This was the created data. So in this data set, I now have this variable in it. These kinds of variables sometimes cause difficulty in the sense that there's a word for it. These are sometimes called ordinal variables. So sometimes data is looked at sort of, you know, numerical and categorical. And categorical is sometimes called nominal and ordinal. Nominal means it's a name of a person, north, south, east and west, gender, male, female, place, etc. It's a variable. Essentially it's a name. Ordinal is, it's also categorical, but there is a sense of order. There is a sense of order. Dissatisfied, very dissatisfied. So there's an order, therefore ordinal. This variable, the fitness variable, can, if you wish, be treated as an ordinal categorical variable. So for example, the Likert scale is that, so the 7-point scale. Not satisfied, very dissatisfied, dissatisfied, moderately dissatisfied, neutral, moderately satisfied, satisfied, very satisfied. Mark 1. This generates a data from a scale of say 1 to 7 or 0 to 6. So it will show up in your database as a number. Like for example, here you can say instead of 1 to 5, very unfit, moderately unfit, okay, relatively fit, very fit. Instead of giving 1 to 5, give it that way. And you code it up this way, your choice. So sometimes when you have data that looks like this, the Python or any database will recognize it as a number because you've entered it as a number, but you analyze it as if it is a category. So the opposite problem also sometimes exists in that sometimes you get to see a categorical variable show up as a number, but you know it's a categorical variable. A zip code is an example. A zip code shows up as a number, but it's obviously not. You can't add up zip codes, right? You take two places in Bangalore and you want to find a place between them, that's not the average of the zip codes. It might be close, but you can't do arithmetic with zip codes. The other difficulty with zip codes is that there can be many of them, which means that as your data set grows, the number of zip codes also grows. So the number of values that a variable can take grows with the data. And this sometimes causes a difficulty. Because what happens is that in the statement of the definition of the variable, you now cannot state how many categories there will be present. So you know that there will be more zip codes coming, you just don't know how many more zip codes will be coming. But you also know it's a categorical variable, so you can't treat it like a number. And so there are some special types of, problems like zip codes that require special types of solutions. So the plot itself is a very computational plot. If it recognizes it as a number, it plots it. If you don't want to make it plot as a number, change it to a character. Most softwares, including Python, will allow you to do that.
whatever news we have been hearing, air to air or air to ground attacks. Those were like say targeted missiles. Majority of all these, or in all these applications, some algorithms like say which we call as like say reinforcement learning. Okay, these algorithms are implemented, and when you actually get into reinforcement learning, there is good amount of uneasiness. It is very easy to talk about it, like say how it works and all these things. Theoretically, actually, we can draw very nice diagrams on the board. Okay, but when it comes to implementation, okay, or even like say even think about implementation. Okay, how to create data is one of the toughest tasks. Okay. Actually, when I entered into reinforcement learning, I did not know all these different difficulties actually. We shared some of the material, okay, today's presentation in PPT, PDF form, and also there is one write-up, okay. That write-up actually I implemented some time back, and I'm actually trying to go for patent of that one. Of course, I revealed to the extent that my idea is not my idea cannot be completely copied, okay. So that time, like say, as of now, you have sklearn library for machine learning. Okay, and you have like say TensorFlow recently came up like say some 2-3 years back for deep learning. Okay, and when we actually started programming for this reinforcement learning, there was no library per se. We had to actually write our own framework to complete the task. Okay, for just one application, it took around 9 months for me to complete that end to end. Okay. So I will be actually touch basing this one tomorrow at second half, because I will not be able to implement and show you because that is a bigger application. But I will be walking you through like say different stages. If you take a real time scenario, how do you actually model and then get to that level where you can implement. And before that, we actually implement some toy problems. In fact, it is actually some 2-3 years old. I will be actually touch basing that framework, and then we will get into hands on. Okay, there is something called OpenAI Gym. That is the framework. Okay, and of course there are like say 3-4 more frameworks what are mentioned in Quora, but they are not maintained well. And using existing framework for like say reinforcement learning is a challenging task. Reason is the data what I use versus the data what you use. Here the data I mean to say, I want to actually get into self-driving car, and you want to basically hit some target. So the environments are completely different. So coming up with a generic environment where everyone can use that library is very difficult. Okay, as of now, this may actually look little bit of jargon. I will explain, and then it will be clear. Okay, so the agenda is as follows. We start with introduction to reinforcement learning, and then first of all, why should we actually get into this one? There should be some business value, right? So we will actually see patents in different technologies. We actually had already good amount of supervised learning, unsupervised learning, deep learning, and now today we have reinforcement learning. Okay, and this is like say as of now one of the latest trending things in the market. Deep learning followed by reinforcement learning. Okay, how many of you know DeepMind in Google's DeepMind, right? So you people are already aware about it. And Google's DeepMind AlphaGo actually defeated this like say world champion Go game, right? Yeah. Okay, and it was like say I think 100-0. No, right? So that means like, and that was one of the toughest games it seems to actually. I don't have any intuition about that game. Okay, so that was one of the toughest games it seems to beat human. Okay, so people actually came up with combining deep learning and reinforcement learning, and now they are able to basically beat world champions in that area. Okay, and this happened just recently, right? So we'll see like say what is the trend in patents when it comes to these technologies. You may expect like say supervised learning will be leading the patents. Okay, we'll see those surprises. Okay, and then what are the differences between supervised learning, unsupervised learning, and reinforcement learning. Okay, and a few examples like say what are the dominant problems we solve using RL. Okay, and then we get into introduction to RL and what are the important concepts, important components in RL, followed by one of the celebrated algorithms in for RL, Q-learning. Okay, well, if you ask me, like say, why that name Q, I actually do not have don't have idea, but probably the guy who invented he has some Russian roots, looks like. Okay, and then you have like couple of case studies. So smart taxi, and then I do that smart taxi in class using this framework, whatever our friend mentioned, OpenAI Gym. Okay, and then you'll be actually solving the next one, frozen lake 4x4. That is, we'll see what is that 4x4. Okay, and then we actually start improving our Q learning from there onwards. And then we get into second case study, like say the same case study extension. Okay, and finally we go to the next level of Q learning, improvement of Q learning to the, like say Q learning first level improvement, second level improvement, SARSA. Okay, the name looks like say some person name, but it actually state action reward state action. Okay, that's it. Okay, and finally we'll be touch basing on this real world case study. This document is already shared with you. Fine. So what we expect by the end of this module, I mean this 4 hours and next 4 hours, you'll be able to actually program to some extent real world scenarios. Okay, today itself I will say like say without this framework, how do you solve a small problem, like say programming environment, and then okay, I'll say that that code as well, so that without using the built-in environment, this framework, okay, how do you solve the problem? I believe that will be more beneficial, but I cannot use that one in the classroom because there will be like say hundreds of lines of code. Okay. But I can explain the structure, how it goes. Okay, and then we can describe different scenarios in RL. Okay, finally examples. Okay, explain various models in RL. That's what we can expect from this course, from this module. Okay, and of course, having said all these things, okay, you can see like say the top-notch applications, whatever we are actually seeing in the market now, most of them are programmed using some form of RL. Okay, so there will be good amount of complexity when you actually go for the bigger case studies. We'll try to actually keep it as simple as possible for a class, and towards the end we'll actually make it little more complex and more realistic case studies. Okay, so when it comes to patent search, I actually just quickly browse through the patents. Okay, for example, k-means is one of the trending words among data scientists. Okay, for k-means, when I actually look at the number of patents filed using k-means as a word, okay, there were around 620, not filed, patents awarded. Okay, and with the deep learning, there were like say around 100k patents. Deep learning being one of the oldest technique, like say it actually started in 1960s, 70s, right? So, and then reinforcement learning, which is like say one of the latest ones you can call, okay, that has like 65,000 odd. Okay, and if you see the latest one, I mean last 2-3 years, the amount of applications people are developing and going for patents are dominant in RL, combining RL and DL. These two areas are dominant in generating values. And also if you see the takeovers in startups, people focusing on these two, deep learning or RL, okay, these two are like say dominant. When it comes to startup, yes, I have showcased some value with RL, you have higher chance of maybe taking over by Google. Okay. And recently, like say some 9 months back, it happened in Bangalore, right? One actually team itself was acquired by Google, AI team.
6-month-old team was moved.
Yeah, it was not even like say some established startup. Okay, they showcased some value in DL, and it was taken over by Google, and some undisclosed money. They did not disclose how much money they have paid. let me actually just to give you that confidence, what is the trend in the latest one. Okay, these are the two things what you can use, lens.org and Google Patents. Okay, if I it is like say open source patents patents information maintenance website. Okay, so if I actually do this one, lens.org, so I go for like say in recent past how the trend is. Okay, this year just we are just in March, that's why it actually came down. But if you see the growth, it's even bigger than exponential, right? Maybe exponential of exponential, let me call it, right? And now if I actually look at this is somewhat smoother. In the recent past, it is somewhat smoother compared to the previous one, right? So the growth in RL is pretty dominant compared to DL in recent past, right? Because everyone is going for automation. Okay, so if you want to generate value, I think this could be one of the like say next steps you can take. Fine. And now you can actually look at other supervised learning algorithms in the similar fashion. Okay, you can actually go to Google Patents and see, and you can see like in these things what are all other things like say for example monitoring method and monitoring device of deep learning processor. Okay, and you can actually see exactly what people are doing in recent past. This actually sets up our task like say yes, we have to get into this field or to basically ride the tide. In traders terminology, there is something like say trend is your friend, or trend is trader's friend. If some market is going up or going down, that is the best thing where they can make money. Okay, if market is fluctuating around a point, they actually switch off the system and go for break. Okay, so if you are able to see a strong trend in one of these technologies or some of these technologies, let us actually ride the trend. Okay. So in supervised learning, we have like say X and Y. X is our independent set and Y is our target variable. And so we want to basically predict Y using X. Predict Y using X in the sense we want to find a function F. Function is nothing but a relationship between X and Y. That's what we want to basically do in supervised learning. So some of the examples like say you have classification, regression, then object detection. Of course, again falling either in classification or regression, predominantly classification. Okay, image captioning. Now combining multiple technologies, like say you have your DL plus NLP caption, like say image captioning. Okay, this is what we learned so far. In unsupervised learning, similar stuff, but without Y. There is no target, right? So just as a feature space, we basically want to find hidden patterns in the data using this unsupervised learning. Okay, so learn some underlying hidden patterns in the given data. That's what we try to do in using unsupervised learning techniques, right? So some of the examples: clustering, k-means or hierarchical or DB scan. Okay, some of the dimensionality reduction techniques like say PCA or factor analysis, right? And then feature engineering. Of course, feature engineering also you can use like say PCA for feature engineering. Okay, so and then density estimation using like say DB scan sort of thing or any other statistical methods. Okay, so that's what predominantly like say bird's eye view of unsupervised learning we had. Okay, and when it comes to DL, okay, if a problem is not falling under in supervised or unsupervised learning, okay, you are not basically able to get some data upfront which can be easily handled, okay, or which is like say combination of supervised and unsupervised. Say for example, I want to hit a target, okay, that is like say very ambiguous statement, right? Because when I actually take off, due to weather conditions, my direction may be changed, right? My instrument direction, maybe that what do you say, aeroplane, whatever it is, the direction may be changed due to some external factors, okay? But I have to hit the target. That means when I actually train the model, the coordinates are like say the information what system had was different compared to now when it is in the air. That means the flight should be able to take the decision on its own looking at the external factors, but finally reach the target, right? If you actually listen to some of these videos by what do you say our IAF personnel, we fixed the coordinate and we sent it and it did the rest of the work. That's what they told, right? And if you actually look at it, target is fixed and like say missile is fired, like say incorporating all external factors, it did not miss the target. The error they actually mentioned was few meters, single digit few meters. That's what they mentioned, okay? That means the problems which actually have to incorporate that latest external factors, those are the problems where RL can be very good. Your regular supervised and unsupervised learning will not be so effective in those scenarios, right? So more general than supervised and unsupervised learning, okay? These problems, like say reinforcement learning problems, you will be actually hearing the following terminologies again and again. There will be something called agent, there will be something called environment, there will be something called reward, okay? Environment is like say our external factors, agent is aeroplane, okay? Action, go straight or take slight left or slight right, okay, based on wind or whatever it is, okay? So in frequent intervals there will be communication. In frequent intervals it actually starts calculating what action to take, left, right, straight or go deep, right? So you have like say your environment, weather, okay, your flight, and it actually takes action. When it takes action in the given environment, that flight coordinates are different, right? Now you look at the target and based on that now your coordinates are different. That means your data has changed, your state has changed. I mean to say agent state has changed. Now based on that state again you have to basically take the next action, okay? Go another 10 meters ahead. Makes sense, right? So this repetition will be continuous till we reach the target, okay? And now there is this one, how do you actually say my action is correct or not? Whatever action I have taken is correct or not? There will be some sort of reward associated to that. Some reward associated to that. Say for example, yes, you actually moved in the positive direction, whatever is expected, okay, I'll give you 1 point, okay, due to like say someone tried to intercept you, so you actually took the like say slightly deviated direction, now I'll give you -1 point as reward, I penalized you. That means now whatever the action you have taken, that instead of straight you have taken right, that action is not a correct one to reach the target. To reach the target you have to go straight, right? Now you see like say going straight or going left, going right, those are the actions you are taking. Those actions are actually leading you to some reward. Reward in the sense like, yes, you are closer to the target or not. If you are not closer to the target, because of your action you are going away from the target, that means the action you have taken is a wrong action. It should be penalized. Make sense? So that's what on like say bird's eye view, what reinforcement learning is. To solve this problem, now people actually came up with a lot of algorithms. Okay. So predominantly RL is the science of decision making. Okay, and this is where like say people are actually running behind it. Automated decision making. Pilot is not sitting in this one. Your system is making the decisions, right? And it is not missing the target. That is the power. right? Your supervised learning, if there are outliers, algorithm will go for toss.
Would need a huge storage space and everything.
Of course.
Just to capture the data. How do we know that you have enough data to make the change?
Well, that is a slightly a challenging question to answer. Okay, the data itself you have to create. Okay, I'll show you some examples. After that, then I'll take up that question again. Okay, so how do I collect data and what, like say, what is the volume of the data needed for to solve this problem? That is what his question is. The example. Okay, I have two examples now. One of the simplest examples, you see, like say we actually live with in the sense, like say we actually have a lot of animals around us, and many of those animals are our friends. Say for example, like many people have dog as their pet, cats. Okay, say for example, I have cattle at my village home. Okay, if my sister calls, that buffalo comes. If I call, that actually comes to hit me. Okay, and it is very difficult, like say, to understand now, like say how the buffalo understands human language. It is very difficult, right? But that's what exactly is happening. Now, what is the logic behind it? Okay, now let us take a simple example. Okay, let us actually try to teach something to the dog to do. Okay, so consider a scenario where you want to teach something for a dog to do. Right? Say for example, what normally these trainers do, they actually try to create some noise or create some action, hand signs. Okay, based on that hand sign, if dog does the favorable action what the trainer wants, dog will be appreciated by either a biscuit or a pat. Right? So then next time when trainer actually does the same, like say hand sign or like say some noise, now dog, like say it tries to do something else and it is not getting that biscuit. So again it actually goes, oh okay, I did that one, I did previous action and when I actually got the biscuit, let me try to do that one, whether I get biscuit. Okay, it tries to actually repeat the old action where it actually got the biscuit. Okay, now it got the biscuit. So now it has the memory. Okay, whenever there is hand sign of, like say lifting the hand, if I do this one, I'll get biscuit. Getting biscuit is reward. Not getting biscuit is punishment.
Set of actions that lead to a result would be that kind of scenario. So how do you capture that in your loop?
Yeah. So first of all, actions can be lot. It can be continuous space as well. When you take this flight scenario, it can actually take the rotation in continuous manner. Why only 360 degrees? It can be actually 1 degree by 100th as well, right? 100th fraction as well. So yes, you can have lot of actions, but in this particular one, okay, say for example, you lift the hand, you are a trainer, you lift the hand, you expect dog to get up. Okay, you actually put down your hand, you expect dog to sit down. There are only two actions, right? One is, like say dog has to get up, it has to sit down. And say for example, third action, when you actually throw some ball from your hand, you expect dog to jump, third action. Okay, when it actually jumps, you appreciate it with biscuit. If it doesn't jump, you don't appreciate it. Right? So you are increasing now action space. Right? And now when you actually take the stick, it knows, like say you are going to hit or you are going to punish it. Right? So that is a negative thing for that. So when you take the stick, it will be very obedient. Whenever it was obedient, when you took the stick, it did not get that much punishment. That's why it actually starts acting as obedient. Make sense? Now all these things, though they look qualitative, but they are all quantitative. We can actually make all these things as observable entities. Correct, right? Okay. Now getting into the dog example, let us actually try to quantify. Quantify in the sense, let us try to get some sort of logic. What exactly is happening? how reinforcement learning works in broader sense. Okay, say for example, your dog is agent, okay, that is responding to the, or that is exposed to the environment. Okay, the environment could be your house or your lawn, right? And now the situations they encounter are analogous to state. Okay, you are in the environment and you are standing, that is one state. Standing with your folded hands, folded your hands and kept it in the back of your body, that's what state is. Okay, when you do this one, dog also actually comes and stands in front of you, if you observe, right? And when trainer actually raises his hand, okay, it is actually seeing the change in the environment. Change in the environment, state changed. Yes, as a greedy person, okay, when I actually try to program, I want to actually capture all the movements when I lift the hand. Whether all these things are important, or like say keeping my hand in the back of my body and raising my hand and showing this one. Okay, there are only two actions, discrete actions, discrete states. These two are enough, or I want to actually capture everything. As a greedy person, as a greedy data scientist, I want to capture everything. But for our example, let us say this is one state and this is another state. Okay, so as soon as my state changes, the agent actually starts acting, right? So our agent reacts by performing an action to the change in the state. Change in the state in the environment. Trainer actually gave the signal, shout or hand signal, whatever it is. Okay, that is the change in the state. Okay, then your agent, the dog, is performing some action, and that action, based on that, like say you expected the dog to get up, it got up, and you are the trainer, you gave the biscuit. Okay, you giving the biscuit and the dog taking the biscuit is like say dog receiving the reward, agent receiving the reward, right? So for every state followed by action, there is a reward. Whether that reward is 0, -1, +1, okay, getting punishment, getting food, no, like say you don't actually do any reward at all, not giving any reward also is reward, reward 0, right? So after the transition, they may receive a reward or penalty. Okay, once it actually takes the biscuit, you throw the biscuit and dogs take the biscuit. Okay, now again you have like say change in the environment. The change in the environment is new state. So from previous state, I actually now came to the another state. It could be my, like I said, previous state where I stood keeping my hands in my back, or it could be like say lifting my left hand, right? So the states will be changing continuously. Based on the states, there will be actions. Based on the actions, there will be rewards. Rewards to the agent, actions by agent, environment. Because of those actions and rewards, environment changes. Environment changes in the sense the states in the environment changes, right? So it is a continuous process till you expect the agent to complete the task what you wanted. Makes sense, right? And now if you see, it looked a toy example, but it actually perfectly makes sense. Now we can generalize this topic, right? And in fact, we are all like say tuned to do reinforcement learning in our life, but we don't program per se reinforcement learning with hand. I mean, computer programming we might not have not done, but we all are tuned to do this activity. Okay, the policy, this is another term, okay, which you will be hearing again and again. The policy in reinforcement learning is the following. The policy is the strategy of choosing an action based on the state. Okay, policy is chosen by agent, and then if this policy is optimal policy or the best policy, that policy is referred as optimal policy for a given state. This is the best action. Okay, for a given state, this is the best action. one of the simplest examples is you are on highway and no vehicles in your hindsight, and you are like say driving. Looking at that scenario, most of the time you actually increase your or like say you accelerate your speed. That is the thing, like what we have actually experienced in our life. No one says us like say, okay, now you go by like say 120 or 150, right? Our system is tuned to that one, like say, okay, this is the environment, let me actually take this action, because this particular action led me into a lot of benefit in the past. Okay, let me take that action for this like say state. That's what is your policy. Action, state action pair is your policy. The state action pair, which is the best state action pair, I mean best action for a given state, is optimal policy. Okay, and once you train your system, this is the beauty. Okay, once you train your system, at the end, what you actually store in your what do you say automated system is list of all possible actions and their respective list of all possible states followed by optimal actions.
It's a one-on-one.
Exactly. Okay, it could be like say 1 million states. It could be 1 million states, and 1 million like say number of actions could be just 100. But these 100 actions are linked to for each state. Say for example,
what if an important state is missed?
That's where DL comes into picture. Okay, when you have a continuous space, how do you approximate? Okay, we'll touch base that one tomorrow. Assume that we have all states listed possible. All possible states are listed. Okay, so let me actually say this is all states, state 1 till state 100. Okay, these are all states I can actually think of like say showcasing in front of my agent, which is dog.
Like buffalo and the runway example we spoke in the past. Yes. What would happen? Like what I'm saying is like an odd state.
Exactly. Okay. So if some state is not experienced in the system when you're trained, okay, when in real life when you actually experience, you are getting negative reward. And the name of the algorithm is reinforce. Okay, this is the new state, and when I actually do some action on top of this new state, I'm actually getting the negative reward. Let me not repeat the same action what I did for the new state, because my experience is bad. But first time when I actually do that action for the new state, I'm getting affected. I have to live with that. There is no scope. Okay, and another thing what you actually can get like say similarity is the new state, whether it is close to one of these 100 states. Maybe it is close to state 50. This is new state, it is close to state 50. Let me take that optimal action. Your clustering is coming into picture. Okay, and in fact this is what I actually implemented in finance, because finance you cannot see all the states. So approximate states, and then based on that you basically take the action. Okay, so I have like say states 1 to 100, right? And now for state 1 to 100, let me say for the dog, okay, hand lift. Okay, this is that comes under state. Okay, for state 1, dog jumps. This is one action, right? And for state 2, probably it sits. Another action. Okay, and these are actions. These need not be optimal actions, right? So once you train your system over the period of time, okay, for the state 1, probably walking to next point is the best action. right? So over the period of time, you actually start repeating these actions, you learn your system and then come up with a list of optimal actions, not list of optimal action, each state mapped with one optimal action. Okay. Now the output of reinforcement learning, once you train your system, okay, you have your problem, and you train using RL, okay. Now you say like you have your output. The output is going to be just like say CSV file with 2 columns. Those columns are nothing but states, optimal actions. That's it. And this will be your output from the system. The better optimal actions you get, the better system it will be.
Associated with multiple states.
Definitely.
Because one state may not have more than one optimal.
It is only one, like say, one state can have only one optimal action. So when you are on highway, whether you are nearby Bangalore or nearby Hyderabad, if like say highway is clear and it is 6 lane, you actually accelerate. That is different state, but acceleration is common action, whether it is nearby Bangalore or nearby Hyderabad. Right? So different states, but same action, because these states are very similar to each other, excluding the geographic location. Right? So
in case optimal action needs to be changed.
Sorry?
Okay, scenario has changed, environment has changed, let's say, something has happened. Optimal action needs to be changed.
Exactly.
Then what happens? That was my question. So how much data we would need to make sure to come to a conclusion that optimal action needs to also be changed.
Okay, in production, how do we use it? Now I can erase this one, right?
See, you are talking about multiple states which are similar to each other.
Yes.
Then both can have optimal action.
But your states are different. That's what you have lot of states, right? You have lot of states, and each state is associated with an optimal action, right? Say for example, your lion and other like say 4-leg animal, like say cat, they are very similar, but the actions actually you perform when you are in that environment are different. Yeah, exactly, because when you actually do the same action when cat is around versus when lion is around, reward is different, right? Am I correct or not? So that's what. Now in the production, how do you actually do it? So you have, let me say, this video streaming. Okay, you have your video streaming. Our eyes are seeing that video. Okay, now every 1 second or every 500 milliseconds, you actually capture the scenario, you actually capture the state. Okay, continuous stream, you are discretizing it. Okay, and you are discretizing to the extent that your system can actually react, right? So new state, fine. This new state, now you actually see like map to your existing one, where that state actually belongs to, take that optimal action, okay, and since you perform this action, say you are on highway and you performed action of like say accelerating little more, maybe you are actually reaching the end of the curve in the road, right? Now your state is changing. So after that you are getting again new state. Now since like say in few hundred meters ahead there is a curve, the optimal action whenever you have this scenario is slowing down. right? So look at again this one, okay, take the action. And the faster you make this system, the better it is. And that's why when you look at self-driving cars, they say if you go beyond 60 kilometers, my car will not be able to function properly.
Changing in different states, right? So one action, I mean the result, I should reward it or not, depends on the future state. Because that is our neutral state. We don't know what.
That is training part of it. That's what Q learning.
For instance, suppose I'm going this way. I'm starting from there. This every time I have to take. So
Yes.
there will be no reward for this.
Yes.
Right? But left or right, where I should go. If I take right, then that is like I should lose. If I take left, I should win. This is a neutral thing, right? Where you are not rewarding anything.
I completely agree. And this scenario you always have in chess. Say for example, any game winning is the reward. Okay, to win the game, you may set a trap. The trapping, temporarily it looks like -1. Right? So yes, long-term win is the target, and then short-term loss is negative reward. Okay, how to keep this memory? That's where you have like say Q-learning advanced and SARSA. Okay, and this is actually part of the training of the reinforcement learning system. Okay, when you use it, you already trained and you actually thought that, okay, at 9:30, when you come out of the house, okay, irrespective of what reward you will get, you actually should go straight, though your vegetable market is in, you're behind, because your office is 10 kilometers away from you. Initially, you may actually see like, oh, they are taking some long routes. And now you start actually suggesting them, okay, no, take this shortcut routes. After 2-3 trials, when you take the next cab, automatically it gets adjusted. You don't need to tell the driver after that. Right? The reward here is less fuel consumption and shorter time to reach the destination. That is the reward for them. Right? System is getting trained in the back. Right? So long-term target should be always kept as like say in the view, and the long-term, like say when I say reward, it's not actually one reward. She correctly pointed out the rewards will be accumulated in the following way. It's when I actually look at reward only in the next moment, that's referred as greedy algorithm. Right? When I actually look at long-term reward, that's referred as keeping in the memory. Right? Setting the trap and winning the game. So the present reward actually will be reward starting like say, let me say I equals to t to, or maybe I'm actually going to have like say some 100 time steps from now onwards into the future. Okay, and then it is not exactly with the equal proportion. My present reward I need to give little more higher weight than future reward. Right? So I actually put some like say learning parameter, and when I go to the 2 time steps from now, this learning parameter should get depreciated. So learning parameter less than 1, and then I'll actually try to put something like say power I. So since learning parameter is less than 1, and when you actually get into too deep into the future, that may not have much importance, but you are trying to give some importance. Okay, now you can play with these things, and that's how you actually get the memory into the system training. So your actions are not instantaneous, your actions are looking like say future reward also into the, your actions are actually taking your future rewards also into the consideration. Make sense? This is what you are asking, right? Okay, fine. So how do we actually play with this one? You actually have come across this one in ADA boost as well as in gradient boosting, learning parameter. And in deep learning, like say you have been living with it. Correct, right? Yeah. Okay. Now, so far are we fine? We are able to get, like, say, reinforcement learning is nothing but, like, say, looking at the state and taking the action, and you are getting reward for that one, and over the period of time, what are the optimal actions for the given state? Okay, that's what we have to figure out, and output of reinforcement learning is going to be this, just this CSV table. Okay, on this missile, it will be just the CSV table implemented. So for that, like, say, system to work, there will be video streaming coming in, new state identified, optimal action taken, it will be continuous. How fast you can react, that is nothing but your accuracy. Some people say, like, say, I can react in 1 microsecond, 2 microseconds. Yeah, then you can hit target even before others realize it, right?
So the output of the training is the CSV.
Exactly.
And then afterwards, what you do with the CSV?
On, like, say, I am looking at no self-driving car. In self-driving car, I have the following. In self-driving car, you have a camera in front of the system, like, say, car, right? Your car camera, it is taking the pictures. How frequently you want to take pictures? Maybe every 100 milliseconds, right? Or live streaming. Though we call it as live streaming for marketing purposes, it's actually frames, right? How many frames do you want to have in given 1 second? Like, let us say 100 frames. Let me take frame 1, latest frame. This frame is explaining me my state, right? This frame is nothing but state, where I am in now, right? On this frame, you have to associate with other quantities as well, right? The speed at which you are actually at present you are driving, and other external factors. Probably when I actually ride my scooty, my son says, "Daddy, some cycle wala is going faster than you." Okay, I normally cannot ride faster. Okay, but others, like, say, they may go at 120 or 150 on their bike. Okay.
And each frame is possible to have multiple states, right?
Each frame can have only one state, because this frame, using your clustering, you are saying this frame is similar to so and so state. Agree with me?
Can we have another car in front of us? And we can have traffic signal also in the same
Of course,
frame.
and that's why self-driving car, you'll have, like, say, a lot of data to crunch. Google spent several hundreds of man years to build this one. Self-driving car, Google spent several hundreds of man years to actually simulate all these things, and still we hear, like, say, recently self-driving car hitting a human on the road, right? Because that particular scenario was not captured earlier, right? So you have the frame and also associated attributes. Okay, all these things is new state. This new state is one of the states in your CSV file. Then take action. Okay, once you take this action, it is leading to the next frame, right? That's it. It is an iterative process.
If there is a new state, it does activate training CSV file.
Training will never take place in client place. Training will never take place in your, like, say, car. Okay, the person who sold you that self-driving instrument, they have trained with enough scenarios and they have given you. And if they want to train with the new scenarios, that's what they say, we are giving you updates. We are giving you updates. They are adding more scenarios. It will be, like, say, very limited data. You need to know, like, say, what is the scenario in front of you, right? Are there any objects? If at all there are any objects, how far that object is from your present location? You can detect that one, right? When flight is actually going in air, it is able to tell, like, say, how, like, what is the altitude it is flying at. It's able to detect. It actually tells you, like, say, It is coordinates, right? You basically from your flight you send the signal and like say that sound signal, okay, how fast it actually goes and comes back. That is the algorithm basically to detect the distance, and that's how flight like say pilots are able to tell, like say we are actually cruising now at 11,000 kilometers. Because your system actually should get all these things. Otherwise, what happens is the data what you have is not fully like say representing the state. Do you people agree with me or not? Like say yes, without saying like say how far ahead of some particular object is from me. If I am not able to detect that one, I actually end up with an accident at some time. This is a definitely like say useful data to have as an attribute. And we have been seeing like say this is what is available. You just have to capture and use it. Once you have all this one, you are doing action. That action is leading to you to the next state. That next state again includes frame and attributes.
Adding new scenarios is not automated learning.
No.
It's similar to other models where how we will collect new data and then retrain, build, test, deploy.
Exactly. It is the same. But if you actually look at it, there is a significant difference between your supervised learning, unsupervised learning, and reinforcement learning. The target in your supervised learning, target is fixed. Here, your target is actually evolving. I want to come from Hyderabad to Bangalore. My target is short term. Like say every 100 meters, I will see like say whether there is any obstacle. Reach that 100 meters, again evaluate it. Right? So target is evolving. Am I correct? So there is a significant difference between your RL and your SL. And your like say unsupervised learning clustering is actually coming as part of your state aggregation.
I'm just taking from an NLP perspective.
Yeah.
We have trained a model with a list of words.
Yeah.
We are looking at something and predicting. The model has not seen any new scenario in this case, but still it is affecting our classification. But model has not seen that.
Yeah.
Then also we have to even in our machine learning scenarios, we will have to collect how many such. If it is significant in number, then we will go and retrain the model.
Definitely.
Right? Same thing even if you use RL there also.
Definitely train, test and deployment has to be there. Okay, train, test, here like say test, I mean to say you have a self-driving car, you put it in the ground and you actually try to create hurdles and see how it reacts. The test environment, that's how you create the data.
Because a lot of business people think these things have been sold in very bad way. Many business people think that it is auto learning. Not only RL, even machine learning, they think it is auto learning.
I completely agree. So here the thing is, when you actually explain to anyone this self-driving car, there is a strong sentence made, right? When Google actually announced these things, self-driving cars are not suitable to Indian roads, right? Self-driving cars, they are not suitable to Indian roads. Main reason is, like say for example, the lane discipline. These things are violated very frequently. Exactly. So they may be actually roaming around freely, right? When that sort of scenarios are not part of your training data, then your system doesn't know what to do. You meet with an accident in that case.
So automated learning is something is not really till now, right?
It is a marketing term. We are evolving. The better you actually say like mine is a very good system with a lot of confidence, if you are able to tell, you can sell it for a few $1 million.
For instance, you talked about like some scenario which didn't exist, but shouldn't it return to some default state then?
That's what exactly actually happens in your car also.
Unexpected right? Kind of scenario it came, then it should return to its default state.
Exactly, it actually comes. Say for example, yeah, you say like when you are driving your car, okay, without actually coming to the neutral or pressing the clutch, okay, you put the brakes, slight brake, and you are on 4th gear, automatically it stops. Default state, right? Engine gets stopped.
Yeah, but we need to define that for all the scenarios for business. For instance, for your problem, stock problem, there will be a default state.
We have to define all these corner cases should be defined. Okay, because that's why the building reinforcement learning system takes a lot of time. Okay, it looks very, very easy to explain, but development, now you see the complexity. Okay, we are actually talking about a lot of like say new data points coming in, all these things. Now coming up with a general framework to solve this problem is far from reality. Right? Okay, now let me go to the next one. This is like say, I think almost all of us might have experienced. How do we actually teach baby to walk? This is exactly like previous one. Yeah, right? You actually try to give some reward, right? That reward could be just clapping. Kids are attention seeking people, right? In general. So when kid actually gets up, he doesn't know whether that is good activity or bad activity. We all start clapping and he sees like say smiling faces all around. So okay, this action when I do, I'm able to see like say a lot of attention towards me. Let me do it repeatedly, right? And then he actually puts one foot forward. He falls. We all will be sad. So that action of falling is not actually liked by my people. Let me not do that activity. I may do something slightly different because by then I don't know like say what is correct one. I may do something slightly different. And then people are liking. So I try to repeat it again and again. Right? Whether the kid actually looks at our smiley faces or like say he actually looks at our chocolate or whatever it is, from his point of view, smiley faces or chocolate, everything is reward. Right? We actually saying, oh, you fell. That's also reward negative. Right? By then, kid and you don't have communication mechanism developed. Right? So, for example, my son actually started talking only at the end of 3rd year. And we were sending him to school at starting of 3rd year. Okay, his teacher used to tell like say he doesn't speak to anyone. Why are you bringing? But I could actually understand whatever he was trying to tell. That communication mechanism was established between me and my son, but not between teacher and student. Right? So exactly those actions, whatever he was actually making those actions, my system was able to understand it. You have to train the system for the new data points. Make sense, right? And now you see, this is what the end story is. You have your child and you have surface. Okay, so couple of steps that child actually puts, and then you are actually rewarding him with chocolate. He falls, you don't reward him with chocolate. So whenever that kid wants chocolate, now he puts those two steps. Well, it is actually much more complex than this one. Okay, online learning is a marketing term again. Okay, we actually try to say my car actually goes at 300 kilometers per hour speed, Ferrari climbs, but in reality, we actually buy Maruti going at 120 or 130 speed. Online is exactly the similar one. Right? So people claim online learning, yet to come, it is something like say automated machine learning. Auto machine learning, what some of these framework people are claiming. Microsoft of the world, Amazon of the world, right? They say like say you don't need to even program, you can just drag and drop APIs, right? Yes, you can do all those things, but at what cost? Right? So they are actually trying to simplify. There is limit for simplification. Online also, it is basically for marketing. In reality, I may not believe online learning. Of course, there are algorithms for online learning. Okay, and reinforcement learning, if you actually take it as like say optimal actions and then states, it's actually taking actions online. Maybe you can say my system is automated and taking actions online or in real time. Fine, can we go ahead? Are we getting the sense of like say what kind of problems reinforcement learning can handle? Okay, the data size can be very big and the data can be pretty ambiguous at this stage. Okay, Now you have like say, you have your agent, the kid, okay, he did some action, like say either standing up or walking forward, okay, and then the environment where you are in on surface, you observed it and you gave him reward, and before that you have to interpret it, right? Yes, this action is good, you have interpreted, you have given him reward, and then he tries to again repeat the same thing, okay. When you interpreted and gave him reward, your state has changed, environment state has changed, again it is continuous cycle, okay, right? So now enough with those trivial examples. By the way, these examples, when you actually start building to the next level, any example or any case study you try to solve are very similar to these two examples. You take any example, okay, whether you are talking about self-driving car or whether you are talking about like say hitting some target, all are like say again boiling down to this one, your data changes, okay, what is my state? That state definition will be different for different problems, but the process is same, okay. Now she was actually saying like say, can I keep that end target in view and then have that like say present rewards like adjusted? That's a different algorithm. Now to solve this one efficiently, you actually come up with different algorithms, whether you want to be greedy, I mean trying to focus only on the next reward, trying to focus only on like say chocolate, or you want your father to lift you and take you to the bazaar, right? If that is the target, I walk as a kid and I don't take the chocolate, I refuse the chocolate, right? That is a negative thing. I don't take the reward, and then my father thinks that okay, he is not taking even this expensive reward, probably he is expecting something more. That's what all kids do, right? Yeah. So RL is actually intersection of some of the known areas. One is like say optimum control. This is what like say communication engineers, they are very fond of this particular word, optimal control. Okay, ECE guys, they actually focus on optimal control. And RL from optimal control point of view are like say your aerospace applications or communication network applications. Okay, and then you have like say operations research, right? Operation research, it is pretty interesting problem. Say for example, you have this a big blood bank in the city, and like say yes, blood supply is there, and there is a requirement also from different hospitals, right? Now some blood groups are universal donors, some blood groups are universal acceptors, some are only one-to-one, right? With given supply and given demand, what is the optimal way so that everyone can actually get everyone can be served? That's again RL. Okay, you can actually frame it as part of reinforcement learning problem. Okay, but it is a supply chain. Solving a supply chain problem using artificial intelligence. Now, I actually told only till this point. Now you have to actually get your intuition, like say, what could be my state and what could be my action for this, right? If universal donor is actually giving it to universal acceptor, probably that may not be a right thing. Universal donor giving it to a specific blood group probably could be a right thing, right? So you actually iterate through all these actions and finally you come up with proper match. Okay, this supply today, whatever blood we have in the bank could be actually mapped to so and so. Makes sense, right? So, and then you have like say these economics people, utility theory, game theory, whatever it is, right? And then medical applications, neuroscience, or like this one, or like say artificial intelligence or deep learning. Okay, and since you people were talking about like say state aggregation, okay, sometime back me and my friend in IIT Mumbai, we were actually trying to solve some problem empirically. Okay, we actually spent a few weeks and we actually came up with the state aggregation. You have continuous data coming in. How do you actually get the states prepared? Because you cannot take data in a continuous format. Maybe every 100 milliseconds or every 1 second you have to consolidate all that information and then go for the action making, right? So we actually empirically proved, and then but we had some doubt about its validity. We talked to a professor called Borkar. Okay, by the way, Borkar is one of the leading research scientists in India for like say reinforcement learning. He is in IITB. Okay, and his students are in IASC. Okay, like say Professor Ghosh and other people, and other like say his Kandan, Professor Borkar's Kandan is pretty big in Bengaluru as well. So we actually explained him the problem. He told, okay, go and see my paper in 1995. I proved this one theoretically. Okay, almost like say some 15 years before what we actually solved empirically, he could theoretically prove it. State aggregation, how to do in a continuous manner, how to actually aggregate this information and put it as a state. Right? So that is nothing but like say some people call it as vectorization, some people call it as clustering, and in RL terminology we say state aggregation. Continuous data, you have to put it into like say all that information consolidated, like say every 100 milliseconds, this is what my state is. Makes sense, right? And then, so how this particular beautiful object, reinforcement learning, is seen from different people. Okay, when you are like say coming from computer science and machine learning, these are the intersections what you have. Okay, so different people try to handle this problem differently, but at the end automation is the target. Okay, at the end automation is the target. And the other thing is there is no target variable here. It cannot be fit into unsupervised learning, it cannot be fit into supervised learning straight away. Those sort of problems, automating those problems, like solving those problems, solution, automating it is nothing but reinforcement learning. It is core of decision making. And if you want very, very precision decision making, that can be achieved to the greater extent with RL. Okay. So you have like now trying to see how the interaction between agent and the environment. Okay. So for example, you have your environment. In that environment, you have states, rewards, actions, right? You actually emit state and reward, and this man, agent, he actually sends back action. Because of that, something will change here. Again, you actually start emitting. Okay, this is what is exactly happening in your self-driving car or any continuous systems. Right? This is what I wrote here. This is a continuous process. Okay, every time this is like say, this is actually emitted. Look at that lookup table, .csv table, action is actually sent. And again, your state is coming up. Again, you are sending back action, looking at that table. Since you are just looking at lookup table, your action taking time is just a fraction of a second, maybe couple of microseconds. Right? Can we go ahead? So now in a way, reinforcement learning is the science of making optimal decision, right? That's what the crux of the story. It is the science of making optimal decision, looking at the experience, what you had so far. Experience is nothing but training the system, right? So breaking it down, the process of reinforcement learning, observing the environment, deciding how to act using some strategy. Observing the environment is nothing but state aggregation. Last 10 microseconds information, let me put it as my state. Right? In last 10 microseconds, my vehicle traveled at like say 120 km speed. Right? And coordinates are from here to there. the coordinate of present one, coordinate of previous one is so and so, right? And the fuel consumption is so and so. Okay, that's what my observation of the environment. Okay, now acting accordingly, your optimal actions, looking at the table, right? And then receiving the reward, reaching the target, right? And then learning from the experiences. If it is good experience, you try to repeat it. If it is bad experience, you try to avoid doing that action, right? And then iterate until an optimal strategy is performed, an optimal strategy is like say figured out, and when you do all these things, your optimal strategy is there, and then that's what your trained system is.
In machine learning or deep learning, we use hyperparameters to get to a better accuracy of performance. Here, like you say, iterate until an optimal strategy is found.
Actually, I wrote already a hyperparameter, learning parameter here. That is one of the hyperparameters. Yeah, we have to tune. Okay, I did not name it because I have not introduced that term yet. Okay, but that is a hyperparameter. Makes sense, right? Can we go ahead? So, some of the components in reinforcement learning. One is reward. Okay, this reward will be coming again and again. Reward is nothing but a scalar quantity. Okay, it could be like say $rupees, dollar or rupees, right? Or it could be something like say punishment, right? Yeah. So, and our target is maximizing reward. By the way, no one will tell you what is the reward. Here, when you are actually going ahead to build your system, no one will tell what is the reward for your system. Completely unknown. Now you have to come up with your own reward definition. Okay, probably same problem whatever you are solving. Okay, you may have reward defined in one way, I may have reward defined in another way. So though we solve the same problem in like say in our ways, your set of optimal actions and my set of optimal actions for given a set of states will be different. Okay, probably to win the chess game, I may put the trap and then win. Okay, you don't like to actually lose those initial pawns. That's why you don't put the trap, but you may take a lot more steps to win the game. That's it. Okay. So target is going for like say maximum reward. Okay. So some of the standard examples for the reward. Okay. So this is just like say sample list. When you are actually building any solution for a given problem, you have to define your reward. Say for example, the dog receives a reward from a trainer for doing the activity what trainer expected. Okay, so probably that reward is something like say getting biscuit or not getting anything, second reward. Third is getting beatings and then getting call from Maneka Gandhi, right? So any of those things. Now like say getting beatings, the environment also has its limitations, right? It is not that it can actually do any actions whatever it wants to, right? So and then say for example, you have like say this auto driving helicopter, okay, and this man like say Andrew Ng from Stanford, his example is pretty famous, okay, for this one. I'll just play that, okay. You see now, first of all, taking off the helicopter, and you see like say how many states are possible in this one, and it has to balance. And this is like say he actually created this example on his own with his students. Self-flying. Okay, he set the target and now it will reach. So it will go and hit the land. That is actually like say serious punishment, right? So that action will not be performed again and again. it is just flying in the air there only. Now you set the target, instead of like say flying there only, going forward has higher reward. So it starts reaching the destination. Yeah, it should not fly upside down, those actions should be penalized. Andre NG is actually standing next to it. That video, like say, it is slightly bigger.
Program is running inside.
Exactly, that state action pair, optimal state action pair is actually running inside that one. Oh, you thought that it is remote helicopter. This helicopter is actually flying with reinforcement learning algorithm incorporated into it. Okay, and in fact, you can see like say his photo also next to it. You see, this is the man. You can actually see him actually doing all these experiments. This is the man we are talking about. Oh, okay, so that means we have to change our perception to some extent. Okay, our CEO Mohan K and Andre NG, they both were lab mates in their PhD days. Yeah, so this one like say flight maneuvers. Okay, now you see some particular desired like say reward, positive reward for doing the expected activity, going forward or flowing, like say being in the air, positive reward. Negative reward, sorry?
Reward or penalty both will be written in the actions column, right?
Exactly. Exactly. So reward, positive sign is positive reward, negative sign is penalty. But we normally don't call it as penalty per se, we say negative reward. Okay, and then you see like say default world champion in what do you say, backgammon or chess. Okay, initially you set a trap or like say and then win, or you have the following. Finally, whatever you have like say winning the game or losing the game is the reward. Okay, winning the game is positive reward, losing the game is negative reward. Okay, now manage an investment portfolio. Making money, if you make $1 money, positive reward. If you lose $1 money, negative reward. Right? And then controlling a power station. Now you have like say, if you are able to manage power efficiently, positive reward. Any security like say incidents, negative reward. Just giving an idea like say how do we define rewards. Each problem will have different rewards, a different kind of reward definition. Okay, and then how a humanoid robot can walk. How can you make a humanoid robot walk? Okay, exactly whatever we did with dog and baby. Exactly same like say repeat actions repetition. Okay, forward motion of humanoid is like say positive reward, and falling over negative reward. Okay, and then playing different games, different Atari games. Like say you have now systems playing games on their own, right? So that's what like exactly. Right? When actually systems start playing among themselves, they actually become like say pretty intelligent, and after some time we may actually find it very difficult for us to control. That's what actually happened in AlphaGo.
So how systems will understand if that is a negative reward or positive?
We are defining it. We are defining that it is okay. Very good. Okay, how do we define rewards in that helicopter case? Any guess?
Sensors. There should be sensors which actually measure the distance.
Exactly.
How close the distance is to the ground.
Exactly. You actually took the action now. Okay. So for example, tilting over, you actually took that action, and because of that action, what is the like say the altitude now you are in? If altitude falls, it is a negative reward.
But when we are going down, it needs to fall. The altitude needs to fall down, right?
That is the expected action. You reached the target, you reached the expected GPS. Okay, now you reached the expected GPS, so your altitude should start falling. Exactly, based on the environment or state. Based on the environment or state, your reward will differ.
So mathematically, this reward is nothing but some factor that multiplies into the weightage from a machine learning perspective.
Weightage, like say, weightage are like a function. It's a function which actually accumulates all your actions output. The better you actually capture all the output of actions, the better it becomes. I mean, your system will be far better. Make sense, right? Can we go ahead? So now you see like goals and actions, and this is another term what you actually come across. You need to have like say goals and actions, set of actions, and the like say short term goal and long term goal. Okay, short term goal is coming from here, and long term goal is like say yes, I want to win the game. Okay, how do we actually incorporate those things? And then state. We actually discussed about state quite a bit. What is a state? State is nothing but your environment perception. Environment perception. Okay, maybe the image what you have, your vehicle image whatever you have taken, along with all your vehicle's attributes. Makes sense, right? And this is what state is. And now where is the juice? I mean, where is the main information in reinforcement learning? The better you make the states and the better actions you make for those states. I mean, what are all possible actions? What are all possible states? If you can actually get all possible states for our environment or for our problem, now you can actually train your model very well. And this is where we actually get little bit greedy. Okay, how many states we can actually live with? Maybe 1,000. If you actually say 10,000, yes, now training time takes a lot of thing. Okay, and like say 1 million states, it's gone. Now we have to use like say bigger systems to train. Right? 1 million states possibly like say now we are able to see like all possible frames in the video. Right? All possible frames in the video you are able to, we are trying to see. And now the policy. This is what we discussed. Policy is nothing but for a given state, action is associated. Optimal policy is for a given state, optimal like say action is associated. Okay, these are the terminologies. What are the terminologies we have looked at? Reward, goals and actions, state, policy. These are the standard terminologies what we have, right? And now finally, so far we did not talk about model, how a model looks like. Okay, a model is nothing but agent's perception of the like say environment. Okay, and then this model includes the CSV file whatever we talked about. Okay, and in that CSV file, or like say if you actually go little more deeper, if you are able to predict what would be the next state as well, apart from action, possible action, you actually predict the next state as well. If you are in this present state, what is the probability that you will be in the next state? Okay, now you see you are getting into probability, right? What is the possibility that you will be in the next state? And that's what like say we end up into Markov chains, Markov decision processes. Today I don't introduce it, tomorrow I will introduce. In fact, reinforcement learning is introduced to first MDP, Markov decision processes are explained and then reinforcement learning comes. But if I actually talk about Markov decision process in the afternoon, everybody will be sleeping. Okay, and in fact for us to implement, we don't need MDP. We are practicing data scientists, right? And any of you want like say a theoretical understanding of this one, I am like say willing to discuss. And if at all like say offline you want to take it up, there is this man, this is the man, he actually leads AlphaGo project in DeepMind. And these lectures, he actually taught it in University College London. There are 10 lectures, each lecture approximately 1 hour 40 minutes. So around 14 hours. Well, definitely the stress testing, we are actually giving different state, which was not experienced earlier. And now you are trying to see how your system reacts. Yes, you are able to do that one. Yes, it's option. But you have to incorporate it into your system. If you give any new state, exactly, that state need to be identified with something which is already there. maybe using clustering, right? So like say this man is one of the celebrities in RL. Okay, so like you have enough material in his website, in his UCL website. Okay. Again, I am going back to my PPT. So his name is David Silver. Okay, and by the way, in his class he actually very frequently advertises, like say DeepMind is like say recruiting. If you people are interested, you can apply. And he is down to earth person. Like say when you actually listen to him, you feel like say, oh, I have to do this research. That sort of influence he has in his voice. Okay, now the framework what you were mentioning. Okay, yes, we talked about like say theoretical stuff, right? What we want to basically solve problems, right? And we basically wanted to have like say states defined, actions defined, and some way of like say training the system. Correct, right? And the framework for all these things, okay, the basic framework, it's not something like say scikit-learn. Actually scikit-learn spoils us. We expect all the comfort in life because of scikit-learn, right? So for this sort of RL algorithms, there are hardly any frameworks available, and this is one of the matured framework, and it has like say few examples through which we can actually develop the intuition, and if at all we want to deep dive, we have to write our own frameworks. Okay, so this is Open AI Gym. You can actually get into pip install gym and you can start using it. And like say document is not so great like in scikit-learn. Scikit-learn is pretty good documentation. How do we solve the problem? Like say we talked about the problems, but who worries about the problems unless we have a mechanism to solve it, right? So one of the algorithms people have proposed to solve these reinforcement learning problems, or like say problems of this kind. Okay, people actually proposed retraining the system or relearning the systems, reinforcement. Okay, and one of the algorithms is Q-learning. Okay, Q-learning is off policy. It actually doesn't start with any policy. We'll see what is Q-learning. Okay, it doesn't start with any policy. It doesn't have a model per se. Okay, the model it has is only like say you have this k nearest neighbors classification, right? In k nearest neighbor classification, what is the model? It's only k nearest classification. What is your daddy's name? Daddy. Right? There is no model per se except k equals to 3 or k equals to 10. Right?
The distance calculation.
Exactly. And in Q-learning, it's model free. You just have .csv file. As an output, you just have .csv file. That's it. Okay. So it is a model free. Off policy means it does not require to follow a specific policy while training. Okay, it actually looks at all states repeated times, and whenever you have like say good states, it actually starts accumulating positive reward, bad states negative reward. Okay, so that's what it does, and at the end it actually has the following: set of all states, set of all actions. As a data frame, you can put it, set of all states, set of all actions. You visit all the states for all the actions multiple times. If you are in state 1, say for example, you visit action 1. State 1, you performed action 1. Because of action 1, you may end up getting into state 4. So the cycle actually repeats. Right? So you actually start repeating this as like say information again and again. At some like say at some stage you actually converge. That means your Q table will not be these results, these values will not be getting updated much. That's what we call it as convergence. Okay. Now how do I use it in the production, or how do I actually say what is the best one? For state 1, whatever in the actions, whatever maximum value I have. Say for example, for state 1, I want to say index 0. For state 1, the best value is 0. So when I am in state 1, perform action 4. When I am in state, let me use indices only. When I am in state 0, like say index 0, perform action 4, index 1, perform action 5. And then when I am in like say state index 4, perform action 5. Okay, now I am getting states associated with optimal actions. Right? This table is repeatedly updated, and at the end I'll get this table, and then just like say when I actually say what is the argmax for each row, that will give me my action, optimal action. Argmax is nothing but maximum happening at that particular place. That index will be thrown out. Correct, right? So Q-learning basically prepares this table, and from that we basically prepare for optimal actions. That's it. And this is one of the simplest algorithms. And I feel like say RL is more natural than any other supervised or unsupervised learning. So you think that chatbot is simple, but for some other guy who actually has a lot of fancy thing with cars, he may think car is very good. Reason is like say like looking at the photo and identifying is much better than understanding some multiple languages. Right? Translating those languages will be difficult. And we have the habit of like say getting into multiple languages in the same sentence.
So how do you deal with, so the action might be different if the future state is going to be different?
So for example, if as of now I am in state index 0. Okay. Now I performed action, like say the optimal action in this one is index 4.
Right. What I'm saying is, let's say you're in state 0. The state can change because of my action. The state can also change because of the environment.
Exactly.
Right?
Yes.
So if there is, in the previous, one of the previous slides you said that there's also a possibility of predicting what the next state is.
Probability.
Right? Some probability.
Yes.
Now, knowing that, my action might actually change. Is there another dimension to this?
Improvement of these algorithms.
Correct. Okay.
Okay. So like say Q-learning is the starting algorithm. Okay. On top of this one, now we actually do like say all fancy stuff. Okay. So with rice, now we are actually getting like say just steamed rice cooking. Okay. From here you can actually make your biryani. Right? You can actually get a lot of recipes prepared on top of this one. But this is the base. Right? So at the end, now when you actually look at it, this problem like say, I think defining reinforcement learning is much easier than compared to any other supervised or unsupervised learning. It is very easy to actually see what is the problem. And it is very easy to actually define what is reward, what is state, what is action. Whatever you are saying, chatbot, maybe you are the right person to actually to define. You are putting the condition there. Right? So any questions? Yeah. So far it is fine, right? I actually gave an example. In general, what happens is when we start training the system, when you start training any reinforcement learning algorithm, you actually start with zeros. Your Q table starting with all are zeros. Okay, and from there onwards, you actually start updating.
And also, if you look at state 3, multiple zeros are there. Which action will you take?
Random action. Among all those zeros, among all those, like say, here you have like 1, 2, 3. Among these 3 actions, random action will be taken.
When we are starting with training, so this Q table, the size that you said S into A, do we already know how many states are there?
Yes, of course, then only we can train the system. If we don't know how many states are there, if you don't know the state, what is going to be there, okay, then what are the expected actions to train the system? Will be difficult, right?
But there are chances I may miss because there might be many scenarios.
Right? While the system is running, if it come across an unknown state, then it cannot act.
Basically, that's where you have k-means clustering to help quantization, right? This latest new state, which was not experienced in the history, is similar to so and so.
For instance, here you are rewarding when it is higher. Let's take the example of helicopter. So when you are going up the altitude height, then your height should increase. My reward state will be something based on that action. Now you reached a state. After that, it has to be reversed, right? So how do you identify that in Q learning?
So Q learning will not identify that. Okay, you are let me actually answer that one. The state where you are in, on the top, say for example this is state 0. Okay, when you are in state 0, whether your target is going straight and then coming down, if that is your target and this is what your state is now. Okay, the possible actions, it could be go forward, increase your altitude, decrease your altitude, right? These are like say turn left, turn right, or turn left. Any of these things, right? So say for example, if you actually say go forward in the same altitude, this is one of your actions. You are continuing, and then here, when you are here, you know, like say what is this GPS location? As soon as I reach that GPS location, my state is changing. Here it is not S0, it would be some S100. In S100, when I reach like say some 100 kilometers or like say 50 kilometers from my destination, now I start receding my altitude. That means not only going forward, altitude receding and then going forward is the action. Right? Otherwise, like say you are actually going forward and this is the like say bad action. You will not be able to take, you will not be able to land.
So if I have to make a matrix like that for this, how would I make this one?
So you don't make metrics of that kind. Okay, what you actually say is, say for example, total you have 100 states. Right? You have 100 states, 1 to 100. One of the actions, like say go straight, okay, back, down, up, okay. So these are my actions, right? I can actually say and when I am actually in the simulation, every time I repeatedly run this simulation, whenever I am in like say state 0, state 1, okay, state 2, whenever I am here, if I perform this action, this is negative some big number. Whenever I perform this action, this is negative big number, I am increasing the altitude. Whenever I perform this action, I am actually appreciating it. I do this activity again and again, right? When I am here and when I do this activity, going forward, I may end up with state 1. Here also I have to come, like say perform the same activity to get better reward. As soon as I reach S100, I cannot do this one, I will get negative reward. I have to actually perform this one. One of those actions will be performing for a given say state, but one of those actions will be the right one, others will be like say deviating, others will be wrong actions. Makes sense, right? Is it clear or not? Okay. Now, how do we update that Q table? Okay, that Q table, if I actually write it slightly differently, let me put it here. The equation, please don't worry, it may be distracting element. Okay, I will actually write it easily. This is your Q table, whatever we had earlier, right? That is nothing but Q of ST, or let me put it as SA. That is nothing but table with states, actions. Okay, this is nothing but Q of 0 state, 0 action. Q of like say 0 state and 5th action. There are only 5, like say 6 actions, for example. Like that, if there are 100 states, Q of 100 state, 0 action. Q of 100 states and 5th action. Okay. To start with, we actually start with all zeros here. Okay, initialization with all zeros. And now, how do we update? When I am in a state 0, and if I perform action 0, what is the reward? I may get 1 rupee as reward. Okay. So state 0, okay, and like say I am performing action 0, and that resultant is actually pushing me to state 3. The updation is going to be in state 3, right? So state 3, right? The updation, no, I have to actually repeat it. Because I have taken action 0, I got 1 rupee. The reward has to be updated in my present state 0 and action 0. Okay, so starting with it has already 0, 0. Okay, say for example my learning rate hyperparameter, let me take it as 1 for convenience. Okay, and the reward is 1 rupee. This is the reward I got. Okay, the discount factor, let me take it as 1 for time being. And this quantity I am looking at, like say in the next state, because of my action I am leading it to state 3. In state 3, what is the best reward possible? Starting with all zeros. So all will be 0 here, right? And old value of your present state is 0. So your latest value in Q 0, 0, state 0, action 0 will be 1. Right? And when you go for the next iteration, okay, again you are in queue of like say state 0 and action 0, your equation will be different. Actually, you will be actually leading to 2. Right? Are you following now? So this will be repeated. Positive actions, like say actions leading to positive rewards are getting accumulated. Negative rewards are getting accumulated, but negative side, yes.
Whatever it might be, like it might be sensors which are detecting what is going on in the environment, right? So it understands the state.
Yes.
But how does it detect reward?
Reward we have to define. Reward is defined by.
Because as these things are happening, how does the reward get interjected? How does the learning actually happen?
So that is what, again, one of the IPs you can generate. What is the best way to define a reward for my problem? There is no defined, like I said, there is no designated way of saying, okay, this is how we have to define for this problem.
How do people do it today? Like, do they do it as a post process? Like they capture state and action randomly and then assign rewards?
Yeah, say for example, let me see this standard problems where you can see quantitative reward. When I buy a stock, what is the reward? What is the return I am getting by the end of the day? Is my reward for that action?
Sure. Then it's formulaic. So I could write a formula for it.
Exactly.
Like for a drone getting to a destination, the reward might be
moving in the positive direction to moving in positive direction to the destination.
Keeps you oriented in that direction.
Okay. So you actually have to keep that momentum going. Okay. Say for example, if you are taking deviation, the taking deviation may be a trap. If you observe, okay, again we are going to the first example only because that latest one is in our mind, whatever happened, right? Our guys actually put a trap. There were like say a lot of flights, fighter jets. That was the news, right? There were a lot of fighter jets around Bhopal and other places. So enemy got trapped, right? So what is our like say loss? We actually spent good amount of resource and fuel. The win is reaching the target. Long-term target in the view, we actually lost a little bit in the starting. So now we have to actually define what is your reward. My reward is reaching the destination, hitting the enemy, and that may have like say $1 million as reward.
So learning can happen at 2 stages here. One is online or when the thing is actually being trained actively versus offline when the data is being collected. You might.
Oh, when no. Actually, that doesn't happen. Okay. The online whatever you are saying actually is part of training. The online whatever you are referring is actually training.
So which means you have to repeat it a lot of times.
Of course. That's where like say it takes time to build the system. And the better actually you train, the more robust it is. Yeah, we can actually give whatever nomenclature is possible to this baby. Because like say you have like say supervised learning as part of it, unsupervised learning as part of it, lot of ambiguity, Okay, and there is lot in your plate to define, right? So now there is like a good amount of literature around this this particular algorithm. Okay, and now like say some of you were asking like hyperparameters, and these are hyperparameters here. It could be any floating number. Okay, and whatever she was asking about, like say keeping track of that learning in this like say computation, actually this is getting accumulated, keeping track of the learning, exponential summing. Okay, at the end if you actually look at the equation, this actually comes out to be similar to this.
So does this also, like in deep learning, there is a problem of vanishing gradient and all these things? Same concept.
Here also all those like say bad guys will be coming in. We have to live with it. Okay, and we will be introducing some of them. This is what the updation mechanism is, Q table. Okay, now there are few parameters. You have learning rate, discount factor. Okay, when you actually look at the equation, the maximum of next state, okay, for all the possible actions, you are becoming greedy, right? For all the actions in the next state. Once you perform action on AT on ST, you will land up in ST plus 1 next state. Okay, what is the like say best action in that one? You are taking the maximum of that, and then you are giving discount factor. You don't want to be too greedy also, but you want to follow that one, like say long term target, right? And then old value versus new value, how much you want to basically take it up, right? Old value, this is old value, and this is like say learning rate. You may take alpha equals to 1. When you take alpha equals to 1, this value and this value gets cancelled, right? And you are going ahead with the latest RT plus 1. That means your present ST80 values are replaced with RT plus 1, AT plus 1. So you are becoming more and more, what do you say, short term sighted, greedy. You are not keeping track of history to the greater extent, right? So that we may not want that one. So you want little bit of learning happening, little bit of the, what do you say, history keeping with you. So alpha equals to close to 1, you are actually saying history doesn't matter to me. Alpha close to 0, history matters to me a lot than present. Fine. And then discount factor, how much greedy you want to become. Like say looking at like say next moment I want to actually win. I never want to lose even 1 rupee. Then your discount factor is 1. Training this model and getting the optimal numbers is going to be a nightmare when it comes to computation. Correct, right? Is not so straightforward. It takes good amount of computing power. Say for example, one reinforcement learning convergence, I mean one model convergence, if it is taking like say 1 week, for 100 parameter combinations, now we have to take cloud subscription and then like say in independent manner, you actually train all those 100 reinforcement learning models and see like how your system is performing. And that's how you actually decide the learning parameter. You have something called grid search, right? In machine learning. Okay. So similar approach you have to follow here as well. But of available libraries, straightforward available libraries, there is no one. There is no library. You have to write your own wrapper. Okay. And then the main steps in this algorithm. Okay, there are 9 main steps. Okay, it is something like after actually you come to second step, perform third, like say 3 to 9. That's what you say. And once you come to 5 to like say fourth step, perform 5 to 8. Okay, it's actually loop, for loops. Right? You start with initialize all states and actions, the Q table to 0. Okay, for all episodes, in the sense I have like say episode 1. I actually, in that episode 1, I tried to walk through set of all possible states and actions again and again. I have my Q table prepared. Now I take that prepared Q table as my starting state, and again I start next episode. Okay. In the given episode, I set my time step as something like say 1000. I will be revisiting different states 1000 times. Okay, and then next episode again 1000 times. Like that I will be actually repeating, and then finally my Q table will be getting updated. Fine. So this is what the learning process in what do you say, Q learning. And when you actually look at this Q learning, oh, it is so simple, right? Actually hard work is hidden here. States and actions preparation. State action, yeah, states preparation is hidden. That's where actually all our blood will be squeezed. Okay, the IP is state preparation. Q learning is known to everyone. Now, different variants of Q learning also people know now. Okay, why people actually don't venture into reinforcement learning straight away is there is no framework available to learn, right? Something like say baby problems, like say toy problems, whatever we are working, they may not carry much value in the industry unless you solve a case, business case, right? So that's why many people don't venture into this reinforcement learning. There are like say sparse groups in India. One is IISc computer science and ECE department. You have like say a couple of guys working there. IITB, you have a couple of guys working there. Okay, TAFR, some theoretical people are there, but not implementation level. And that's it as far as academic institutes are concerned in India. Okay, people focusing on these areas. And like say, there are a lot of people who actually associate themselves to RL and say we are RL data scientists. I doubt. Okay, reason is like say they are not practitioners, they are not theoretical people. They are neither on neither side. Without working with the data, implementation of RL doesn't make sense, right? So you are not on the other side. I mean, not practicing. Without getting into like say that Markov decision process and deriving algorithms, theoretical side you don't have value. That's what I mean. Now let us start with a simple example. Smart taxi. This is well celebrated example like our iris dataset. Iris dataset in reinforcement learning you can call it as like say smart taxi, and the next one is like say walking in a frozen lake. Saving yourself when you are walking in frozen lake. Frozen lake, not everything is frozen. There will be some like say semi-solid. If you step onto that one, now how do you survive walking in that frozen lake? That is the second problem you will be solving. Okay, so here smart taxi. So here what the guy has to do is, the guy I mean to say your agent has to pick up passenger from like say pick up location, and here passenger should be dropped at designated location. Okay, for every pickup now you have to define a reward. For every drop you have to define a reward. For every other action you have to define a reward. It's in your hand. You are fine, right? The task is we have to pick up a like say passenger, drop him. That is the task. And you want to basically teach the like say taxi to do this one. The next one is take care of passenger safety. Don't hit any divider or don't hit any, what do you say, yeah, obstacles. Okay, this is the problem like say what some of you are asking, like say if unknown situation is coming, how do I handle? As of now you have to actually fall back to your old friend k-means, state aggregation, that's it, right? So the rewards for every drop, for every proper pickup, you have to appreciate with some big reward. For every proper drop, you have to appreciate with big reward. For every, here time is important. Okay, you pick up and you drop next day. For like say from here to like say Koramangala, like Majestic. Okay, it's also perfect drop, but you are losing out time. You should penalize. Right? So for every other step, if you are not reaching the target, there should be some time, like say penalty. Right? That's also reward. That may be very marginal over the period of time. If that is happening, like say you are actually getting stuck, so your taxi is getting penalized. So he doesn't want to do that activity again and again. I mean, same repetition, like say he may actually stop at one place and sleep, and that is penalized. Right? So since he is penalized, he doesn't want to do that activity again. But all those like say penalties, now we have to define seriousness of the penalty. Hitting the divider is serious penalty. Okay, as of now in the simulation environment, penalties are equated to 1. Every time whenever there is a penalty, it is actually added, the reward is -1. Whenever proper passenger is picked up, reward is 20, drop 20. Okay, and we can actually redefine those things when we are coding. By default these values are there. So now we are getting the reward meaning, right? So for proper pickup, big reward. For proper drop up, big reward. Roaming around freely, penalty. After picking up, if you are not reaching the destination in shorter time, for every move you are actually penalizing. Trying to visualize now how the solution looks like. Right? Now you have to see the environment and then discretize it. Right? Say for example, you are in a parking lot. You have to visualize your system. Okay, this is what like say the rectangle I have in front of me. Let me discretize that rectangle into 5 by 5 square. The taxi can be in any of these 5 by 5 square. Okay, the drop and the pickup locations could be anywhere in these things. Okay, there are 4 locations where it could be drop, it could be pickup as well. Right? Right? Now basically if it is the pickup location, this guy has to directly come here, pick up and then drop here. For any unnecessary roaming, this guy will be penalized. And the middle bars, whatever you have, these are obstacles. You have separator, and if a cab is in the present location where it is, what it can actually do, it can actually go north, east, south. It cannot go west. Am I correct? Either you use like say northwest, south, west, north, west, east, or you use like say up, down, left, right. Right? So if it actually takes this side, it is serious negative. That reward you can redefine. Right? And when you are actually penalizing this sort of wrong activities, these activities will not be repeated in future with high probability. If you are not penalizing, okay, it is sotomata. We can actually repeat again same mistake. Right? So this is what the environment. Environment is now, I have taken the picture. I have now got the like say 5 by 5 grid on top of it. Now how many states are possible in this one? 25 states, and there are 4 locations to be picked up. RB, YG. Okay, RG, YB. 25 and these 5, these 4 in different 5 into 5, and there are 4 locations. You are getting into tensor now. If a person is in the cab, that cab location also can actually go to any of these things, right? Right? So say for example, I am greedy.
There are obstacles, right? So I mean,
Obstacle, now of course I can actually increase the complexity. I can increase the complexity. That obstacle is not in the middle of the road. That's what I'm actually pursuing. It's actually, these are roads. Obstacle is not in the middle of the road. Okay, but like say if there are multiple lanes, okay, and there is like say divide, left and right turns are possible, okay, or like say some animal is walking, that is obstacle, right? It can be in the middle of the road. So 5x5 grid, fine, and you have 4 drop or pickup locations. That means totally you have like say 25 into 4, right? And then once your person is in the cab, the passenger is in the cab, okay, he can be anywhere in this location, right? He is picked up here. Now cab location also is important, right? Cab is in 00, 01, 02, 03. Cab location, you need to keep track of it, and it is actually moving in 1 dimension. In 1 dimension you have like say 5 grids, right? You already have one like say x-axis, your cab is y-axis, it can have 5 values. Let me say how it is. Say for example, my, what do you say, I am in 00 location. Let me start, the least one, left hand side bottom is 00. Fine. And then the person who is like say whether the passenger is there or not, the not passenger, pickup location is there or not, 0 or 1. Let me say Y. Yes, he is there, right? And then here it could be cab, okay, whether cab is there or not.
So this RG may be on locations.
Locations. Passenger can get into the get into cab at these locations, get out of cab at these locations. This is one, this is one, this is one, and this is one. These are not visible, little bit gray.
Yeah, light gray.
Light gray. In my next one, it will be clear. Okay. So now you actually try to say, for example, if it is here, I am here. The cab can be here or here, right? So when I am here, cab location I am looking at. When I am here, what is the cab location? Cab location, cab location, cab location. Okay. For x value, what is the y value? Y value is cab location.
5 into 5 into 25 C4 is what? Because these 4, these are already fixed, right? RGYB.
RGYB locations are already fixed. That's why 4 locations.
Into 4 because whether people will be there or not.
Will be there or not, the choice is either 0 or 1. Okay. Whether person, like say your cab can go there or not, whether person is there or not. See, I am here, x-axis. Okay. Now I am actually looking at the y-axis. Where is the cab? Cab could be at 00. Cab could be at 01.
Oh, because the first one is fixed.
First one is fixed. Your x-axis is fixed. You are fixing x-axis where your like say cab in the y-axis. Okay, that's why like say independent values are 5. I am saying like say when I am in this place, where is the cab? Okay, whether it is in 01, 011, 012, 013 or not, yes or no. 5 values are possible. Next one, okay. So I am fixing the x-axis. Actually for cab 25 values are possible. In one of these 25 locations it can be there. Okay. Now say for example if I fix x-axis at 00, whether on x-axis 0, whether it is there. Now I have only 5 y values varying. Okay. So that's why I am taking like say 5. Right. So in fact I can actually go a little more complex. I can actually define like say a lot more things. Okay. This is the simplest grid I can define. Simplest grid I can define. From here onwards, I can actually say like one dimension is, this is like say x, y, this is like say passenger location, okay, and this could be taxi location, right? 4 dimensions. Agree with me? And now I can actually get into, like, say, this, to make it more spicy, I can actually say, like, say, this cap can be in any of these things. Instead of 5 independent variables, or 5 independent degrees, let me say 25 degrees. Okay, I am actually increasing the complexity. Okay, let me say now I have only this many states. How many states that will come?
500.
500. Simple problem, 500 states. And in fact, here we actually reduced complexity. If you actually go for the complexity, like say, yes, I want to basically, I don't want to fix this location also. Okay, I want to basically get, like, say, all the coordinates without any aggregation. I'll get not 500, 2500 states. That action is not defined. Actually, you can actually define, like, because there is no lane discipline. Obstacle is actually in the middle, not in the middle of the road. It is actually in the side. Yeah, we can actually define a lot of actions, but we need to change the, like, say, ecosystem in that case. Okay, say for example, in the simulation mode, this is how it will be. The yellow one is cab. Okay, the yellow one is the cab. It is jumping all over the place, right? And you see, for everything, whenever it actually comes to, like, say, either pickup or drop location, the reward is 10. You can redefine. Okay, otherwise reward is, like, say, -1. If you are not at one of these 4 locations, reward is -1. If you are at one of these 4 locations,
let's say there is a 5 by 5 grid.
Yes.
The passenger is at location 1.
Yes.
The cab is at another location.
Yes.
So we are looking at the possible 5 by 5 makes sense. Either the cab is at the place where the passenger is standing,
okay,
or it can be in any of the other 24 positions.
Okay.
So the total thing is 5 by 5.
I want to represent this particular scenario.
So where the cab is there.
Exactly.
And where is the passenger?
I'll come to that one. Okay, where the cab is, let me say that is on index 1, 1.
No, that is 1, 3. X is 1 and
If
Y
I
is
actually
3.
come from 0 to up, any convention, either coming from bottom to top or top to bottom. Okay, I have 1, 1. And then how do I represent cab? Cab, I'm, like, say, this is the location. Okay, once I have this location, okay, now cab location is there. Okay, that is the cab location. I have to now represent the passenger location. If passenger is inside the cab, okay, and then how do I actually give the notation? Okay, say
either a 0 or 1.
0 or 1. Okay, whether he is inside the cab or he is not inside the cab, right?
And then the destination. Now the destination could be any of the 24, because if that 1, 1 the cab is there, let's take this case. 1, 1 the cab is there, the passenger is also there. So we say that 1, 1, 1. 1 indicates the passenger is in the cab.
Okay.
Now and now the cab can go to any of the places. Now instead of all the 24, you said there are only 4 drop locations.
Yeah, we are actually giving, like, say, limited, like, say, destinations or starting positions.
So then we can indicate that, you know, the destination is in any of those 4 locations.
Yes. Okay. Let me say you have, like, 5 by 5. This is your grid. These are 4 locations. 4 locations. Okay. And now once the, like, say, passenger is inside the cab. No, this is actually just location. 4 locations. Okay. Once passenger is inside the cab, okay, you have fixed one dimension. He is inside the cab. Okay. He either has to go from here to here or here to here. Right? So your x-axis, one dimension you are fixing. It is something like when you say your x1, x2, you have, and you are writing now hyperplane. Say x1 plus, or let me say x1 equals to x2 plus c. You have fixed x1. What is x1 for given x2? It is hyperplane. Once you picked up the passenger, you are either going from this side to this side, this side to this side. Only five positions are possible. You are fixing one. Say for example, if I pick up that passenger here, it can go this side 5 locations, or this side 5 locations. Only 5 positions are possible. You see, that's what hyperplane I am giving.
Okay, 24 positions are possible. He can go left, right, up, down.
Those left, down, up, down, like say left, right, up, down. Okay, those things are actually we are getting from here. Okay, the thing what we actually have to see is maximum number of states versus what are the minimum number of states possible. What are the minimum number of states possible? If you actually look at this hyperplane, x1 plus x2, 2-dimensional, 5 by 5. Okay. Now we are saying like say x1 equals to x2 plus c. That is the hyperplane. Okay. What is that hyperplane dimension? It is 1. You started with 2 dimension, x1 comma x2. Hyperplane in any dimension is n minus 1. If dimension of your space is n, hyperplane will be in n minus 1. Okay. Now why it is actually coming out to be 5 is, if you picked up here, the maximum number of possibilities, it can actually move this side or this side. Picked up location is 1 and rest of the 4 possibilities are 4. Like say 1, 2, 3, 4. Of course it actually hits obstacle, so it has to come this way and come this side. The maximum y values possible for this one are 0 to 4. Once I fix x, that's exactly what happens in hyperplane. Okay. Yes, I can actually worry about all 25. That extra, like say duplicate feature I can add, and in that case, I can actually end up with 2500 states. 2500 states I will end up with. Okay. I don't need to have those 2500 states. With just 500 states I can actually replicate. That's what I mean by. Okay. If I have these 500 states, what will happen? Okay. Now this is what like say simulation. It is actually, cab is actually moving in all directions, all possible directions. Okay. And respectively, like say you are actually getting either reward or penalty. I mean negative reward is penalty. Make sense? So yes. So whenever you are actually moving from one location to another one, you see your reward, this is what your Q table is getting updated with. Okay, right? And now you start your Q table as like say 0 zeros, right? And then for every like say episode and for designated time and number of time steps, you actually start updating your Q table with the formula whatever we actually started with. Q of STAT equals to Q of STAT plus your learning rate with all that masala, right? And that's what like say this particular use case is. Okay. Now let us go to the, what do you say, the simulation and see how it exactly works. Can we please open this Jupyter notebook? And by the way, if you want to implement this one on your own without any framework, it will consume time, but it's not too difficult. Teach a cab to pick up and drop passengers at their right locations with RL. Okay, so we are not clearly saying like say this is pickup and this is drop. Okay, what we are actually trying to tell is whenever you touch base it with one of these data points, I mean one of these locations, you are avoiding. In fact, this is not a full-fledged implementation, I should call, right? Whenever you actually pick up, only drop is possible, right? We have to actually get all those logics incorporated. Now, so you can like say install GIM using pip install GIM. That's what I actually did, right? And it works with Python 3. It works very well. Python 3.5 and above. On Python 2 also it works, but I hardly used Python 2 and GIM. Okay, now I am loading this taxi environment. Okay, when I load this taxi environment, it is actually giving me those states and actions description. Okay, what are all states, what are all actions, what are all rewards I mentioned. Okay, that is the information I am actually getting. Okay, so for some of the problems, and now actually it is pretty active. People started loading even this humanoid robo walking. That environment also people actually uploaded now to GIM. Okay, and then so I'm resetting it to a particular like say random state, because cab can be any of the 25 locations, right? So I'm resetting it to a particular location. Okay, by the way, when you actually look at these states, they are not now represented with coordinates, they are actually given numbers 0, 1 to 499. Okay, so the state what we are actually getting is 201. Oh, that was earlier one. Okay, then now cab is at the third location. Number of elements in observation space, number of states 500. Okay, and now if I actually see the state, this 3 state is actually coming out here. Okay, 3 state is represented like this. I was actually one step ahead. I was actually reading out previous one. Okay, and now for this the state is 3. Anyway, we already rendered. This I'll remove. The possible actions are 0 down, 1 up, right 2, left 3, pick up 4, drop 5. 0, 1 to 5. Totally 6 actions possible. Right? So now if you see number of actions possible 6 and number of states 500. Let me take like say let me set state to 114. Okay, what the state would look like? The cab is at this location. Okay, and now when I actually do like say what is the next state, when my present state is 1, what is the next state? Okay, actually it is not my my present state is 3. Okay, I started with present state equals to 3, right? And I am performing action 1, 0, 1 to 5. I am performing action 1. Then what is the resulting state? The reward, whether you reached the destination. No, you have not reached. Okay, and then the other things like say probability 1.0, those are like say values for the debugging. As of now, they don't carry much information. You can actually start adding your debugging information there. Okay, say for example, if I say action equals to 5. Okay, action equals to 4. Minus 100. Sorry, minus 10. Right? So you are seriously penalizing. Probably you hit the wall with this action. Right? So action equals to 4 refers to pickup. Okay, that was not possible. So you are basically missing something there. Now, how good does behaving randomly help? Okay, say for example, I don't get into the queue learning per se. I have like say state, and I am putting the counter, and I have a reward. I emptied it. Okay, I start at one location. Let me put some what do you say, 1,000 steps, and see whether I will be able to reach the destination. And what would be the reward? Like say reward to reach the destination, pick up and then drop. Okay, in how many time steps I am setting like say maximum 1,000. In how many time steps I will be actually able to pick up the passenger and drop him. And what is my reward?
So just going up, right? 0 to 5, 0 to 4. Are you presetting those?
Exactly.
Okay.
When we loaded the taxi environment, all these things are preloaded. Okay, we have to write it on our own. So what I am saying is, unless reward equals to 20, or actually keep on going this one. Okay, till I actually get the final destination. Okay, in how many steps I did solve this one? In 562 steps. Okay, I am using while loop, so there is no limit on the steps, but in general, for the next step, you see when I am doing, it took 2126 steps to pick up a passenger and drop him. Okay, and now let us get into queue learning way of doing things. So I can actually, so whenever you are not actually dropping the passenger, reward is not 20. When you are picking up the passenger, it is taking reward as 10. When you are hitting the wall, your reward is minus 10. So when you are hitting reward equals to 20, that means you are reaching the destination. Okay, I actually clicked those three quickly. That is like say reward equals to 20. I am saying like say whether you have dropped it or not properly. Queue table I am setting it to 0 zeros, and then I am saying like say number of episodes. Let me actually run only once. So I am keeping a like say reward accumulator g equals to 0, and then learning parameter alpha equals to 0.6. Some number I am starting with. Okay, and then you see here my gamma, the discount parameter I am taking it as 1 in my equation. Only alpha I am varying. Otherwise, this is the same equation what we are actually having, right? There is no deviation. Okay, so for episode, I am saying like say, while reward is not equals to 20, take the action. You are actually, this is the state, take the action, best action from the table, and then you are saying like say environment dot step of action, best action, and for that best action, what was the reward? You are repeating it till your reward is 20. Okay, right? I can use while loop, or I can actually put timestamp, 1,000 time steps, or counter, right? So my initial state is 187, and final state is, let me print that one, 475. Okay, what is the reward? Total reward minus 518. It's very bad. That means I took lot of time Okay, I took lot of time. I actually trained the system only once, episode equals to 1. I did not train multiple times, right? I trained only once, episode equals to 1. Once passenger was picked up and he was dropped, that's it. Okay, so what I'm actually now going to do is, I'm going to set episodes 2000. Okay, now we started with minus 77 reward, and finally we are actually more or less stable with an like say reward value. Okay, now we got our Q table prepared. Q table prepared, we actually ran 2000 iterations. Okay, now let us see whether we are able to pick up and drop. Okay, so what we are doing is, I am picking up a random state equals to environment dot reset. Okay, whether we are done, no, we are saying like say not done. Okay, done not equals to true, action equals to the best action for the given state. Okay, and using this action, now your environment is giving the next state. Okay, next state, the respective reward, whether you have reached the destination or not, done or not. Okay, earlier you were actually comparing reward equals to 20, right? Reward equals to 20 or done equals to true. You are done or not, right? So reset the system, and then now you see cab is here. Okay, it is asked to actually move north. Move north, there is it could not move, it could not go upward. And the next one is move east, it moved east, picked up. Okay, and then the action, you are at the place, it picked up the passenger, that is the action. Okay, and after that it is asking like say to move south. Okay, and then it is asking to move west, no, south, and then finally drop off. Okay, you are actually defining the environment. And see, when you actually trained with one episode, you are not actually, it did not actually perform so well. Of course, we did not test it in this way, but as soon as we actually did that Q table learning, the cab is able to actually do its job. And it looks very, very simple, but if you see the complexity, the defining the number of states, right? For each state, now you have to say like say what are the possible actions, and based on that now you have to define the reward, right? Whether you want to go ahead with 500 states or you want to go ahead with 2500 states, right? And then you basically define your rewards based on that one. Okay, if so and so category of states reward is -1, so and so category of states reward equals to bigger. Okay, now let me actually add little more spice to this one. So we have this one here, right? Done not equals to true. What I try to do is, if done not equals to true and reward equals to 0, reward equals to -1, okay, I want to basically penalize it to higher number. Okay, if reward equal to like say -1 or reward equals to minus 100. I am penalizing a lot, okay, for not doing the activity correctly. I am rewriting this one, okay. So let me get this Q table again. So I am initializing Q table to 0. Episodes I am setting it to 2000. See, initially started doing badly, and over the period of time it actually started learning. Okay, now let me see what is the initial state. Now also it is doing very well, right? It actually started with this is the initial pickup, initial place, right? Picked up and then immediately moved upside. Because my penalties, I am actually seriously penalizing the guy for not doing the activity. Now, say for example, instead of 2000 episodes, let me set episodes equals to 100. Because number of episodes, when you are increasing, it is expensive computationally. Let me set episodes equals to 100. Let us see how good it will be. You see, now since it worked straight away, we were actually very happy. Now you see, you are here and it is asking to go west. But it cannot go west because there is wall there. When you are here, you cannot actually suggest west. There is a wall. So it is standing there only, and you see, and those actions are repeated. Infinite loop. No, it could not solve the problem. Even after, like say, 100 episodes, it actually got into a loop. It could not solve, right? Let me actually penalize less. See what happens. Or in fact, the state may be, I can change the state. No, with 100 episodes, we are not able to get solve the problem. It is still there only. Let me say like, we are not able to actually converge when you have number of episodes equals to small. No, it's not able to actually solve the problem. It is getting stuck at some place. Now let me, instead of 100, let me say 1000, whether we will be able to do. Yeah. Any, like say, any of these 4 locations, starting one, if you visit one as a pickup, it can visit any of these 4 locations, that will be pickup. Any of these 4 locations after that, okay, once you pick up, it has to go to other location for the drop.
And then where are those obstacles put in here? Sorry, I missed that part probably.
You see here?
No. In the code, where did we mention those?
Okay, so the rewards. Say for example, let me actually I understand your question. Okay, I actually got slightly deviated. The obstacles, when we actually mention, we are talking about states, right? When I am in a particular state here, like say west is not possible.
Yeah, where did we mention those?
The environment we loaded. the environment we loaded, okay, that is where we mentioned, and no, we don't mention, the environment already mentioned and gave us.
So this is like a pre-environment loaded environment.
Exactly. And when you actually, here when you take each action, state will be there only, but you are getting penalized. Okay, that's why like say, you are actually hitting west and west, there only you are standing.
So when we say taxi-v2, that's the environment with those already loaded in the...
Exactly. And now, as a data scientist, what is our value add? Our value add is creating these environments. Solving, once we have environment, I mean to say, once we have states properly defined, rewards defined, actions defined, solving is pre-learning. That's it, very simple. Right? But preparing this one, preparing that environment is like a problem dependent. Whatever environment I prepare for my problem, you may not be able to use it. Okay, that is the challenge. We have to live with it.
Can you see how the data in the environment looks like here in this problem?
Yeah, we can actually go to that, like say open AI gym, complete source code is available. Yeah, we actually loaded from OpenAI gym. Say for example, OpenAI gym, GitHub. All the source code, everything is available. Okay. Complete thing is open source, and now people actually if you want to redefine, like say if you want to define your own environment in labs, what people are doing is the existing environment is adopted, like say taxi environment I take, and then do modifications for my own data. Okay, because already like say how states, actions and rewards to be combined. It's already defined in this one. So let me take that as a template and then do it for my problem. Okay, so if at all you want to use this framework, you have to modify it that way. But the best way is write your own states and actions outside, that will have far better control.
We hope you liked this complete tutorial on machine learning and Python. Great Learning offers high quality, impactful, and industry relevant programs to working professionals like you. Our faculty pool comprises of leading academicians and industry practitioners in the field of data analytics. For more information, check the links in the description down below. Don't forget to like, share, and subscribe. Remember, the only learning that matters is great learning. See you in our next video.